नाही. काळीवाली आज आहे का गेली बघ बरं.
बघितले नाही मी क्लिप ना.
हं?
क्लिप माझी विसरली.
नाही. काळीवाली आज आहे का गेली बघ बरं.
बघितले नाही मी क्लिप ना.
हं?
क्लिप माझी विसरली.
नाही.
गुड मॉर्निंग एवरीवन, एम आई ऑडिबल? मेरी आवाज आ रही है सभी को?
गुड मॉर्निंग यादव जी। आ रही है।
थैंक यू सर, थैंक यू। आज मोबाइल का दिन है। आज अब मेरी आवाज ठीक ज्यादा आ रही होगी। आज मोबाइल का दिन है।
गुड मॉर्निंग सर।
मॉर्निंग मॉर्निंग मॉर्निंग। अभी मैं अटेंडेंस सेट शेयर कर देता हूँ और करीब 10:15 बजे पेपर शुरू, आपका ये क्लास शुरू होगी। ठीक है। तो सबको एक बार आज मैं लास्ट दिन भी है तो एक बार बेस्ट विशेष बोलूंगा। और सभी लोग एजीएम बने, बधाई हो एडवांस में। जो लोग बन रहे हैं और बनेंगे ही सभी लोग। ठीक है। तो अभी मैं अटेंडेंस शीट और सारे शेयर कर देता हूँ। शेड्यूल मैंने ऑलरेडी शेयर किया हुआ है, मैं दोबारा से लिख
सर
देता हूँ।
ट्रेनिंग एक्सटेंड करवा दीजिएगा। फीडबैक दीजिए, 5 दिन काफी नहीं है।
5 दिन काफी तो है ही नहीं सर। वो 5 दिन के लिए तो मतलब ही नहीं है। अगर 5 दिन में पढ़ के अगर सब वो बन जाते तो फिर तो सारे लोग ही बन जाते। अब ये
सर
तो
ट्रेनिंग
टैलेंट देखना
एक्सटेंड
है।
एक्सटेंड कराओ सर ट्रेनिंग को।
एक्सटेंड कहाँ कराओगे? अगला हर पूरे महीने शेड्यूल है एग्जाम का। तो सारे बैच का, सिविल का भी है, इलेक्ट्रिकल का भी है। बाकी देखते हैं। रिकॉर्डिंग तो हमने पूरी दे दी है सारी आपके सामने।
हम्म।
ठीक है ना? बाकी आपके क्लास इंचार्ज हैं और बाकी एक बार एनालिसिस किया जाएगा। अगर लोग मौका लगा तो फिर से करेंगे।
सर ये जो यूट्यूब पे अपलोड किया है, ये चैप्टर एज इट इज रहेंगे ना? लिंक अवेलेबल रहेगा?
तक एग्जाम नहीं खत्म होगा तब तक मुझे बोला गया रखना है तो मैं रखूंगा तब तक।
ठीक है, थैंक यू।
ठीक है ना? तब तक आप आराम से उसको रखिए, कोई दिक्कत नहीं आगे। बस मैं उसको एडिट भी इसलिए नहीं कर रहा हूँ, कोई ये ना कहे कि हमने ट्रेनिंग नहीं ली तो पता नहीं क्या पढ़ाया। तो जो है जो करते हो मैंने इसको शेयर कर दिया कि इतने देर वेट करना पड़ा है, इतने दिन ब्रेक है। मैं तो एडिट करना मेरे लिए बहुत आसान है। उसमें यूट्यूब में तो बहुत आसानी से हो जाता है आज की डेट में। ठीक है।
सर एग्जाम नहीं, सर रिजल्ट तक रखना है इसको।
रिजल्ट तक रखना है वो
हम्म।
मैं पूछ लूंगा। फिलहाल तो एग्जाम तक के लिए है। ठीक है। बाकी देखते हैं। ये मैं मैसेज आपके उसमें पूरा शेयर कर रहा हूँ। इसमें टॉपिक क्या कवर होंगे, अटेंडेंस शीट, यूट्यूब की लिंक और सारी चीज़ें आपका इसके अंदर जा रही है। ये मैंने चैट के बाद में भी डाल दिया है कि आपको ये ज़्यादा स्लो हो रहा है। जो अटेंडेंस शीट है कोशिश करिए हर हाल में 11:30 बजे तक भर जाए। ठीक है ना? अभी हमने आपको शेयर किया है, अलग से भी मैं शेयर कर देता हूँ। और जो भी आपके साथी लेट आए उनको भी आप शेयर कर दीजिए। जो क्योंकि बीच में क्या होता है कि जो बाद में आते हैं यूट्यूब में तो क्या होता है, पढ़ा होता है, इसमें पढ़ा नहीं होता। ठीक है। तो फिर मिलते हैं क्लास सेशन स्टार्ट होने पर। अभी के लिए मेरी तरफ से थैंक यू एंड बाय बाय।
सॉरी।
बेटा शुरू कर, कब पढ़ेगा बाबू? बेटा एकदम सीरियस हो पढ़, मैं सुनूंगा, लाइट बंद करके बात सुनता है।
कर रहा हूँ, पहले आपका था आप शेयर वेलकम बैक। आप सभी का एक बार मैं हार्दिक स्वागत करता हूं। हमारे सेशन को चालू करने के लिए पहला जो सेशन है सैटेलाइट कम्युनिकेशन का है। इसकी शुरुआत करने के लिए हमारे बीच में मनोज नागर सर मौजूद हो चुके हैं। तो एलटीटीसी के बिहाफ पे, आप सभी के बिहाफ पे मैं उनका स्वागत करता हूं और पूरा सेशन उनको हैंड ओवर करता हूं और 5 मिनट के अंदर वो सेशन को स्टार्ट करेंगे। तो ऑन बिहाफ ऑफ एलटीटीसी, मनोज नागर सर, यू आर वेलकम टू ईयर। और उम्मीद करता हूँ कि जो आप सैटेलाइट जो बताएं उनमें से बहुत सारे क्वेश्चन आ जाए। ठीक है, सबकी उम्मीदें रहती है। ठीक है, तो अभी आपसे 5 मिनट के अंदर ये चालू करेंगे, बल्कि हैंड ओवर कर दिया मैंने सर को। यस सर। अच्छा अच्छा। Hello, kindly confirm, am I audible? Okay, okay, thank you, sir. So, welcome to the session on overview of satellite communication, VSAT, DSPT, and Inmarsat. So, I think all of you are here, so we can start the session. So, in this session, first we will discuss about this overview of satellite communication. So, actually, we have to cover the entire session within 75 minutes. So, we will discuss the things in brief. So regarding overview of the satellite communication, so already we are having the landline communication, we are using the mobile communication, but nowadays we are more interested in the satellite communication. So some reasons are there. So I will cover only the important points. No? So nowadays we are more interested in the satellite communication. So some reasons are there. So first reason is that in case of satellite communication, we are having the large coverage. In fact, with the help of the single satellite, we can cover the entire nation. And if we compare it with mobile communication, so in case of mobile communication, what is there?
to give the coverage in the entire nation, we need lakhs of BTS. हमको कई लाख BTS चाहिए, hundreds of BSc, hundreds of MSc, HLR, VLR. So much hardware is needed in case of the mobile communication to give the pan-India coverage. But in case of satellite communication, with the help of single satellite, we can cover the entire nation. So that is the biggest advantage to use the satellite communication. Second point is that in case of emergencies, suppose some emergency is there or some natural calamity or natural disaster is there, flood is there, earthquake is there. So in that case, what will happen? Our landline as well as our mobile communication, it may come down. But the satellite communication, it will work. So we can use the satellite communication in case of the some emergency situation. Third one is that in case of the hard terrain area like the sir ये बंद कर दीजिए आप इधर से. Please wait for 1 minute. Also, in case of some, also in the hard terrain area like the hilly area, J&K, Northeast, Himachal Pradesh, Uttarakhand, where we cannot lay down the optical fiber cable. So in that case, for this backhaul connectivity, we can use the satellite communication. So these are the some reasons due to which we are nowadays more interested in the satellite communication. Then in case of satellite, what is there? We are having, I will again cover these points. In case of SATCOM, what is there? We are having two subsystems. So if I draw it here now, in case of satellite communication, we are having two subsystems are there. So first one is the ground segment, and second one is the space segment. So on the ground segment, we are having the earth station or the hub like this. Now, suppose this is your earth station. This is the ES. If I draw it here, this is the earth station ES. And suppose this is some end user. This is some end user like this. So this is the ground segment. So on the ground segment, we are having earth station. The second name of the earth station is the hub. And suppose this is the end user. So they are available on the earth or on the ground segment. In the space segment, we are having the satellite. Suppose this is the space segment, and in the space segment, we are having the satellite. So this is the satellite like this. So at the end of the satellite, the important component is the transponder. So you might have heard this word transponder. So at the end of the satellite, we are having transponders are there. So actually what we are doing, we are transmitting a signal from the earth station towards the satellite like this. So what does the satellite is doing? It is simply down converting the frequency. So whatever signal is received from the earth station, the satellite down convert the frequency. If I draw it here, तो यहाँ पर क्या होगा? Frequency down conversion will take place. Then the satellite, it will amplify the signal. This will amplify the signal. And again, the signal will be retransmitted towards the earth. So this is the basic job of the satellite. Satellite will receive signal from the earth station or the end user. Then frequency down conversion will take place. It will amplify the signal. And again, the signal will be retransmitted towards the earth. अब क्योंकि सैटेलाइट एक हाइट पर है, तो उससे हमें एडवांटेज ये मिलेगा कि हमारी जो कवरेज है वो बहुत ज्यादा होगी. तो सैटेलाइट इज नॉट एन इंटेलिजेंट डिवाइस. इट सिंपली रिसीव द सिग्नल, फ्रीक्वेंसी के डाउन कन्वर्ट करेंगे, सिग्नल को एम्पलीफाई करेंगे, एंड अगेन सिग्नल विल बी रिट्रांसमिटेड टुवर्ड्स द अर्थ. सो दिस इज द बेसिक जॉब ऑफ द सैटेलाइट. तो अभी तक हम लोगों ने ये कवर किया है कि सैटेलाइट के केस में क्या, वी आर हैविंग टू सब सिस्टम्स, ग्राउंड सेगमेंट, अर्थ स्टेशन एंड द एंड यूजर्स, दे आर ऑन द ग्राउंड सेगमेंट. In the space segment, we are having the satellite. Within the satellite, we are having number of transponders. Satellite simply receive the signal, then frequency down conversion takes place, then it amplifies the signal, and again the signal is retransmitted towards the Earth. So that is the two subsystems of the satellite subsystems. Now we come to this point of the orbits. So in case of satellite communication, we are having some sort of orbits are there. So normally what is there? We are having 3 orbits. So first one is the low Earth orbit. Second one is the medium Earth orbit. And this geosynchronous and geostationary, we can take it as one orbit like this. So in case of low Earth orbit, the altitude or the height of the satellite from the Earth's surface is from 150 to 1000 kilometer, and the time period is from 1.5 to 1.8 hours. In case of medium Earth orbit, the altitude is from 5000 to 10,000 kilometer, and time period is from 3.5 to 6 hours. For this geosynchronous and geostationary, the altitude or the height from the Earth's surface is 36,000 kilometer from the Earth's surface, and time period is 24 hours. So in case of this geosynchronous and geostationary, the altitude is same as well as the time period is same, but some minute difference is there. So actually what is there, that this, suppose this is Earth, and this is one axis. So actually what is there, the Earth is tilted on its axis like this, no? Earth is tilted on its axis. So suppose if in this case, we draw a plane on the tilted axis, na, like this. So this plane is known as the plane of equator. So if the satellite is moving in the plane of equator, in that case, this orbit is known as the geostationary orbit. And if it is not moving in the plane of equator, then we know, this orbit is known as the geosynchronous orbit. So this is the minute difference. If the satellite is moving in the plane of equator on the tilted axis, then this orbit will be geostationary. Otherwise, that will be geosynchronous. So you should remember that in case of the geosynchronous and geostationary, altitude as well as the time period is same. So this is also shown here. And this for this geostationary satellite, precisely, roughly we are saying that this height is 36,000 kilometer, but precisely this is 35,786 kilometer. So low Earth orbit, medium Earth orbit, geosynchronous and geostationary orbit. In case of low Earth orbit, what is there? The altitude is low, so coverage will be less. So to cover some area or some country, we need more number of satellite. Same is the case in case of medium Earth orbit. But in case of this geostationary orbit, altitude is more, so coverage will be more. So we can cover some country or some bigger area with the help of the single satellite. So in case of geostationary, we need less number of satellite. In case of low Earth orbit or medium Earth orbit, we need more number of satellite. So this is the difference in number of satellites in case of this. Again, we come to this point. So here what we have shown the geostationary orbit. So as we have already seen that in case of geostationary orbit, time period is 24 hours. 24 hours, no? So actually what is there, as we know that the time, suppose this is the Earth and this is some satellite, no? So as we know that Earth takes 24 hours to take one round on its axis. And suppose the time period of satellite is also 24 hours. So in that case, the time period of Earth and satellite, they are same. So a point on the Earth like this is one point on the Earth, and the satellite they will always be in line of sight, क्योंकि दोनों का time period same है. A point on the earth and the satellite, they will always be in line of sight. LOS is the line of sight. तो ये दोनों हमेशा क्या होंगे ना, आमने सामने होंगे. So normally we are using the geostationary satellite. So in case of geostationary satellite, we are using the line of sight concept as the time period is same. So these are the advantage of satellite communication, which I have already covered, that large coverage will be there. Then high quality will be there. As we know that in case of mobile communication, we are having the multi-path fading. Signal from BTS to mobile station, it can follow so many paths. No? So multi-path fading will be there. This loss will be there. But in case of satellite, normally we are using the line of sight communication. So this multi-path fading will not be there. So we are having the high quality. High reliability is also there in case of satellite communication. So once the satellite is launched successfully, the satellite is going to serve for 14 to 15 years. So reliability will be higher. High capacity will be there. Flexibility will be there. Speed of installation. So this will also be there. In case of emergency, we can use the satellite communication. This advantage is there. These are the application areas of satellite communication for telephony. So if we are using a satellite for communication purpose, in that case, that satellite is known as the COMSAT. So COMSAT is the term used for the satellite, for the satellites which are used for communication purpose. तो telephony में हम लोग इसको use कर सकते हैं. Satellite television is there, है ना? For DBS also we can use it. So this is one application, DBS. DBS is the direct broadcast satellite. Direct broadcast satellite. So DBS is the DTH service, direct to home service, like Tata Sky. Na? So this DTH is also one application based on the satellite communications. Satellite radio is there. Satellite internet is there. So nowadays we are using broadband with the help of the satellite in low Earth orbit. In navigation, we are already using the satellite communication, like for GPS, and for India, we are having one another system, that is the IRNSS. So these are the application areas of the satellite communication. Now, basic communication satellite components. So again, I think this picture is missing here. So I am again drawing it. Suppose this is your satellite. This is the, suppose this is your Earth station, ES. ES is for Earth station. And suppose this is one end user like this. This is one end user. So usually what is there? Just like in case of mobile communication, we are having uplink and downlink. In the same way, for satellite communication, we are having uplink and downlink. So from Earth station to satellite, we call it as uplink. So this is the uplink, and from satellite to end user or satellite to Earth station, we call it as downlink. So suppose this is the downlink. So uplink is from Earth station to satellite, and downlink is from satellite to the end user. And normally this uplink frequency is higher in comparison to the downlink frequency. In case of mobile, this is reverse. In case of mobile, what is there? Uplink is lower and downlink is higher. But in case of satcom, uplink frequency is higher and downlink frequency is lower. So this is due to that at the end of the satellite, we have to save the power. So normally at the end of the satellite, the power source is normally solar power. So we have to save the power. So at higher frequency, losses are higher. So to save the power, we are using higher frequency from Earth station to satellite. क्योंकि Earth station पे क्या है ना कि there is no problem of power. We can use DG sat or some other power supply, but we have to save the power at the end of the satellite. So you should remember that uplink in case of Earth satellite is higher and downlink is lower. ये मैंने आपको बता दिया है. Now basic components of the communication satellite link. So basically at the end of the satellite, what we are having, the communication satellite essentially consists of payload and support subsystem. So they are talking of the satellite components. So what we are having the payload. Payload means kya hai? What is the meaning of payload? Payload means actual bandwidth, na? Actual bandwidth. So actual bandwidth is provided by the transponder at the satellite. So this payload is provided by the transponder, which is available at the satellite. So payload means actual bandwidth. Then some support subsystems are also there, like this altitude and orbit control equipment, power subsystems, telemetry and telecommand. So normally satellite अपनी orbit में move कर रहा है. अब मान लो वो orbit में अपने path से ऊपर या नीचे कुछ हो गया. So in that case, what we are having one facility that is called as the this ISRO. They will release the TTC command from their stations to make the satellite into its correct orbit. So that is through telemetry and telecommand. Transponder we will discuss later on. Now these are the frequency bands, and this is the important point for satellite communication. So in case of satellite communication, we are using line of sight communication, and we are using some special frequency band. For example, we are using L band, S band, C band, X band, KU band, K band, Ka band. And out of these bands, this L band, C band, KU band, and Ka band, they are important. So the C band is normally used for the fixed satellite service or fixed mobile service based on satellite, no? Like the Inmarsat service. So in case of this Inmarsat voice service, we are using the C band. KU band is normally used for VSAT. For VSAT service, we are using this KU band. Ka band is also used for this VSAT service, and KU band is also used for the DTH service. L band we are using as the IF frequency for downlink, no? So C band is used for Inmarsat, satellite-based mobile communication. KU band is used for VSAT as well as for DTH service. Ka band is also used for VSAT service, and L band we are using as IF or intermediate frequency. So these are the important frequency bands which we are using in case of the satellite communication. If we take the C band, so in case of C band, what is there? The downlink, uplink frequency is from 5.9 to 6.425 gigahertz, and downlink is from 3.7 to 4.2 gigahertz. So these are some important information, and you have to remember it. Uplink from 5.925 to 6.425, and downlink is from 3.7 to 4.2 gigahertz. So if you see that in case of uplink and downlink, the total available bandwidth is 500 megahertz. So this bandwidth in uplink and downlink is 500 megahertz. And bandwidth for one transponder, including the guard band, is 40 megahertz. So if we map the different transponders in the given bandwidth, so number of transponders will be how much? So we have to divide the total bandwidth by the bandwidth of one transponder. So that comes out to be 12 transponders. So normally we are having 12 number of transponders. Okay. But with the help of the polarization technique, with the help of the polarization technique, we double the number of transponders. So this number will be 24 transponders. So nowadays, normally we are having 24 number of transponders inside one satellite. So as already covered that the actual bandwidth will be given by the transponder. Okay, so what is the meaning of this concept? Actually, what is there? The companies which are launching the satellite, they are earning revenue by leasing out the transponders. Suppose I am having one office at Andaman Nicobar and my head office is at Delhi. And I want one link between my Andaman Nicobar office and Delhi office. So what will I do? I will go to the commercial branch of ISRO and I will tell them that I want one connectivity between my two offices. So they will ask me that how much bandwidth you need. So I will tell them that I want a link of 2 MB or 4 MB or 10 MB. So as per my requirement, what they will do, they will allot me this bandwidth 2 MB, 10 MB or 20 MB out of 40 MB available in one transponder. Suppose I say that I need 20 MB, so they will allot me half transponder. If I say that I need 40 MB link, so they will allot me one complete transponder. And in lieu of that, I will pay rent of the transponder to the ISRO. So in this way, these companies are earning the revenue. They are leasing out the bandwidth available in the transponder or renting out the transponders. So this is the concept how they are earning the revenue. So for this C-band, uplink and downlink, we have discussed. One extended C-band is also there. For that uplink is from 6.725 to 7.025 and downlink is from 4.5 to 4.8 gigahertz. For KU band, uplink is from 14.0 to 14.5 gigahertz and this downlink is from 10.95 to 11.2 and 11.45 to 11.7 gigahertz. So normally we are having this 500 megahertz bandwidth in uplink and downlink. Now, advantage of satellite communication we have already discussed, but some disadvantage or some problems in satellite communication are also there. So the biggest problem in case of satellite communication is the latency or the delay. We also call it as latency. So latency is more. So actually what is there? Suppose we are transmitting a signal from the Earth station and it has to reach up to satellite. So distance is around 36,000 kilometers. And if we take the speed of the EM wave as the speed of light, so time taken by the wave to reach up to satellite, it will be distance 36,000 kilometers. And if you divide it with by speed of light, suppose c, so this time comes out to be 120 milliseconds. So this is the time from Earth station to satellite. So this is the one-way time. And if we are transmitting signal to the another end, so again 120 milliseconds will be there. Okay. Like this, suppose this is the satellite, this is the Earth station, and this is the end user now. If we are moving from this Earth station to satellite, this will be 120 milliseconds. And from satellite to this end user, again this will be 120 milliseconds. So the total time will be 240 milliseconds from this Earth station to the end user. So in case of satellite communication, this delay is more. So that is the problem. So somebody, this is asked in the examination that problem in satellite communication. So latency or the delay issue is there. So that is the biggest problem. Orbitals we have already discussed. Geosynchronous, geostationary, I have already told you. Now we come to this point, satellite footprint. So the footprint of a satellite is the ground area that its transponders offer coverage. Basically, footprint means the coverage कि satellite का जो signal है वो कहाँ पे ना available है. So that is the footprint. So footprint means the coverage on the ground area where the signal of the satellite is available. So this downlink EIRP is the effective isotropic radiated power is 32 dB watt at the beam center. Now we are having some coverage area like this primary coverage area, secondary coverage area, and this tertiary coverage area. Difference between geosynchronous and geostationary. Atul ji, I have already told that if the satellite is moving in the plane of equator, then that orbit will be geostationary orbit. And if it is not in the plane of equator, then that will be the geosynchronous orbit. Altitude as well as time period for both the orbits is same. Only the difference is that plane of equator. If it is moving in the plane of equator, then the orbit will be geostationary orbit. So primary coverage area, secondary coverage area, and tertiary coverage area. So basically, what is there? We are having a concept of spot beams. The signal which is coming from the satellite, it is in the form of spot beams. Suppose we are having one area like this, na? Suppose this is one area. Suppose this is UP. So basically, what is there? Spot beams are coming from the satellite. So this spot beam from satellite will come and it will strike at the center of the UP like this. This is the center of the UP. तो जहाँ पे ये स्पॉट बीम स्ट्राइक कर रही है वहां पे हमें ना सिग्नल की स्ट्रेंथ बहुत ज्यादा होगी, ठीक है। तो ये यहाँ पे 32 dB वॉट है जो लिखा हुआ है ना ऊपर, ये डाउनलिंक EIRP इज 32 dB वॉट एट द बीम सेंटर। तो यहाँ पे ये 32 dB वॉट है। इसके बाद क्या होगा, इफ फ्रॉम दिस सेंटर इफ वी गो 3 dB डाउन लाइक दिस, 3 dB डाउन हम लोग यहाँ से जाए लाइक दिस ना, तो वी रीच दिस बाउंड्री लाइक दिस। 3 dB मीन्स क्या हो गया, पावर आपकी आधी रह जाएगी। तो ये जो पूरा एरिया इस तरह कुछ बन गया ना, दिस इज दी प्राइमरी कवरेज एरिया, ठीक है। और अगर इस बाउंड्री से अगर अगेन हम लोग 3 dB डाउन जाएं तो वी रीच दिस बाउंड्री लाइक दिस। सो दिस बाउंड्री विल बी दी secondary coverage area like this. So this area will be the secondary coverage area. And again, if we move 3 dB down from this secondary coverage area boundary, so we reach this point. So this area will be the tertiary coverage area. तो जैसे BTS के केस में होता है कि अगर हम लोग BTS के नजदीक है तो we are getting stronger signal. In the same way, if we are okay, so if we are in the primary coverage area, so we are getting stronger signal. We are getting some weaker signal for secondary coverage area and more weaker signal or the weakest signal in case of the tertiary coverage area. But इसका मतलब ये नहीं है कि अगर आप tertiary coverage area में तो you are not able to use the service. एक minimum level is there and in tertiary area you will also be able to use the service. ठीक है, तो we are getting stronger signal in primary coverage area and the weakest signal for the tertiary coverage area. dB watt is the way to represent the power in dB like this ना, पावर की जो यूनिट है बेसिकली दैट इज वॉट और मिली वॉट ना। तो नॉर्मली इन फॉर दिस वायरलेस सिस्टम और सैटेलाइट कम्युनिकेशन ना वी आर रिप्रेजेंटिंग द पावर लेवल्स इन dB. So if some power is given in the watt, suppose we are having 1 watt power and you want to represent it in dB, so what you do, you just take the 10 log 1, 10 log base 10 1 आप करेंगे तो log base 10 1 की वैल्यू कितनी 0 होती है, तो this will be 10 into 0, so this comes out to be 0 dB watt. So dB watt, in case of dB watt we are representing the power in dB. So अगर हम लोग 1 watt पावर हमारे पास है तो in case of dB that will be equivalent to 0 dB watt. इसी को हम लोग dBm में भी रिप्रेजेंट कर सकते हैं। अगर मान लो आप मिली वॉट में किसी पावर को ले रहे हो मिली वॉट, तो इसको हम लोग रिप्रेजेंट करते हैं dBm, dB मिली वॉट। एंड इफ वी आर गोइंग 3 dB डाउन तो पावर हमारी आधी रह जाती है। 1 वॉट है तो आपका ये 0 dB वॉट हो गया, वो 30 dBm हो जाएगा। तो प्राइमरी कवरेज एरिया, सेकेंडरी कवरेज एरिया एंड टर्सरी कवरेज एरिया ये मैंने आपको बता दिया। Now we come to this VSAT now. So VSAT stands for very small aperture terminal. So in case of BSNL, what is there? We are having two types of things. One is the VSAT, very small aperture terminal. This VSAT we are using for voice as well as high speed internet. So VSAT is used for voice as well as for high speed internet. And the second service was this DSPT, डिजिटल सैटेलाइट फोन टर्मिनल. ये भी हम लोग आगे देखेंगे. तो ये जो DSPT सर्विस थी, दैट वाज मेनली फॉर वॉइस. That was mainly for voice. But nowadays we are operating on only on VSAT. We are using the VSAT. DSPT service basically एक तरह की close हो गई है service अभी है ना. So we are not using this service. So what is VSAT? VSAT stands for the very small aperture terminal. इसका मतलब क्या हुआ कि जो VSAT के अंदर हम लोग डिश यूज कर रहे हैं, जैसे हमारे घर में जो DTH लगा हुआ है, वहाँ भी जो डिश का जो साइज है दैट इज ओनली 80 सेंटीमीटर. तो डिश का साइज क्या है या जो अपर्चर है वो काफी छोटा है. तो दैट्स वाई वी कॉल इट एज वेरी स्मॉल अपर्चर टर्मिनल. तो VSAT को हम लोग नॉर्मली आजकल काफी ज्यादा यूज कर रहे हैं. तो VSAT stands for the very small aperture terminal. The very small component of the VSAT acronym refers to the size of the VSAT terminal. And this size of this VSAT terminal is from 2 to 5 feet or 0.55 to 1.8 meter in diameter for the KU band. वॉइस में और हाई स्पीड इंटरनेट में हम लोग इसको यहाँ पे यूज कर रहे हैं. अब इसमें जो इम्पोर्टेंट है ना, ये आपका ये काफी इम्पोर्टेंट है कि VSAT के जो कंपोनेंट्स हैं. तो इन केस ऑफ VSAT वी आर हैविंग 2 units are there. So first one is the ODU. ODU means outdoor unit. And second one is the indoor unit. तो VSAT के अंदर दो चीजें हैं. फर्स्ट वन इज द आउटडोर यूनिट एंड सेकंड वन इज द इंडोर यूनिट. मैं एक बार आपको दिखा देता हूँ. Like this. So this is the VSAT service ना. तो आउटडोर यूनिट का मतलब क्या हुआ कि जो हार्डवेयर या कंपोनेंट हम लोग आउटडोर में लगा लेते हैं या हम लोग जो ओपन स्पेस में लगा रहे हैं, सो दैट विल बी द ODU. और जो हार्डवेयर या कंपोनेंट हम लोग इंडोर में या किसी ऑफिस में इंस्टॉल कर रहे हैं, तो दैट विल बी द IDU. तो नॉर्मली ये जो कंपोनेंट्स आप लोग देख रहे हैं यहाँ पे ना, दे आर द पार्ट ऑफ द ODU. सो दिस इज अवर ODU, आउटडोर यूनिट. और जो ये मॉडेम यहाँ पे लगा हुआ है और एक PC यहाँ पे लगा हुआ है, तो दे आर द पार्ट ऑफ द इंडोर यूनिट. So these are the component of the VSAT, outdoor unit and indoor unit. In case of outdoor unit, some components are there. So first component is the BUC, buck. इसको हम लोग buck भी बोलते हैं. तो this BUC stands for the block up converter. Block up converter. मैं लिख भी देता हूँ यहाँ पे. This is block up converter. LNB stands for low noise block down converter. Low noise block down converter. The block up converter is there and low noise block down converter is there. So if we ask that what are the hardware components in ODU, so buck is there, LNB is there, this will be there. So and this is the horn antenna. This is the horn antenna, receiving or transmitting antenna. So they are the component of the outdoor unit. For indoor unit, we are having this modem as well as your PC. So they are the part of the indoor unit. Now, how this system works? So in case of satellite communication, what is there? One process is there. Suppose we are transmitting some signal, na? So we are having two chains. So one is the transmitting chain and the second one is the receiving chain. So in case of satcom, what we have to do, some frequency conversion is there. So in the starting, we are having the baseband signal. Suppose I am speaking, so I am using the speech signal. So that is our baseband signal. Then what we do, we convert this baseband signal into IF signal or the intermediate frequency signal. And this range will be in megahertz. And then we convert this IF into microwave signal. ऐसा हम लोग क्यों कर रहे हैं? क्योंकि अभी आपने देखा ना कि एल बैंड इज देयर, सी बैंड, के यू बैंड एंड का बैंड, उनकी जो रेंज है दैट इज इन गीगाहर्ट्ज, और जो हमारा बेस बैंड सिग्नल है दैट इज इन द किलोहर्ट्ज. सो वी हैव टू कन्वर्ट द फ्रीक्वेंसी. तो जब भी हम चीजों को ट्रांसमिट कर रहे हैं तो हम लोग क्या कर रहे हैं? फर्स्ट वी आर हैविंग द बेस बैंड सिग्नल, then with the help of some modem we will modulate it and we will convert it into IF signal that is in megahertz, and we have to reach up to microwave. So then we will use one frequency up converter. So with the help of this frequency up converter we will convert IF into microwave signal. So this is the process in the transmit chain. रिसीव चेन में क्या होगा कि जो सिग्नल हमें रिसीव होगा दैट विल बी इन माइक्रोवेव सिग्नल और इन गीगाहर्ट्ज रेंज. देन वी विल demodulate it, or sorry, then we will frequency down convert it. So with the help of that we will convert microwave or gigahertz into megahertz, then we will demodulate it, so we will convert megahertz into baseband signal in the kilohertz range. So this is the process. अब यहाँ पे क्या हो रहा है कि ट्रांसमिट या रिसीव हम लोग कैसे कर रहे हैं कि सपोज कि कोई सिग्नल आपका सैटेलाइट से आ रहा है, तो डिस्टेंस इज अराउंड 36,000 किलोमीटर. So we can assume that the signals which are coming from satellite, they are coming from infinity. So signal from satellite will come and it will strike on the dish. So after reflection, it will go to the focal point. At the focal point, we are having this horn antenna like this. तो सिग्नल यहाँ पे रिसीव हो जाएगा. देन आफ्टर दिस हॉर्न एंटीना वी आर हैविंग वन पोलराइजर हियर. तो यहाँ पे एक पोलराइजर लगा हुआ है. विद द हेल्प ऑफ दिस पोलराइजर व्हाट वी आर डूइंग, वी आर जस्ट सेग्रीगेटिंग द ट्रांसमिट पार्ट फ्रॉम द रिसीव पार्ट. एक्चुअली में यहाँ पे एक हॉर्न एंटीना तो सिंगल है, और यही हॉर्न एंटीना वी आर यूजिंग फॉर ट्रांसमिटिंग एज वेल एज फॉर द रिसीविंग ऑपरेशन. सो वी हैव टू सेग्रीगेट द ट्रांसमिट पार्ट फ्रॉम द रिसीव पार्ट. So for that we are using the polarizer. So EM wave, it can move in two ways. It can be horizontally polarized or it can be vertically polarized. So signal from satellite will come, it will strike on the dish, it will go to the focal point. यहाँ पे ये horn antennas को receive कर लेगा. Then through this polarizer it will come inside the LNB. यहाँ पे ये LNB लगा हुआ है. LNB क्या करेगा? ये माइक्रोवेव जो आपने रिसीव किया है उसको ये डाउन कन्वर्ट करके ये IF में कन्वर्ट कर देगा. And through this receiving cable signal comes inside the modem. Modem क्या करेगा? इसको demodulate करके अगेन ये बेस बैंड में कन्वर्ट कर देगा. So this is the receive part. If you are transmitting the signal, suppose यहाँ से हम लोग नेट एक्सेस कर रहे हैं, तो यहाँ पे हमारे पास बेस बैंड होगा, फिर ये मॉडेम के अंदर जाएगा, मॉडेम विल मॉड्यूलेट इट एंड our baseband it will be converted into IF frequency. फिर थ्रू दिस केबल इट विल गो इनसाइड द बक. बक का मतलब क्या है? ब्लॉक अप कन्वर्टर. इसका मतलब क्या हुआ? ये फ्रीक्वेंसी को अप कन्वर्ट करेगा. तो विद द हेल्प ऑफ दिस बक वी आर कन्वर्टिंग IF इनटू माइक्रोवेव, और अगेन फिर सिग्नल यहाँ से ट्रांसमिट होगा. नाउ दिस इज द फोकल पॉइंट. तो अगर रे आपकी फोकल पॉइंट से जाएगी तो और यहाँ पे स्ट्राइक करेगी, तो फिर ये क्या होगी? पैरेलली ट्रांसमिट हो जाएगा टुवर्ड्स इंफिनिटी, जहाँ पे आपका सैटेलाइट. सो this is the transmit and receive operation in case of the VSAT. So basically in case of VSAT we are having ODU, we are having IDU. ODU के अंदर हमारे पास BUC है, LNB है, हॉर्न एंटीना है, डिश है. So they are the component available in ODU. IDU में हमारे पास क्या है? मॉडेम है और हमारा जो PC है, they are the component for IDU. फिर हमें ये पता होना चाहिए कि जो बक है, ब्लॉक अप कन्वर्टर, ये किस साइड यूज होता है? ट्रांसमिट साइड या रिसीव साइड? तो अभी मैंने बताया कि अप कन्वर्ट हम चीज़ों को करते हैं जब व्हेन वी ट्रांसमिट द सिग्नल. तो बक इज यूज्ड इन ट्रांसमिट साइड, LNB इज यूज्ड इन द रिसीवर साइड. सो वी शुड नो दीज कंपोनेंट्स. अगेन यहाँ जो ये कनेक्टिंग केबल्स है ना, दीज केबल्स आर ऑफ टू टाइप्स. वन इज द RG6 केबल and second one is the RG11 cable. So use of this cable depend on the distance. So if the distance between this outdoor unit and indoor unit is less than 40 meter, so in that case we use this RG6 cable. और अगर distance between ODU and IDU is more than 40 meter, suppose ये आपने कहीं रूप पे लगा रखा है और ये कहीं ऑफिस के अंदर लगा रखा है, डिस्टेंस आपकी 40 मीटर से ज़्यादा हो रही है, तो इन दैट केस वी विल यूज दिस RG11 केबल। तो बेसिकली जो RG11 केबल है, ये इसके लॉसेस कम होते हैं तो डिस्टेंस ज़्यादा कवर आप कर सकते हो, बट ये थोड़ी कॉस्टली भी है। तो वी आर हैविंग टू टाइप्स ऑफ केबल, RG6 केबल एंड RG11 केबल। If I ask you that what is the basic difference between this VSAT system and the DTH which you are using at your home, तो दोनों में क्या डिफरेंस दिख रहा है आपको? For BK is asking for BUC and LNB, two separate cables are used or single cable? Okay, okay. Basically क्या है, in case of VSAT we are operating in full duplex mode. तो यहाँ पे दो पार्ट हैं, एक है ट्रांसमिट चेन एंड सेकंड वन इज द रिसीव चेन, जिसके ऑपरेशन मैंने अभी आपको बताए हैं। तो यहाँ दो केबल होंगी, एक केबल होगी RG11 केबल एंड सेकंड वन इज दी RG, सॉरी, यहाँ पे दो केबल हम लोग यूज करते हैं, one for transmit and second for the receive operation. So two cables are there in case of the VSAT. KSP is writing that in case of DTH, one-way communication is there. Okay, very good. So if we compare this system with DTH, so DTH is receive only. DTH is receive only. So in case of DTH, we are not transmitting anything. That is the receive only system. तो वहाँ पे क्या होगा, जो ट्रांसमिट वाला पार्ट है वो सारा मिस होगा. In place of two cables, only single cable is there. So that will be used for receive only. बक को, अच्छा, ट्रांसमिट में हम लोग क्या यूज करते हैं, एक केबल होगी, देन वी यूज द बक ब्लॉक अप कन्वर्टर. तो ब्लॉक अप कन्वर्टर विल ऑल्सो नॉट बी देयर, तो BUC वहाँ मिस होगा और ये केबल, एक केबल भी वहाँ पे मिस होगी. मॉडेम की जगह हम लोग वहाँ पे सेट टॉप बॉक्स यूज करते हैं. सो दिस इज द डिफरेंस बिटवीन DTH एंड योर VSAT system. Okay, one more point is there that so again I have covered ना all these points कि क्या क्या लगा हुआ है, कि अगर हम इफ वी सी दिस आउटडोर यूनिट, तो इसमें क्या है, वी आर हैविंग द BUC, वी आर हैविंग द LNB. फुल फॉर्म क्या मैंने आपको बता दिया, वी आर हैविंग द फीड असेंबली, और जो डिस्क का साइज है दैट इज फ्रॉम 0.75 मीटर टू 1.8 मीटर. Yeah, one more thing is also there that for BUC, one power rating is there that is from 1 watt to 2 watt. Basically ये जो BUC है, इसके यहाँ पे दो काम है, two jobs are there. First one is the frequency up conversion, and second one is the amplification of the signal. So for amplification, this BUC is having SSPA. SSPA is solid state power amplifier. So this BUC is having 2 points. First, it is up converting the signal during transmit operation, as well as we have to amplify the signal. अगर सिग्नल को हम लोग VSAT से ट्रांसमिट कर रहे हैं टुवर्ड्स सैटेलाइट, तो डिस्टेंस इज अराउंड 36,000 किलोमीटर, तो पाथ लॉस विल बी हायर. So we have to amplify the signal so that it can reach up to satellite. So inside the BUC, we are having one SSPA. SSPA is your solid state power amplifier. So we are amplifying the signal with the help of BUC. And the rating is from 1 watt to 2 watt. So this rating is mentioned here. And nowadays we are using SSPA of rating 1 watt to 10 watt. So for BUC, frequency up conversion as well as amplification of the signal. तो ये काफी इंपॉर्टेंट है, ये सारी चीजें ना. BUC block up converter, it also amplifies the signal. LNB amplifies incoming RFs from the field using low noise amplifier, and it converts IF into baseband that is given to the indoor unit. अगेन ये सब चीजें यहाँ भी है कि ये आउटडोर यूनिट के अंदर डिस है, LNB है, BUC है, और इंडोर यूनिट के अंदर वी आर हैविंग द मॉडेम. These are the features of ब्रॉडबैंड वीसेट सिस्टम ऑफ BSNL। तो इसमें कुछ चीजें हैं एक्स्ट्रा, और जैसे कि ये DLA हो गया। व्हाट इज DLA? DLA स्टैंड्स फॉर डायनामिक लिंक एलोकेशन। DLA का मतलब क्या हुआ कि जो भी आपकी मॉड्यूलेशन स्कीम है या कोडिंग है या जो गेन है, दैट विल डिपेंड ऑन द लिंक क्वालिटी। सपोज यहाँ पे कोई आपका ये वीसेट लगा हुआ है और आप यहाँ पे सर्विस यूज कर रहे हो, एंड यू आर इन टर्सरी कवरेज एरिया, सो यू आर गेटिंग वीकर सिग्नल। सो इन दैट केस सिस्टम विल अलॉट यू लोअर ऑर्डर मॉड्यूलेशन स्कीम लाइक दिस QPSK or BPSK. But if you are in primary coverage area, so you are getting stronger signal. So in that case, system will allot you higher order modulation like this 16 QAM. तो ये जो मॉड्यूलेशन स्कीम है, दिस ऑल्सो डिपेंड्स ऑन द लिंक क्वालिटी, कि आपका जो सिग्नल है वो कैसा मिल रहा है आपको। सो दैट इज द मीनिंग ऑफ द DLA, डायनामिक लिंक एलोकेशन। Okay, one more thing is there that as I have already told you that with the help of this VSAT we can use internet as well as the this वॉइस। तो वॉइस के लिए हम लोग क्या करते हैं कि मॉडेम के बाद ना, आई थिंक दिस इज गिवन हियर लाइक दिस। सपोज यू हैव टू यूज द वॉइस ना, तो फॉर दैट व्हाट वी आर डूइंग, दिस इज अवर आउटडोर यूनिट, this is our indoor unit. So at the indoor unit we are having modem, then we are using one hub here, hub or switch na. Then from this hub we are using one cat cable or ethernet cable. So if you want to use the internet, so this cable goes in the CPU like this. But if you want to make the voice call, so in that case this ethernet cable goes inside the ATA. So ATA is the analog telephone adapter. तो एक ये ना प्रोटोकॉल कन्वर्जन है कि अगर आपको वॉइस कॉल यूज करनी है तो फॉर दैट वी हैव टू यूज द ATA, एनालॉग टेलीफोन एडेप्टर। और ATA से हम लोगों ने अपने यहाँ पे ये फोन को अटैच कर दिया, तो यहाँ से हम लोग वॉइस कॉल कर सकते हैं। सो व्हाट इज द फुल फॉर्म ऑफ ATA? एनालॉग टेलीफोन एडेप्टर। ये भी थोड़ा आपको पता होना चाहिए। नावेडेज जो हमारे ये मॉडेम है, दे आर VoIP इनेबल्ड, तो अब हमें जरूरत नहीं है ATA की, बट इन द ओल्डर वर्जन वी वर यूजिंग दिस ATA, एनालॉग टेलीफोन एडेप्टर। तो DLA मैंने आपको बता दिया है, ATA एनालॉग टेलीफोन अडेप्टर। तो दिस VoIP टेलीफोनी विद एड ऑन ATA एनालॉग टेलीफोन अडेप्टर टू मेक द वॉइस कॉल। ये कुछ VSAT सर्विसेज ऑफर्ड है, तो ये एक बार आप लोग देख लीजिएगा कि हम लोग इसको VoIP टेलीफोनी में यूज कर सकते हैं। हाई स्पीड इंटरनेट के लिए जो टेलीमेडिसिन, ई लर्निंग। व्हाट इज द मैक्सिमम बैंडविड्थ? बेसिकली क्या है कि अराउंड 2 ईयर एगो द मैक्सिमम स्पीड वाज अराउंड 14 Mbps। राइट नाउ कितना हो गया ये मुझे अब याद नहीं है अभी, बट इट वाज अप टू 14 Mbps। These are the advantage of this VSAT. वैभव गोयल जी, जो मुझे फिगर याद है ना, अराउंड 1 to 2 ईयर एगो दैट वाज 14 Mbps। राइट नाउ क्या है किस प्लान में ना, अभी थोड़ा मुझे आइडिया नहीं है। तो दीज आर दी एडवांटेज ऑफ VSAT की अवेलेबिलिटी इज देयर। तो जब तक आप ओपन स्काई में हो, कहीं पर हो, ओपन एरिया में हो और आपको सिग्नल मिल रहा है फ्रॉम दी सैटेलाइट, तो यू कैन यूज दिस VSAT सर्विस, है ना। तो अवेलेबिलिटी इज देयर, डाइवर्सिटी इज देयर, डिप्लॉयबिलिटी इज देयर कि वी कैन डिप्लॉय VSAT विद इन आवर्स, so this is also the advantage. Homogeneity is there, कि suppose two subscribers are there and they are using the same plan, so they will have the same type of service, दोनों की स्पीड सेम होगी, इस तरह की चीजें यहाँ पे होंगी। मल्टीकास्ट सिक्योरिटी, so these are the advantage of the VSAT. Jaypal ji is saying that it can go up to 100 Mbps. So that may be the latest figure. Disadvantage in case of VSAT. So again, the only one disadvantage is there, and that is the latency. So if we are using the geostationary satellite, then latency will be there. So VSAT links are subject to a minimum latency of approximately 500 millisecond for the round trip. Round trip means, suppose this is your satellite, this is end user, and this is the second user, and you want to send some packet, some information from here to here. So in that case, what will happen? From this point to satellite, 120 millisecond, satellite to the end user, again 120 millisecond. And if we count the round trip, so here to here, again 120, and again here to here, again 120. So that will be around 480 millisecond. So nearly that is equal to 500 millisecond for the round trip. तो 500 मिलीसेकंड डिले ना काफी ज्यादा होता है. तो प्रॉब्लम क्या है? लेटेंसी की प्रॉब्लम है. One more problem is there that is also important, that is the environmental concern. एक ये भी प्रॉब्लम होती है. What is delay in one hop? Suppose you are moving from one end to another end, so that will be 120 plus 120, so that will be equal to 240 millisecond. So suppose this comes in the examination, and they will tell you that what is the delay from Earth station to satellite, so that will be 120 millisecond. If they ask, but answer is 500 millisecond, so that is for the round trip. If you are moving from one end to another end and from another end to the first end, so that will be the round trip. In that case, that will be 500 millisecond. Yes, two hops, two round trip hops will be 1 second. Again, one more problem is there in case of VSAT, na? So in case of VSAT, what is there? We are operating in KU band. We are operating in KU band. And also some more bands are there like this, na? Which I have already told you that C band is there. C band is there. KU band is there. And Ka band is there. So C band को हम लोग use कर रहे हैं for satellite based mobile communication, ना? So C band is used in case of mobile satellite based mobile communication. This KU and Ka band we are using for the VSAT applications. So KU band we are using for this VSAT applications. Now if you compare this C band and KU band and Ka band, so basically what is there? जो एंटीना का साइज है ना, it depends on the operating wavelength. एंटीना साइज depends on the operating wavelength. तो सी के केस में क्या है कि जो फ्रीक्वेंसी है वो कम है, तो वेवलेंथ विल बी मोर. सो इन केस ऑफ सी बैंड एंटीना साइज विल बी लार्ज. यहाँ जो एंटीना का साइज होगा वो लार्ज होगा. के यू और का बैंड के केस में क्या है कि वी आर ऑपरेटिंग एट हायर फ्रीक्वेंसी ना, तो यहाँ पे जो एंटीना साइज होगा वो स्मॉल होगा. So this is the advantage of KU and Ka band, that we are operating at higher frequency, so our antenna size will be small. In case of C band, जो हमारा एंटीना साइज है वो थोड़ा हमारा बड़ा होगा, लार्ज होगा. वन मोर पॉइंट इज देयर कि इन केस ऑफ KU एंड का स्मॉल एंटीना साइज तो स्मॉल होगा आपका, लेकिन यहाँ पे प्रॉब्लम क्या होती है कि जो KU एंड का बैंड है ना, दे आर अफेक्टेड बाय द environmental conditions. Suppose rain is there or some clouds are there. So in case of KU and Ka band, they are affected by the rain and cloudy. So in case of rain or some cloudy weather, na, we are not able to receive the signal in case of KU and Ka band. You might have seen in case of DTH, na, so our DTH system is based on KU band. So sometimes suppose rain is there or some sky is cloudy, na, so one message is there on your TV screen that set-top box is not able to receive the signal. It seems that the sky is cloudy. ऐसा क्यों है? क्योंकि in case of this DTH we are operating in KU band. So this is the problem in KU and Ka band, that they are affected by the environmental conditions. So in case of rain and cloudy systems, we are not able to receive the signal. So this is the problem for KU and Ka band. तो यही यहाँ पे इन लोगों ने लिख रखा है कि environmental concerns are there. Now we come to this DSPT. So DSPT stands for Digital Satellite Phone Terminal. So earlier we were using this service DSPT, but nowadays we are using this VSAT service ना. So we are not operating on this DSPT. I think this DSPT system अभी ये काम भी नहीं कर रहा है, बट क्योंकि ये एग्जाम के सिलेबस में है तो थोड़ा आपको पता होना चाहिए. तो DSPT की फुल फॉर्म क्या है? डिजिटल सैटेलाइट फोन टर्मिनल. मेनली ये हम लोग वॉइस के लिए हम लोग इसको यूज कर रहे थे. बाकी इसमें जो इम्पोर्टेंट पॉइंट है वो आपका कि ये KU बैंड में हम लोग ऑपरेट कर रहे हैं, और जो ट्रांसमिट फ्रीक्वेंसी है दैट इज फ्रॉम 13.75 टू 14.5 गीगाहर्ट्ज. रिसीवर साइड में दैट इज फ्रॉम 10.7 टू 12.75 गीगाहर्ट्ज. तो ये थोड़ा आप याद कर लीजिए. और बाकी इसका जो हब था, हब मीन्स अर्थ स्टेशन. सो हब फॉर दिस DSPT system is located at the Sikandrabad. So Sikandrabad is a town in Bulandshahr district of UP. So these are the important points regarding the DSPT. DSPT full form, mainly that was used for the voice service, transmit and receive frequency, and इसका जो hub था that was at Sikandrabad. So these are the important points for this DSPT. For DSPT, we were using one satellite that was, I think, NSS 6. And that was the American satellite. अभी ये satellite down हो गया, तो that's why this system, this service has been closed. नहीं, पुणे में नहीं है. अब तो ये सर्विस ही DSPT हम लोगों ने क्लोज कर दी है. ये कुछ हब का भी यहाँ पे, सर सिकंदराबाद इज नॉट इन UP. Basically, two Sikandrabads are there. One is at Telangana and second one is at UP. So we are talking of the Sikandrabad, which is in UP. This is near Ghaziabad. Yes, this is near Ghaziabad. So if we see the DSPT hub, where is hub for KU? तो एक तो सिकंदराबाद में ही है, जो VSAT का जो हब है बेसिकली दैट इज अवेलेबल एट सिकंदराबाद. तो इसकी जो प्राइमरी साइट है दैट इज एट सिकंदराबाद, और इसकी जो DR साइट है दैट इज अवेलेबल एट ALT सेंटर. Actually, basically, we are having two systems. One is for this northern area and one is for the southern area. So for northern area, our primary hub is at Sikandrabad and DR site is at ALTTC. Again, for this DSPT system, if we talk, we are talking of the hub of the DSPT. So at the hub, the antenna size is around 8.1 meter. So normally जो हम लोग hub के antenna होते हैं ना, they are of big size, 8.1 meter, 11 meter, 13 meter. So at the hub, we are using the antenna of bigger size. And if we compare this RF path, na, so this RF path consists of transmit chain and receive chain. In case of transmit chain, we are having these components: ULPC, up converter, and SSPA. What is the meaning of ULPC? ULPC stands for uplink power control. That in case of uplink, we are controlling the power. Suppose this is the satellite and this is your earth station. You are transmitting signal from earth station to satellite. So this system or the signal, it should have sufficient power so that it can reach up to satellite. There is no problem. But now suppose at the earth station, we are having some rain or some snowing is there. So in that case, what we have to do? We have to increase the transmit power or not, or we have to transmit at the same level in case of rain or snow. सो इन दैट केस वी हैव टू इंक्रीज द ट्रांसमिट पावर, क्योंकि जो आपकी रेन है या जो स्नोइंग हो गई है उसके केस में क्या होगा कि ये सिग्नल आपका सैटेलाइट तक रीच नहीं कर पाएगा। तो इन नॉर्मल कंडीशन वी आर ट्रांसमिटिंग ए नॉर्मल पावर, सो इट कैन रीच अप टू सैटेलाइट। But suppose some rain is there and some snowing is there, so we have to increase the transmit power। ठीक है, तो इसी को हम लोग बोलते हैं अपलिंक पावर कंट्रोल। तो वन सिस्टम इज देयर एट द अर्थ स्टेशन and it is monitoring the environmental conditions. Some sensors are there, rain is there, snowing is there, so that will be sensed by the sensor, and in that case we have to increase the transmit power, and all these operations are done with the help of this ULPC, uplink power control। Then we are having up converter। तो ट्रांसमिट चेन में वी आर यूजिंग अप कन्वर्टर, फ्रीक्वेंसी अप कन्वर्टर, एंड देन वी आर हैविंग दी SSPA, सॉलिड स्टेट पावर एम्पलीफायर ना। तो बिफोर द सिग्नल इज ट्रांसमिटेड फ्रॉम अर्थ स्टेशन टू सैटेलाइट वी हैव टू एम्पलीफाई इट, क्योंकि सैटेलाइट के केस में क्या होता है, जो पाथ लॉस है ना, दिस इज ऑफ द ऑर्डर ऑफ 200 dB, 200 dB के आसपास पाथ लॉस होता है। और अभी मैंने आपको बताया था कि जो 3 dB, अगर हम लोग 3 dB का लॉस है तो पावर हमारी आधी हो जाती है, तो 200 dB में तो पावर हमारी बहुत कम हो जाएगी। सो वी हैव टू एम्पलीफाई द सिग्नल, सो फॉर दैट वी आर यूजिंग दी SSPA, सॉलिड स्टेट पावर एम्पलीफायर। तो ULPC, अप कन्वर्टर एंड दिस SSPA, दे आर यूज्ड इन ट्रांसमिट साइड। रिसीवर चेन में क्या होगा, वी आर यूजिंग दीज फिल्टर्स ना, ट्रांस फिल्टर्स एंड रडार रिजेक्ट फिल्टर। So basically they are like your band pass filter. We are looking for some specific frequency. Then we are having this LNA, low noise amplifier. So you should remember this LNA ना, low noise amplifier, they are used in receiver side। LNA का जो basic काम है कि जो सिग्नल हम लोग रिसीव करेंगे फ्रॉम द सैटेलाइट, दैट विल बी ए वीकर सिग्नल, वीकर सिग्नल। देन दिस LNA इट विल रिमूव नॉइज फ्रॉम इट। फिर क्या करेगा इसको, ये सिग्नल को रीसेप करेंगे, रीसेप करेंगे, रीसाइज करेंगे एंड एम्पलीफाई करेंगे विद द हेल्प ऑफ दिस LNA। तो LNA इज ऑलवेज यूज्ड इन रिसीवर साइड, एंड वन मोर कंपोनेंट इज देयर, दैट इज द HPA। HPA इज योर हाई पावर एम्पलीफायर, that is used in transmit side। So normally HPA and LNA we are using at the end of the hub or the earth stations। और जो VSAT है वहां पे हम लोग BUC यूज कर रहे हैं और LNB यूज कर रहे हैं। Now we come to this Inmarsat service ना। तो this Inmarsat is basically Inmarsat क्या है, इंटरनेशनल मेरीटाइम सैटेलाइट ऑर्गेनाइजेशन। बेसिकली क्या है ना, जो इनमारसैट है ये एक प्राइवेट ऑर्गेनाइजेशन है, एंड दे आर एक्सपर्ट इन सैटेलाइट बेस्ड मोबाइल कम्युनिकेशन। दे आर एक्सपर्ट इन सैटेलाइट बेस्ड मोबाइल कम्युनिकेशन। तो ये सैटेलाइट बेस्ड जो मोबाइल सर्विसेज थी ये इंडिया में हम लोग पहले भी यूज कर रहे थे। तो आज की डेट में तो जो इनमारसैट बेस्ड सैटेलाइट सर्विस है, दे आर गिवन बाय BSNL इन इंडिया ना, वी आर हैविंग द लाइसेंस। बट बिफोर दैट वी वर यूजिंग दीज सर्विसेज, वी वर ऑल्सो यूजिंग दीज सर्विसेज, एंड एट दैट टाइम दिस लाइसेंस वाज गिवन टू द BSNL, विदेश संचार निगम लिमिटेड। अब उस समय प्रॉब्लम क्या थी कि जो BSNL के केस में कि इसका जो गेटवे था, या MSC कह सकते हो, मोबाइल स्विचिंग सेंटर ना, जहाँ पे हमारी CDR जनरेट होती है, दैट वाज अवेलेबल एट लंदन। एंड ड्यू टू द सिक्योरिटी एस्पेक्ट्स कई बार वी नीड द CDR। सो फॉर द CDR our security agencies ना, they have to go to Inmarsat and MSC is available at London। तो CDR मिलने में बहुत प्रॉब्लम होती थी, कई बार तो कई दिन का डिले हो जाया करता था जो। तो इस तरह की कुछ प्रॉब्लम्स थी पहले। सो टू अवॉइड दीज कंडीशंस क्या हुआ कि गवर्नमेंट ऑफ इंडिया ने डिसाइड किया दैट वी विल इंस्टॉल आवर ओन नेशनल गेटवे इन इंडिया। तो इनमारसेट से बात की और उसके बाद क्या हुआ, वी इंस्टॉल्ड आवर ओन नेशनल गेटवे एट द इंडिया। तो यहाँ पे जो कॉन्सेप्ट है वो दो तरह की है। एक तो है कि वी आर हैविंग टू टाइप्स ऑफ नोड, वन इज द नेशनल गेटवे and second one is the international gateway। तो दोनों जो गेटवे हैं वो लगभग सेम ही है, दोनों में कोई खास डिफरेंस नहीं है। बट दिस नेशनल गेटवे और इंटरनेशनल गेटवे में जो डिफरेंस है वो है जीआरएम का। जीआरएम इज द ग्लोबल रिसोर्स मैनेजर, ग्लोबल रिसोर्स मैनेजर। इसका मतलब क्या हुआ कि अगर किसी गेटवे के पास जीआरएम इंस्टॉल्ड है तो दैट गेटवे विल बिकम इंटरनेशनल गेटवे, अदरवाइज वो क्या होगा, नेशनल गेटवे होगा। तो इन केस ऑफ इंडिया वी आर हैविंग द नेशनल गेटवे। ठीक है, जीआरएम का मतलब है ग्लोबल रिसोर्स मैनेजर। यहाँ पे क्या है, इन केस ऑफ दिस इनमारसेट जो एलोकेशन ऑफ रिसोर्सेज है दैट इज डायनामिक। ठीक है, तो हम लोगों ने जैसे क्या कर रखा है कि सपोज इफ आई ड्रॉ द मैप ऑफ इंडिया लाइक दिस, आई एम ड्रॉइंग इट रफली ना, sorry for that, and suppose this is J and K, है ना, this is suppose this is the यूपी। तो बेसिकली सैटेलाइट से क्या होता है ना, स्पॉट बीम्स आती है जो मैंने आपको पहले बताया था। सपोज दिस इज द स्पॉट बीम फॉर J&K एंड दिस इज द स्पॉट बीम फॉर यूपी वेस्ट, for UP. Suppose some subscriber is there at UP na, and he want to make some outgoing call through the satellite phone. So in that case, this request will go to the national gateway that this subscriber in UP West wants to make some outgoing call. And to give the channel or to give the carrier for that call, this national gateway it will request to the international gateway GRM that for this particular call you give me the resource, and only then the resource will be allocated by the GRM. इसका मतलब क्या हुआ, एलोकेशन ऑफ द रिसोर्सेज इज डायनामिक। जब कोई ट्रैफिक होगा, इनकमिंग कॉल है या आउटगोइंग कॉल है, ओनली देन द रिसोर्स विल बी एलोकेटेड। सो दिस इज द ब्यूटी ऑफ दिस सिस्टम। अब मान लो क्या हुआ कि ये जो कैरियर है वो J&K के लिए है, ये वाला जो कैरियर है वो यूपी के लिए है, एंड सपोज दिस इज आंध्र प्रदेश, और आंध्र प्रदेश में क्या हुआ, कोई साइक्लोन आ गया है, some natural calamity is there. So in that case, we need more carriers here. So what we will do, we can allot these carriers to this region. So this is the beauty of this Inmarsat system, that we can assign our carriers, we can assign our resources to the area where they are needed. ऐसा नहीं है कि ये कैरियर हमेशा J&K के लिए आता रहेगा। अगर ट्रैफिक है तो वी विल गिव द कैरियर, इफ देयर इज नो ट्रैफिक तो वी विल नॉट असाइन द कैरियर, दिस कैरियर विल बी यूटिलाइज्ड समवेयर एल्स जहां पे इसकी जरूरत है। तो ये जो एलोकेशन ऑफ द रिसोर्सेज है दैट इज विद द हेल्प ऑफ दिस जीआरएम। तो इन इंडिया वी आर हैविंग द नेशनल गेटवे। अब इन केस ऑफ दिस इनमार्सेट व्हाट वी आर हैविंग सम सर्विसेज। तो यहाँ पे जो वॉइस की जो सर्विस है दैट इज द जीएसपीएस। जीएसपीएस क्या है, ग्लोबल सैटेलाइट फोन सर्विस, ग्लोबल सैटेलाइट फोन सर्विस। तो जीएसपीएस इज बेसिकली, सर वेयर इज द नेशनल गेटवे, नेशनल गेटवे फॉर इज अवेलेबल एट ALTTC गाजियाबाद। So in case of Inmarsat, the name of the voice service is GSPS, Global Satellite Phone Service, and this is based on C-band. So name of the voice service for Inmarsat is GSPS, and this is based on the C-band. Now advantage क्या है C-band का, कि अगर हम लोग KU बैंड में या का बैंड में ऑपरेट करते हैं तो अगर रेन हो जाए या स्नोइंग हो जाए तो दैट सर्विस विल बी अफेक्टेड, बट वी आर यूजिंग सैटेलाइट फोन फॉर इमरजेंसी पर्पज ना, तो दैट शुड नॉट बी अफेक्टेड। तो ये जो सी बैंड है ना, दिस इज नॉट अफेक्टेड बाय इन्वायरमेंटल कंडीशंस। सो ये हमेशा आंधी हो, तूफान हो, कैसा भी मौसम हो, इट विल ऑलवेज वर्क। सो दैट इज ऑल्सो द ब्यूटी ऑफ दिस जीएसपीएस सर्विस। तो जीएसपीएस सर्विस इट इज बेस्ड ऑन सी बैंड एंड दैट इज द सर्विस फॉर द वॉइस। तो यहाँ पे इन्होंने मेंशन भी किया, बीएसएनएल इज द इंडियन टेलीकम्युनिकेशन पार्टनर ऑफ इनमार्सेट। BSNL is holding valid license issued by Department of Telecommunication, Government of India. ओके ये मैं बाद में बताऊंगा अभी आपको। ये इन्होंने यहाँ पे मेंशन किया है जीएसपीएस ना, BSNL has installed and commissioned gateway for Inmarsat GSPS service, ग्लोबल सैटेलाइट फोन सर्विस एट ALTTC गाजियाबाद। तो इसका जो बेसिकली जो गेटवे वो कहाँ पर इंस्टॉल्ड है, एट ALTTC गाजियाबाद, and it has started providing GSP service with effect of this. So GSPS is the service for voice. Another service is the दिस IFMC क्या है? इन फ्लाइट मेरी टाइम कनेक्टिविटी। इन फ्लाइट एंड मेरी टाइम कनेक्टिविटी। तो अभी कुछ न्यूज में भी था कि ड्यूरिंग प्लेन के अंदर भी हम लोग वॉइस कॉल कर सकते हैं या नेट यूज कर सकते हैं। सो दैट इज थ्रू दिस IFMC ना, in flight and maritime connectivity. So this is also one service available on Inmarsat. So BSNL is now approved to offer IFMC service, which will include Inmarsat's Global Express. Basically क्या है, जो Inmarsat है ना, they are having one service जिसका नाम है GX। GX is Global Express ना। तो इसको यूज करके हम लोग इन फ्लाइट के अंदर भी, और जो नेवल शिप्स है, मेरीटाइम मीन्स शिप्स और द नेवल, तो वहां भी हम लोग सर्विस दे सकते हैं। सो दैट इज द IFMC सर्विस। तो GSPS हो गया फॉर वॉइस, दैट इज बेस्ड ऑन सी बैंड। एंड IFMC क्या है? इन फ्लाइट एंड मेरीटाइम कनेक्टिविटी। इसकी हेल्प से हम लोग वी कैन अवेल द इंटरनेट एंड वॉइस इन एरोप्लेन ऑल्सो। सो दैट इज द IFMC सर्विस। देखिए ये यहाँ पे इन्होंने मेंशन किया है GMDSS सर्विस ना। तो GMDSS क्या है? GMDSS इज द ग्लोबल मैरीटाइम डिस्ट्रेस सेफ्टी एंड डिस्ट्रेस एंड सेफ्टी सर्विस साइड, सेफ्टी सर्विसेज और सिस्टम्स ना। सो बेसिकली दिस GMDSS इज फॉर मेरी टाइम, जो नेवल शिप्स हैं या जो शिप्स सी के अंदर जा रहे हैं। तो बेसिकली सपोज कोई साइक्लोन आ जाए, तो हाउ दे विल कम्युनिकेट टू दी बेस कि वी आर स्टक इन दी साइक्लोन। So this system is there, GMDSS ना। So with the help of that they can communicate in emergency. So that is the GMDSS service. और अभी जो अर्लियर क्या था कि फॉर दिस इनमारसैट ऑपरेशंस ना, वी वर यूजिंग दिस सैटेलाइट I4 सैटेलाइट। कई बार आता है कि विच सैटेलाइट वी आर यूजिंग फॉर दिस इनमारसैट सर्विसेज ना, तो दैट इज दी दिस I4 सैटेलाइट। बट आई थिंक राइट नाउ ये जो I4 सैटेलाइट है ये डाउन हो गया है, और राइट नाउ वी आर यूजिंग दिस I3 सैटेलाइट। बट क्योंकि ये मटेरियल में I4 ही मेंशन है, तो फिर यही आप लोग याद रखिए I4। तो फॉर दिस इनमारसेट ऑपरेशंस ना वी आर यूजिंग दिस I4। तो इसके अंदर जो मेन जो पॉइंट्स हैं वो यही है कि आपका जो इनमारसेट क्या है, इंटरनेशनल मेरीटाइम सैटेलाइट ऑर्गेनाइजेशन। फिर ये फॉर वॉइस वी आर हैविंग दिस GSPS सर्विस दैट इज बेस्ड ऑन सी बैंड। one more service is there, that is the IFMC, in flight and maritime connectivity. With the help of that we can avail voice and data in aeroplane and on the naval ships. Then the hub or the national gateway for this Inmarsat is installed at ALTTC Ghaziabad. For GSPS we are using this satellite I4 satellite. अभी ये यहाँ पे I4, आई थिंक राइट नाउ वी आर यूजिंग दिस I3 सैटेलाइट, क्योंकि I4 साइड डाउन हो गया, बट ये I4 ही मेंशन है, तो आप लोग ये याद रखिए इसमें। तो इसके अंदर बस यही इंपॉर्टेंट पॉइंट्स है फॉर दिस इनमारसेट। ये बहुत ही अच्छी सर्विस है और काफी पॉपुलर है इन द फील्ड। So that's all for this overview of SATCOM. So again, if I revise the main points, Overview of SATCOM, we discussed the advantage of satellite communication. Satellite communication, large coverage is there. We can use it in case of emergency. हार्ड टेरेन एरिया में हम लोग इसको यूज कर सकते हैं, नेक्स्ट लाइट एरिया में हम लोग इसको यूज कर सकते हैं. डिसएडवांटेज क्या है? लेटेंसी इज देयर. सो लेटेंसी थोड़ी ज़्यादा है, तो दिस इज द डिसएडवांटेज इन केस ऑफ द सैटेलाइट कम्युनिकेशन. देन वी डिस्कस्ड द different orbits: low Earth orbit, medium Earth orbit, geosynchronous orbit, geostationary orbit. In case of geostationary orbit, altitude is around 36,000 kilometer. Time period is 24 hours. In case of satellite, normally we are operating in line of sight mode. Then we discussed the different frequency band: L band, C band, KU band, Ka band. KU and Ka we are using for VSAT operations. C we are using for satellite based mobile communication. L band को हम लोग यूज करते हैं एज IF frequency. Then we discussed the VSAT, very small aperture terminal. It is having ODU, outdoor unit, and indoor unit. In outdoor unit, we are having BUC, block up converter, LNB, low noise block down converter. Connecting cables are there. Feed is there, horn feed is there, this is there. So they are the part of outdoor unit. At the indoor unit, we are having modem and PC. They are the part of the indoor unit. Then we see the DLA, dynamic link allocation. So as per the link quality, we can avail the modulation scheme. Then some advantage of the VSAT. Then we discussed the DSPT, digital satellite phone terminal, and hub of DSPT is at Secunderabad. We see the ULPC, uplink power control. SSPA is solid state power amplifier. HPA is high power amplifier. HPA is used in transmit side. LNA, low noise amplifier. LNA is used in receiver side. And in the end, we discussed the Inmarsat, International Maritime Satellite Organization. इसके अंदर जो वॉइस सर्विस है, दैट इज द GSPS. इट इज यूज्ड इन C band. Name of the satellite is I4. Then we have IFMC, in-flight maritime connectivity. So these are the important points for this topic. Or you can go through the PDF that is already available with you. So I think that is all. That's all for this topic. So thanks to all the participants, and please wait for the next lecture. Thank you. Sir, can you explain the call flow of Inmarsat for national and international call? I can explain, but time is not there. So we will do it later on, और कभी आप ट्रेनिंग कुछ होगी हम लोग करेंगे तो then we can explain it. And I think in March na we are doing one course on Inmarsat. So you please join that course. Why you are not picking my phone? Rajendra ji, I will call you. So thanks to all the participants, and please wait for the next session.
Namaskar. Are you able to see my screen? Participant, can anybody confirm that you are able to see screen, or am I audible? Yes. Okay. Okay. Namaskar. So now we are going to open our mobile course for this LIC. The first topic of GSM or mobile communication is the basic of mobile communication. In this presentation, we are going to cover 3 topic. पहला इसमें होगा basic of mobile communication. इसमें we will see about the cellular concept, something about the cell structure and GSM architecture. फिर इसमें second topic होगा we will cover 3G and third is HSDPA. तो इसमें बेसिकली हम 3 टॉपिक कवर करने की कोशिश करेंगे. फर्स्ट होगा मोबाइल कम्युनिकेशन और जिसमें हम समथिंग अबाउट जनरल मोबाइल कम्युनिकेशन के बारे में देखेंगे, सेलुलर कॉन्सेप्ट एंड फ्रीक्वेंसी क्लस्टर, समथिंग अबाउट द फ्रीक्वेंसी स्पेसिफिकेशन. देन सेकंड वन इज द 3G UMTS एंड थर्ड वन इज HSDPA. तो स्टार्ट करते हैं हम मोबाइल कम्युनिकेशन से. द मोबाइल कम्युनिकेशन स्टार्ट फ्रॉम द सेलुलर कॉन्सेप्ट. जो भी मोबाइल कम्युनिकेशन है दैट इज बेस्ड ऑन सेल. इसमें एक BTS होता है, जनरली द एरिया कवर्ड बाय वन BTS. ये जनरल टर्म है. वन एरिया कवर्ड बाय वन BTS इज नोन एज सेल, बट कंडीशन इज दैट BTS should be the omnidirectional. But nowadays we are not using the omnidirectional BTS. Instead of omnidirectional, we are using the sectored BTS. So in other words, you can say the area covered by one sector is known as cell. So cell is a basic geographical unit. यहाँ पर आप देखेंगे cell is the basic geographical unit of cellular system. तो सबसे छोटी यूनिट होती है दैट इज द सेल. अब जैसा मैंने बताया ना कि एकेडमिकली देयर आर लॉट ऑफ डेफिनेशन अबाउट द सेल. जैसे एक डेफिनेशन है एरिया कवर्ड बाय वन ट्रांसमीटर. तो इन दिस केस ट्रांसमीटर इज ए जो एक सेक्टर बनता है BTS का वो होता है. या अदर वर्ड यू कैन से द एरिया कवर्ड बाय वन एंटीना वन BTS. तो दैट इज ए सेल. क्वेश्चन भी समथिंग लाइक दैट ऐसा ही आता है. विच इज द बेसिक जियोग्राफिकल यूनिट इन सेलुलर सिस्टम. तो दैट इज द सेल. थ्योरेटिकली जो शेप होती है सेल की दैट इज हेक्सागोनल. थ्योरेटिकल शेप होती है सेल की दैट इज हेक्सागोनल. इन दिस फिगर यू आर एबल टू सी this black one, this is a cell 1 and that is the shape of this cell is hexagonal. Please wait. Yes, sorry. So the shape of one cell is hexagonal, but that is theoretical. अगर हम प्रैक्टिकल की बात करेंगे तो देर इन प्रैक्टिकल देर इज नो शेप ऑफ सेल. सेल की कोई शेप नहीं होती. ये जिगजैग टाइप की शेप होती है. ओके, तो यू हैव टू पे अटेंशन ऑन दिस वर्ड आल्सो. अगर थ्योरेटिकली पूछा जाएगा देन दैट शुड बी द हेक्सागोनल और अगर प्रैक्टिकली होगी तो जिगजैग. You are able to see hexagon. That is the shape. Now, the combination of cell or group of cell or the planning point of view known as cluster. एक जैसे इस एग्जाम्पल में 7 सेल के ग्रुप को वी आर सेइंग द क्लस्टर. You are able to see that in this there are 7 cells. 1, 2, 3, 4, 5, 6, 7. So this is one of group of cell known as the cluster. तो basically इस फिगर में 3 cluster हैं, 1, 2 and 3. Okay, so that is the concept of cluster. You are able to see here also that is the 7 cell of cluster A, B, C, D. ये एक क्लस्टर की डेफिनेशन है. द स्पेक्ट्रम. नाउ द स्पेक्ट्रम एलोकेट फॉर ए सेलुलर नेटवर्क इज लिमिटेड. जीएसएम में हमारा स्पेक्ट्रम लिमिटेड होता है, तो क्लस्टर में वी आर नॉट गोइंग टू रीयूज द सेम फ्रिक्वेंसी. एवरी सेल हैज डिफरेंट फ्रिक्वेंसी and the same cluster can be repeat here and here. So A represent the same frequency in this cell and this same A is also have the same frequency. ये दोनों सेल में हमारे पास सेम फ्रिक्वेंसी होगी, बट देयर इज ए डिस्टेंस बिटवीन दीज टू सेल और अप्रोक्सीमेट ये दो सेल की डिस्टेंस इन दोनों के बीच में है. That is the cluster. Now I think you are able to understand. One is the cell. Okay. Now I think you are able to appreciate that cell is a basic geographical unit and cluster is the combination of cell. Now the type of cell. Type of cell according to size and according to application. Different types of cell we have in the mobile system. These 3 cells are according to size. जो सबसे छोटी सेल होती है that is known as pico and pico से बड़ी होती है micro then macro cell. इनके uses भी different हैं. Pico cell basically we made pico cell in urban area and that is for the कैपेसिटी पॉइंट ऑफ व्यू. जहां पर हमें कैपेसिटी बढ़ानी होती है या अर्बन एरिया होता है जहां पर यू कैन से सब्सक्राइबर डेंसिटी ज्यादा होगी, देन वी हैव टू मेक पीको सेल. सेमी अर्बन एरिया वी हैव द माइक्रो सेल एंड माइक्रो सेल इज more than bigger than pico cell, and macro cell that is a largest cell we have in this, and that is it for application point of view. Umbrella cell and selective cell. अम्ब्रेला सेल जनरली हम हाईवे पर सेल जो साइट बनाते हैं थोड़ी बड़ी होती है, ऊंची होती है, दैट इज द अम्ब्रेला सेल. इन वन अम्ब्रेला सेल वी हैव ए मैनी मैक्रो और माइक्रो सेल. ओके, दीज आर द टाइप्स ऑफ सेल. देन वी आर गोइंग टू सेक्टराइजेशन ऑफ द सेल. बहुत अर्लियर स्टेज में जो बीटीएस होते थे दैट वाज द ओमनी डायरेक्शनल. एक बीटीएस में एक ही सेल होती थी, बट स्लोली जैसे जैसे कैपेसिटी इंक्रीज हुई वी आर गोइंग फॉर द सेक्टराइजेशन. हमने एक ही सेल को 3 सेक्टर में डिवाइड किया. नाउ दो सेक्टर इज नोन एज द सेल. तो वो जो सेक्टर थे उनकी जो रेडियस यू कैन से दैट 120 डिग्री, क्योंकि अगर आप एक सेल जो 360 डिग्री कवर कर रही है उसको आप 3 सेल में डिवाइड करेंगे तो 1 सेल जो कवर करेगी दैट इज 120 डिग्री एरिया वो कवर करेगी. तो दैट इज द सेक्टराइजेशन. नाउ नेक्स्ट टॉपिक इज फीचर्स ऑफ डिजिटल. डिजिटल मीन्स जीएसएम को डिजिटल कम्युनिकेशन सिस्टम बोला गया था. उससे पहले जो 1G था दैट वाज द एनालॉग. तो एनालॉग से हम डिजिटल में जब शिफ्ट करें तो उसका क्या पर्पस था, क्या फीचर थे. तो दैट इज द स्मॉल सेल. इन डिजिटल वी हैव द स्मॉल सेल. इन डिजिटल कम्युनिकेशन और जीएसएम वी आर गोइंग फॉर द फ्रीक्वेंसी रीयूज. सेम फ्रीक्वेंसी कैन बी रीयूज आफ्टर ए पर्टिकुलर distance that known as frequency reuse. It have small battery powered handset. आजकल जो हम हैंडसेट यूज करते हैं सब 2 मिली वॉट के हैंडसेट हैं. तो इन दिस वी आर एबल टू यूज द small battery powered handset. Okay, now that is all about the basic of mobile communication. Now we are going over the GSM 2G. 2G is an example of cellular mobile system that is can be used the frequency and frequency can be reused. Now what are the objective of mobile communication? मोबाइल कम्युनिकेशन के क्या ऑब्जेक्टिव थे? ये बात हो रही है 2G के जमाने की, जब 2G हमारा आया था। तो दैट इज द कंपैरिजन बिटवीन 2G एंड लैंडलाइन। अगर आप ये देखेंगे, ये जो कंपैरिजन लिखा हुआ है दैट इज कंपैरिजन ऑफ लैंडलाइन, लैंडलाइन से कंपैरिजन है। तो क्या था मोबाइल का ऑब्जेक्टिव? एनी टाइम एनीवेयर, क्योंकि आप मोबाइल को लेकर मूव कर सकते हैं, एनीवेयर यू कैन यूज योर मोबाइल और एनी टाइम। ठीक है, इट कैन प्रोवाइड यू द मोबिलिटी एंड रोमिंग। मोबिलिटी का मतलब है बीटीएस टू बीटीएस एंड रोमिंग का मतलब है एक्सचेंज टू एक्सचेंज, एमएससी टू एमएससी और एचएलआर टू एचएलआर। that is possible in 2G. It can give us high capacity because in GSM we are using the FDMA TDMA concept. So it can give us high capacity and subscriber identity. कुछ सब्सक्राइबर आइडेंटिटी होती हैं, आगे चलकर वी विल सी अबाउट द सब्सक्राइबर आइडेंटिटी, MSISDN, IMSI and TIMSI type of identity we will see in the this topic. Efficient use of radio spectrum. It is a very precious resource और we have to use very efficiently. GSM में हम TDMA की हेल्प से एक ही फ्रिक्वेंसी पर 8 सब्सक्राइबर रन कर सकते हैं, तो दैट इज द एफिशिएंट यूज ऑफ रेडियो स्पेक्ट्रम. Seamless networks architecture. It is low cost. It have innovative services. Standard interface. अब आप इस एग्जामिनेशन पॉइंट ऑफ व्यू से इस टेबल पर ध्यान देंगे. तो दैट इज ए टेक्नोलॉजी. Here we are going to compare technology 1G to 4G and 1G, 2G, 2.5G, 3G, 4G. In approximate, in every technology we have a 10-year gap. जैसे फर्स्ट 1G जो है वो 1970 में है, 2G 1980 में है, 3G 1990s में है एंड 4G 2000 में है. तो यहाँ पर आप देखेंगे एवरीथिंग, एवरी टेक्नोलॉजी हैव 10-year गैप. इम्प्लीमेंट उनका भी अप्रोक्सीमेट 10 ईयर के बाद ही हो पाता है. जैसे 1970 टू 1980, 1980 टू 1991, 90s वाला 2000 एंड 2000 वाला 2010. व्हाट वर द पर्पज? क्या मेन सर्विसेज थी जो वी कैन गिव अस बाय द जनरेशन? जैसे कि 1G में वी कैन गिव अस ओनली द एनालॉग सर्विस एंड 2G इट कैन गिव अस digital service and SMS and very limited data access. ठीक है, जैसे 1G थी that is only for the analog services. Analog voice service was possible in 1G, but in 2G we can give digital voice services, SMS and limited data services. Then 3G can give us ब्रॉडबैंड लाइक सर्विसेज, बिकॉज ब्रॉडबैंड की जो डेफिनेशन है वो 256 या 2 Mbps आप कह सकते हैं. तो दैट इज पॉसिबल इन 3G. तो वी कैन राइट इन 3G वी कैन गिव अ ब्रॉडबैंड टाइप ऑफ सर्विस विद द हेल्प ऑफ 3G. एंड 4G इज IP ओरिएंटेड सर्विसेज दैट इज पॉसिबल इन 4G. नाउ क्या क्या टेक्नोलॉजी और क्या क्या स्टैंडर्ड अवेलेबल थे 1G में? जैसे MPS है. 2G में आप देखेंगे तो GSM और CDM में दो टेक्नोलॉजी थी. GSM को जनरली वी आर सेइंग द TDM में बेस्ड सिस्टम. GSM को हम TDM में सिस्टम भी बोलते हैं और CDM में को तो CDM में ही बोलते हैं. देन 3G में दो जनरेशन थी. वन इज जनरेशन ऑफ GSM की ए हेड जो जनरेशन है दैट इज UMTS, और जो CDMA की जनरेशन थी दैट वाज नोन एज E-Video, उसको हमने E-Video बोला था. ठीक है. द सेम वे इन 4G में एक जनरेशन है हमारी WiMAX और दूसरी है LT. और ये बैंडविड्थ है. बैंडविड्थ क्या है? ये बेसिकली इन्होंने डाटा बैंडविड्थ नहीं है, डाटा स्पीड होना चाहिए. 1G में ओनली 1.9 kbps स्पीड पॉसिबल थी। 2G में इट कैन बी 14 kbps। 3G it can go up to 2 Mbps, and 4G they have written 200 Mbps। क्या क्या नाम थे इनके? GSM 2G टेक्नोलॉजी का नाम GSM है। 2.5G टेक्नोलॉजी नोन एज GPRS। 3G टेक्नोलॉजी नोन एज UMTS। 4G टेक्नोलॉजी नोन एज LT लॉन्ग टर्म इवोल्यूशन। तो अगर आप इस पेज पे ध्यान देंगे तो देयर आर लॉट ऑफ क्वेश्चंस। ठीक है, जो नॉलेज पॉइंट ऑफ व्यू से नहीं है, बट अगर कोई क्वेश्चन बनाता है तो इस पेज में से बहुत सारे क्वेश्चन बनते हैं, बिकॉज दैट इज ए डेटाबेस टाइप ऑफ PPT। ठीक है, ईयर भी पूछे जा सकते हैं, स्पीड पूछी जा सकती है, स्टैंडर्ड पूछे जा सकते हैं। ठीक है, तो क्वेश्चन जनरली इसी टाइप के बनते हैं। बट इसमें ना कभी कभी कंफ्यूजन रहता है, जैसे इसमें यहाँ पर आप देखेंगे टेबल में 200 लिखा है और इस पिक्चर में देखेंगे यहाँ पर जो है 100 Mbps लिखा है। तो ठीक है, देखना पड़ेगा ये 200 है कि 100 है। ठीक है, यू आर एबल टू सी ना in this figure LT can give us only maximum speed is 100 Mbps, but here it can give us 200 Mbps. Okay, and that is a very small type of questions are here: GSM, GPRS, AG, UMTS, HSDP, and LT. Now this figure in GSM we have the mobile station, then core equipment that can be connected to the PSTN. तो ये एक बेसिक आर्किटेक्चर है। and in GSM we have two link, one known as forward link and another one known as reverse link। ठीक है, जो फॉरवर्ड लिंक है that was also known as डाउन लिंक। जो फॉरवर्ड लिंक है उसको हम डाउन लिंक भी बोलते हैं, रिवर्स लिंक को आप अप लिंक बोलते हैं। जनरली जो फॉरवर्ड लिंक है उसमें हम हायर बैंड यूज करते हैं, एंड जो रिवर्स लिंक है उसमें हम लोअर बैंड यूज करते हैं। दो मेथड हैं डुप्लेक्सिंग के, वन इज FDD मोड एंड अदर वन इज TDD मोड। तो FDD मोड का मतलब है फ्रिक्वेंसी डिवीजन डुप्लेक्स, एंड TDD मोड का मीनिंग है टाइम डिवीजन डुप्लेक्स। अगर आप पेयर ऑफ फ्रिक्वेंसी यूज कर रहे हैं तो दैट इज FDD मोड। उसमें दो फ्रिक्वेंसीज होती हैं, एक लोअर बैंड की फ्रिक्वेंसी होगी, एक अपर बैंड हायर बैंड की फ्रिक्वेंसी होगी। ठीक है, तो फ्रिक्वेंसी डिवीजन डुप्लेक्स यहाँ पर बेसिकली दो फ्रिक्वेंसी होगी। जनरली वी आर सेइंग up to 3G we are working only with FDD। ठीक है, now in 4G we have the combination of FDD and TDD। तो GSM में और 3G में हमने TDD यूज नहीं किया था। TDD का मतलब है देयर इज ओनली वन सिंगल फ्रिक्वेंसी एंड द सेम फ्रिक्वेंसी आर यूज इन अपलिंक एंड डाउनलिंक। नाउ द बैंड इन GSM वी हैव टू बैंड। इंडिया में हमने दो ही बैंड यूज किए थे, वन इज GSM 900 एंड अदर वन इज GSM 1800। ठीक है, तो उसकी स्पेसिफिकेशन लिखी हुई है जैसा हमने बताया, देयर आर बिकॉज दिस इज द FDD बैंड। तो लोअर बैंड इज यूज बाय द मोबाइल एंड हायर बैंड इज यूज बाय द ट्रांसमीटर टू रेडिएट। 890 to 915 ये 25 मेगाहर्ट्ज का बैंड है, and the same corresponding band for downlink, that is 935 to 960। okay, this is the GSM 900 band, it also known as PGSM band। P means the primary GSM band, and other band is 1800 DCS digital communication system। ये 1800 का बैंड है। 75। so now we will see this table again, this is an important table। ठीक है, uplink frequency 890 to 950 25 megahertz, the same for downlink 935 to 960, and here this is the 75 95 oh sorry 75 megahertz band, 710 to 785 and 805 to 880 for the downlink। and duplex distance होती है आपकी अपलिंक और डाउनलिंक फ्रिक्वेंसी का जो डिफरेंस होता है। 900 में ये डिफरेंस 45 मेगाहर्ट्ज का होता है। फॉर एग्जांपल अगर आपको अपलिंक में 890 मिली है, तो उसमें +45 करेंगे तो आपको 935 डाउनलिंक में मिलेगी। द सेम वे here the frequency division duplex distance in GSM 1800 that is 95 मेगाहर्ट्ज। अगर आपके यहाँ 710 इन अपलिंक है तो इसमें आप 95 प्लस करेंगे तो देन इट विल बिकम 1805 दैट इज द 95। तो क्वेश्चन बड़ा सिंपल है, व्हाट इज द फ्रीक्वेंसी division duplex distance in GSM 900, so that is 55 and in 1800 that is 95. Now the carrier separation, every carrier either it is in 900 or it is in 1800, both the carrier separation कह सकते हैं, carrier bandwidth कह सकते हैं, that is 200 किलोहर्ट्ज। तो 200 किलोहर्ट्ज का एक कैरियर होता है जीएसएम में। अब चाहे ये 900 बैंड का हो चाहे 1800 बैंड का हो, इस 200 को अगर आप 25 से डिवाइड करेंगे, 25 मेगाहर्ट्ज को 200 किलोहर्ट्ज से डिवाइड करेंगे तो टोटल कैरियर नंबर ऑफ कैरियर आएंगे 125 एंड हेयर 375। वन एक गार्ड कैरियर रख ले, बचा लेते हैं तो ये बने 124 एंड 374। वॉइस बिट रेट इन एयर, एक सब्सक्राइबर की एयर में जो बिट रेट होती है दैट इज 13 kbps। पीएसटीएन में ये 64 kbps होती है, लेकिन जीएसएम में इट इज 16 kbps। 13 + 3, 13 आपकी बिट रेट होती है, 3 आपकी इनबैंड सिग्नलिंग होती है, तो इट विल बिकम द 16 kbps। तो आप जीएसएम पीएसटीएन में जो 64 kbps की स्पीच होती है, जीएसएम में वही स्पीच हमारी कितनी kbps की हो जाती है, आइदर यू कैन से इट इज 13 kbps और कभी कभी आप इसको कह सकते हैं 16 kbps, क्योंकि इसमें 3 kbps की इनबाउंड सिग्नलिंग भी होती है। और एयर ट्रांसमिशन रेट, एयर ट्रांसमिशन का मतलब है जो 8 टाइम स्लॉट होते हैं आपके 1 TDMA फ्रेम में, उसमें सारी बिटों को मिलाकर जो फाइनल बिट रेट बनती है ओवर एयर इंटरफेस दैट इज 270.83 kbps। And what is the access method in GSM? Access method in GSM, multiple access method in GSM, that is FDMA and TDMA. The combination of FDMA और TDMA, अगर FDMA और TDMA में सिंपल TDMA लिखा है तो it will known as TDMA multiple access method, and speech coder is RP, LTP, and duplexing is FDD. So that is all about the GSM specification. Now we are going over the GSM network structure, that is a GSM network geographical structure. So in this figure, the smallest geographical area is known as cell, फिर बहुत सारे सेलों को मिलाकर एक एरिया बनता है, that area will become the location area, and then location areas को मल्टीप्लाई करेंगे, कुछ ग्रुप में डिवाइड करेंगे, देन इट विल बिकम द एमएससी एरिया, देन पीएलएमएन एरिया। फॉर अंडरस्टैंडिंग पॉइंट ऑफ व्यू आप कह सकते हैं सेल इज ए 1 बीटीएस एरिया, जो एरिया एक बीटीएस के थ्रू कवर्ड होता है, एंड द एरिया लोकेशन एरिया इज द 1 बीएससी एरिया, मीन्स द जो भी उस बीएससी से जितने बीटीएस कनेक्ट हैं और वो जो एरिया कवर्ड करते हैं दैट ऑल कम्स इन द कैटेगरी ऑफ लोकेशन एरिया। तो ये बीटीएस, बीएससी एंड एमएससी अंडरस्टैंडिंग, ठीक है। ये एरिया हो गए जीएसएम के जो डिवाइड है। नाउ द नेटवर्क आर्किटेक्चर, अवर जीएसएम सिस्टम इज डिवाइडेड इनटू द 4 नेटवर्क सब सिस्टम। बेसिकली हमारा जो जीएसएम सिस्टम है वो 4 सब सिस्टम में डिवाइडेड है, यहाँ पर 3 लिखे हुए हैं बिकॉज दे हैव नॉट कंसिडर्ड द एमएस। एमएस इज आल्सो द वन unit of this GSM network architecture. MS is mobile station. Second subsystem is the BSS, base station subsystem, and third one is the NSS, network switching subsystem, and fourth one is the OMS or OSS, operating support subsystem. ये बेसिक एक आर्किटेक्चर है जीएसएम का। This is MS, this is BSS, and the whole they comes in the category of NSS, ठीक है। MS में 2 चीजें होती हैं, एक ME एक SIM। ME means mobile equipment. Mobile equipment which you have purchased from the shop. किसी शॉप से आप जो एक मोबाइल परचेज करते हैं, that known as ME, mobile equipment. This one, mobile equipment, and every mobile equipment has one identity जिसको हम बोलते हैं IMEI, International Mobile Equipment Identity. Each MS is defined by an EMEI identity. ठीक है, that is permanently stored in the mobile equipment. और उसमें एक ME के साथ एक और सिम होता है. You have to purchase SIM, subscriber identity module, which you have to purchase from the operator. And every SIM has one another identity. उसकी एक और आइडेंटिटी होती है जिसको आप जानते हैं MSISDN नंबर, जो आपका जनरली टेलीफोन नंबर होता है 94180 something like that. And this SIM also have a permanent identity which is known as International Mobile Subscriber Identity, IMSI. तो बेसिकली दो आइडेंटिटी हो गई. वन आइडेंटिटी होती है ME में बिल्ड होती है, डेट इज IMEI, इंटरनेशनल मोबाइल इक्विपमेंट आइडेंटिटी, और दूसरी परमानेंट आइडेंटिटी होती है IMSI, डेट इज अवेलेबल इन सिम. तो ये दो आइडेंटिटी हो गई. इस IMSI पर MSISDN मैप किया जाता है. ओके, एंड TIMSI वी विल सी दीज आइडेंटिटी इन डिटेल आल्सो. अभी आगे ये डिटेल में है. फिर इन्होंने अकॉर्डिंग टू पावर देयर आर 5 टाइप्स ऑफ हैंडसेट विच वर यूजिंग इन GSM. बहुत पुरानी बात हो गई, अब हम ये सब यूज नहीं करते हैं, बट यहाँ पर लिखा है. तो ये 5 टाइप के हैंडसेट हैं अकॉर्डिंग टू पावर विच वी वर यूजिंग इन GSM. 0.8 वाट, 2 वाट, 5 वाट, 8 वाट एंड 20 वाट. तो जनरली हम जो यूज करते हैं दैट वाज कैटेगरी इन दिस 2 वाट. Okay, now that is all about the BTS. Oh, that is all about the MS. Now the second part is BSS in this figure. This is the BSS. In BSS there are two main equipment. One is the BTS and other one is the BSC. एक BTS होता है, दूसरा होता है BSC. So what is the functionality of BTS here? BTS is base ट्रांस रिसीवर स्टेशन. तो BTS का मेन काम क्या होता है? फ्रिक्वेंसी को ट्रांसमिट करना एंड रिसीव करना. BTS इज द बेस ट्रांस रिसीव स्टेशन. और ये क्या करता है? मेनली इट विल गिव यू द रेडियो इंटरफेरेंस. जो भी हमारी जनरेशन होती है 2G, 3G, 4G, जो भी जनरेशन दैट इज इन बिटवीन मोबाइल स्टेशन एंड BTS, that is work on RF interface, RF frequency. Okay, तो ये BTS का वर्क हो गया. इट विल गिव यू द रेडियो इंटरफेस. ये रेडियो इंटरफेस पे काम करती है. इट विल गिव यू द all frequencies, all radio resource. So the radio resources are provided by the BTS, and in GSM those radio resources are managed by the BSC. Here this line मैनेजमेंट. ठीक है, तो बेसिकली जो एक टर्म हो गई कि रेडियो रिसोर्स प्रोवाइडेड बाय द BTS एंड दो रेडियो रिसोर्स मैनेज बाय द BSC, बेस स्टेशन कंट्रोलर. नेम जो है वो सेल्फ एक्सप्लेनेटरी है, ये बेस स्टेशन का कंट्रोलर है. तो एवरीथिंग इज कंट्रोल्ड बाय द BSC. Okay, so here you will pay attention. There is another unit also available in BSS, which is known as TRAU. कभी कभी इसको TRC भी बोलते हैं. TRC और TRAU. TRC or TRAU, transcoder rate adaptation unit, because PSTN work on 64 and GSM work on 16 kbps. तो उस रेट को हमें ट्रांसपोर्ट करना होता है GSM टू PSTN या PCM और PCM टू GSM. GSM coded information को we have to change after BSc into the PSTN or PCM coded information, that is conversion done by the TRAU. एंड रेट को अडॉप्ट भी करना होता है, बिकॉज मीडिया जो होता है वो हमारा PSTN बेस्ड होता है या PCM बेस्ड होता है. अब उस 64 पर वी वांट टू कैरी द 16 kbps. तो वो किसकी हेल्प से हम कैरी करेंगे? दैट इज दैट यूनिट TRAU. It will do the transcoder and it will do the rate adaptation. I think I am clear. कि ये ट्रांसकोडर करता है GSM कोडेड इंफॉर्मेशन को PCM कोडेड इंफॉर्मेशन में चेंज करता है, एंड GSM कोडेड इंफॉर्मेशन जो 16 kbps इंफॉर्मेशन है उसको कैरी करता है इन 64 kbps मीडिया में. तो दैट इज नोन एज रेट अडेप्टेशन. ओके, so now I think I am clear. I have defined the BTS also, BSc also and TRAU. ये 3 यूनिट हो गई जो BSS में हमारे काम करती हैं. BTS हमें रेडी रिसोर्स प्रोवाइड कराता है, BSc रेडी रिसोर्स मैनेज करता है, और ट्रांसपोर्टेड एंड रेट अडेप्टेशन डन बाय द TRAU. नाउ वी कम्स ओवर द NSS. NSS के जो मेन पार्ट होता है दैट इज द MSC मोबाइल स्विचिंग सेंटर. अपार्ट फ्रॉम मोबाइल स्विचिंग सेंटर हमारे पास 4 रजिस्टर होते हैं या 4 स्टोरेज डिवाइसेस होती हैं जिनको वी आर सेइंग द VLR, HLR, EIR and AUC. VLR is visitor location register, HLR home location register, EIR equipment identity register, ओके, AUC authentication center. तो ये चारों और GMSC and GMSC they all become the NSS network switching system. तो MSC क्या है? MSC is the main node of mobile equipment which is responsible for the signaling, routing, traffic routing, charging and digit analysis. Everything is done by the MSC with the help of VLR. Basically VLR is also inbuilt into the MSC. हर MSC के साथ एक VLR इंटीग्रेटेड होता है. Okay, now that is all about the MSC. Now we comes over the VLR and HLR. VLR is also known as the temporary database. VLR को हम temporary database भी बोलते हैं, HLR को permanent database बोलते हैं, बिकॉज VLR में वो सारे सब्सक्राइबर होते हैं जो राइट नाउ विजिट कर रहे हैं इज इन दिस एरिया. जैसे फॉर एग्जांपल राइट नाउ वन हरियाणा सब्सक्राइबर राइट नाउ अवेलेबल इन यूपी वेस्ट. तो दैट सब्सक्राइबर इज आल्सो रजिस्टर्ड इन द यूपी वेस्ट VLR. तो जितने भी सब्सक्राइबर राइट नाउ जिस एरिया में विजिट कर रहे हैं उन सबका डेटा हमारे पास होता है VLR में, बिकॉज आपकी विजिट भी टेम्परेरी है, सो दैट इट नोन एज द टेम्परेरी डेटा बेस. VLR कलेक्टेड विद द MSC. ओके, तो जो भी MS रोमिंग है इन दिस MSC एरिया दैट इज अवेलेबल इन दिस VLR. ओके, एंड VLR इज अपडेटेड बाय द HLR. VLR में जब भी कोई सब्सक्राइबर आता है तो उसके HLR से VLR अपडेट होता है. And VLR also allocate TIMC against the MC. सब्सक्राइबर की परमानेंट आइडेंटिटी होती है MC, but when it entered in one VLR area, so for security point of view, VLR allocate one TIMC against the MC. MC के against वो आपको एक TIMC allocate कर देता है. That is also the role of VLR. Now HLR. HLR is a permanent database. जहाँ से आप सिम परचेज करते हैं, that is you are available in that particular HLR. Approximate you can understand like that every PLMN. PLMNs mean the BSNL Himachal, BSNL Haryana, एयरटेल हिमाचल, एयरटेल हरियाणा, ये सब क्या है, एक PLMN है. इन एवरी PLMN वी हैव वन HLR, एंड इफ यू परचेज सिम फ्रॉम द हरियाणा देन you will be available in the Haryana HLR, and whenever you entered some VLR area, that VLR contact to the your HLR और got the information, वो वहां से information लेगा. ठीक है. And HLR known as permanent database, it have the permanent data, but it also have some temporary data. जैसे VLR का एड्रेस, आप राइट नाउ जिस भी HLR VLR में है, that information is also available with your HLR, वो आपके HLR में भी अवेलेबल होगी. HLR का नाम ही आप विजिट कर रहे हैं कहीं पर, उस टाइम पर आपका डेटाबेस अवेलेबल है उस पर्टिकुलर VLR में. ओके, इसलिए दैट नोन एज विजिटर लोकेशन रजिस्टर. तो नाम भी अपने आप में एक्सप्लेन कर रहे हैं व्हाट इज द मीनिंग ऑफ VLR एंड व्हाट इज द मीनिंग ऑफ HLR. नाउ AUC. AUC is authentication center. Authentication center, it will authenticate the subscriber. जो भी आपके सब्सक्राइबर हैं उसको ऑथेंटिकेट करता है, दैट वन AUC. दैट इज आल्सो अवेलेबल इज इन HLR. बेसिकली HLR की ही एक लॉजिकल यूनिट है, उसको हम ऑथेंटिकेशन सेंटर बोलते हैं. द AUC स्टोर इंफॉर्मेशन दैट इज नेसेसरी टू प्रोटेक्ट कम्युनिकेशन थ्रू द एयर इंटरफेस. एयर इंटरफेस इज ए वेरी ओपन इंटरफेस, तो वहां पर हमें जो भी है प्रोटेक्ट करने के लिए हमें एक ऑथेंटिकेशन सेंटर की जरूरत पड़ती है. इट हैव टू मेनली टू डेटाबेस होते हैं जिससे हम ऑथेंटिकेट करते हैं. वन इज IMSI, अदर वन इज KI. IMSI इंटरनेशनल मोबाइल सब्सक्राइबर आइडेंटिटी, जो समथिंग लाइक यूजर ID होती है, एंड KI दैट इज समथिंग लाइक पासवर्ड. IMSI हम एयर में ट्रांसमिट करते हैं कभी कभी, बट वी नेवर ट्रांसमिट द KI ओवर द एयर इंटरफेस. जो आपकी आइडेंटिटी की है that is never be transmitted in the air interface. KI को कभी भी एयर इंटरफेस में ट्रांसमिट नहीं किया जाता. इंस्टेड ऑफ KI what we are going to transmit, we are going to transmit the signed response that is generated with the help of KI, IMSI and A3 algorithm. ठीक है, तो ये कुछ चीजें हैं जो इसी में चाहिए होती है. नाउ the EIR, Equipment Identity Register, that is required for the validation of मोबाइल सब्सक्राइबर. जो आपका मोबाइल सब्सक्राइबर होते हैं उसको मोबाइल इक्विपमेंट को वैलिडेट करने के लिए जो नोड काम आता है, डेट इज द EIR. जैसे नाम भी है इसका, इक्विपमेंट आइडेंटिटी रजिस्टर. EIR इज ए डेटाबेस दैट स्टोर द EMEI नंबर. ये किसको वैलिडेट करेगा, EMEI नंबर को, इंटरनेशनल मोबाइल इक्विपमेंट आइडेंटिटी को. बेसिकली इट हैज 3 लिस्ट. इसके पास 3 लिस्ट होती हैं. वन इज वाइट लिस्ट, ब्लैक लिस्ट एंड ग्रे लिस्ट. वाइट लिस्ट का मतलब है कि दो ऑल द सब्सक्राइबर हु इज जेन्युइन, वो सारे सब्सक्राइबर जिनके साथ कोई प्रॉब्लम नहीं है, जो फ्रीली कोई भी टेलीकम्युनिकेशन सर्विसेज यूज कर सकते हैं, दे ऑल आर अवेलेबल इन द वाइट लिस्ट. वो सारे सब्सक्राइबर कौन सी लिस्ट में अवेलेबल होंगे, that all available in white list. Blacklist, they contains the EMI mobile that have been reported stolen, और जो भी हमें बंद करने हैं वो सारे EMI नंबर हम किस में क्रिएट कर देंगे, ब्लैक लिस्ट में. और ग्रे लिस्ट दैट इज इन बिटवीन वाइट एंड ब्लैक. जो ग्रे लिस्ट है वो वाइट एंड ब्लैक लिस्ट के इन बिटवीन है. जो भी सब्सक्राइबर अंडर ऑब्जर्वेशन होंगे दे ऑल आर अवेलेबल इन ग्रे लिस्ट। तो बेसिकली ये 3 लिस्ट मेंटेन करता है, व्हाइट लिस्ट, ब्लैक लिस्ट एंड ग्रे लिस्ट। ओके, दैट इज ऑल अबाउट द आर्किटेक्चर। नाउ वी कम्स ओवर द आइडेंटिटी, जीएसएम आइडेंटिटी। अभी हमने इसमें काफी बार आइडेंटिटी का नाम लिया, तो नाउ वी आर गोइंग टू सी द व्हाट इज द मीनिंग ऑफ आइडेंटिटी। तो जो मोस्ट पॉपुलर आइडेंटिटी है दैट इज द IMSI, इंटरनेशनल मोबाइल सब्सक्राइबर आइडेंटिटी। ये जो है इंटरनेशनल, इसके 3 कंपोनेंट होते हैं, वन इज MCC, सेकंड वन इज MSIN एंड थर्ड वन इज SN MSIN। ये 3 कंपोनेंट आप देख पा रहे होंगे, MCC, MNC एंड MSIN। MCC इज मोबाइल कंट्री कोड, MNC is mobile network code, MSIN is mobile subscriber identity number। ये मैक्सिमम 15 डिजिट की पॉसिबल है। इंडिया में हम 14 + 15 2 डिजिट की IMSI यूज करते हैं, ठीक है। ये 15 डिजिट की मैक्सिमम हो सकती है। इंडिया में हम 2 डिजिट, दो टाइप्स की IMSI यूज करते हैं, इट इज 14 डिजिट और 15 डिजिट। 404 और 405 दो कोड इंडिया के लिए एलोकेटेड हैं फॉर MCC। तो दैट इज अवेलेबल इन सिम, ये सिम में अवेलेबल है, और इसकी मैक्सिमम लेंथ जो है वो 15 डिजिट पॉसिबल है। दैट इज ऑल अबाउट IMSI। और ये एक ऐसा एड्रेस है दैट इज अवेलेबल इन सिम एंड इट इज इलेक्ट्रिकली राइटेबल इन द EEROM। Okay, now against IMSI BLR allocate one TIMSI। ये एक TIMSI allocate करता है अगेंस्ट द IMSI। फॉर अंडरस्टैंडिंग पॉइंट ऑफ व्यू आप ऐसा समझ सकते हैं, जैसे आप ऐसा समझ सकते हैं जैसे कि उसने एलोकेट करा है कि कोई पूछ रहा है इसका मीनिंग, NMSI। ये है नेटवर्क मोबाइल सब्सक्राइबर आइडेंटिटी। MCC कंट्री कोड हो गया, फिर आपका NMSI। NMSI इज द कॉम्बिनेशन ऑफ MNC एंड MSIN। MNC और MSIN का जो कॉम्बिनेशन होता है वो MN, ये कहलाता है NMSI, नेटवर्क मोबाइल सब्सक्राइबर आइडेंटिटी। ओके, तो टिमसी जो है हाफ लेंथ होती है IMSI की, 8 डिजिट की आप मान सकते हैं इसको, 8 डिजिट की होती है, जो अगेंस्ट IMSI एलोकेट की जाती है बाया BLR। इसके यही क्वेश्चन है कि टिमसी कौन एलोकेट करता है, तो डेट इज BLR। इसका क्या स्कोप रहता है, डेट इज ओनली जब जब तक आप उस एरिया में अवेलेबल हैं, जब तक वो IMSI आप टिमसी रहती है। एज सुन एज यू आर गोइंग टू चेंज योर एरिया देन टिमसी इज आल्सो चेंज, बिकॉज इसका स्कोप ओनली अप टू BLR रहता है। ओके, टिमसी IMSI के अगेंस्ट यूज होती है बस। MSISDN जो होता है मोबाइल स्टेशन ISDN नंबर, मैक्सिमम 15 डिजिट का पॉसिबल है इन इंडिया। राइट नाउ वी आर फॉलोइंग 12 डिजिट MSISDN। अभी हम इंडिया में जो MSISDN यूज कर रहे हैं वो 12 डिजिट MSISDN है, जिसमें भी 3 कंपोनेंट हैं, CC, NDC एंड SN। और SN और NDC मिलकर बनते हैं NSN, नेशनल सिग्निफिकेंट नंबर। फॉर एग्जाम्पल जैसे कि मेरा जो नंबर है डेट इज 9412739313, तो ये 10 डिजिट हुआ। एंड ए हेड ऑफ उसके आगे एक 2 डिजिट का नंबर कोड और लगाया जाता है, डेट इज CC, कंट्री कोड, डेट इज 91 इन आवर केस। तो ये दोनों मिलाकर मैक्सिमम जो भी हमारी नंबर लेंथ है डेट इज 12 डिजिट। ओके, MSRN that is a temporary number, मोबाइल स्टेशन रोमिंग नंबर, ये टेम्पररी नंबर है, that is used only for the call terminating at the time of call terminating। ठीक है, जब भी हमारी कॉल टर्मिनेट होनी होती है एट दैट टाइम वी यूज द MSR, EMEI, International Mobile Equipment Identity, that is stored in your mobile handset. Okay, that is all about the chapter 1. ये हमने चैप्टर 1 अभी हम अपना कंप्लीट कर दिया, जिसमें हमने देखा पहले सेलुलर कॉन्सेप्ट, देन GSM आर्किटेक्चर, देन समथिंग अबाउट द GSM आइडेंटिटी. नाउ वी आर गोइंग ओवर द चैप्टर 2 जो 3G वाला है. Okay. Now, before going over the UMTS, if you have any query or any question, तो हम 2 मिनट डिस्कस कर सकते हैं अगर आपकी कोई क्वेरी या कोई क्वेश्चन है. यू कैन आस्क थ्रू मैसेज, और if you want to unmute yourself, you can do that also. Otherwise, we are going for the 3G. Yes. Anybody? Any question? Okay, if no question is there, then we are going for the UMTS. Okay. अच्छा, इंटरफेस भी पूछ रहे हैं कोई. इसमें इंटरफेस एक्चुअली बहुत सारे हैं, इस चैप्टर में नहीं है. मैं आपको वैसे बता तो सकता हूँ. इंटरफेस कुछ जो इम्पोर्टेंट इंटरफेस हैं वो मैं आपको बता देता हूँ. जस्ट लाइक UM इंटरफेस, मोबाइल टू BTS, एक इंटरफेस होता है जिसको हम UM इंटरफेस बोलते हैं, यूनिवर्सल इंटरफेस फॉर मोबाइल कम्युनिकेशन. RF इंटरफेस भी बोलते हैं इन जनरल, बट जो उसका नॉमनक्लेचर है दैट इज UM इंटरफेस. BTS टू BSC जो इंटरफेस है दैट इज A बेस इंटरफेस. ओके, A बेस. एंड BSC टू MSC दैट इज A इंटरफेस, वो A इंटरफेस होता है. फिर MSC टू VLR B इंटरफेस होता है. MSC टू MSC E इंटरफेस होता है. MSC टू HLR जो है H इंटरफेस होता है. तो इस तरह से इंटरफेस है. फिर किसी ने पूछा MSISDN. MSISDN जो आपका डायरेक्टरी नंबर है दैट इज द MSISDN नंबर. डायरेक्टरी नंबर जैसे आपका जो मोबाइल नंबर होता है ना, उसमें 3 डिजिट 3 कंपोनेंट होते हैं. वन इज द CC. इंडिया के केस में वो 91 है, पाकिस्तान के केस में 92 है. और जो नेटवर्क कोड है जिसको हम 4 डिजिट है, जैसे 9418, दैट मीन्स ये हिमाचल का BSNL है. 9868 ये MTNL है. उसके बाद रेस्ट जो 6 डिजिट है दैट इज SM. ठीक है. फिर किसी ने पूछा TRAU. एक्चुअली TRAU की जो प्लेसिंग है दैट इज ए वेरी फ्लेक्सिबल. इट मे बी अवेलेबल इन BTS, इट मे बी अवेलेबल BTS टू BSC, और या फिर ये अवेलेबल हो सकता है BSC और MSC के बीच में. तो इसकी कोई फिक्स लोकेशन नहीं है. इट इज ए फ्लेक्सिबल, ये कहीं भी प्लेस किया जा सकता है. जनरली हम BSC के साथ प्लेस करते हैं इसको. ओके, इन बिटवीन BSC टू MS, जनरल केस. बेटे बाकी इसका कुछ. किसी ने MSISDN MC का डिफरेंस पूछा है. इसको समझने के पॉइंट ऑफ व्यू से यू कैन अंडरस्टैंड लाइक दैट, जो डिफरेंस IP और ARP एड्रेस का होता है, या MSISDN को वी आर सेइंग इट इज ए सॉफ्ट एड्रेस, और MC दैट इज ए हार्डवेयर एड्रेस. MC आपके सिम का एड्रेस होता है, उस पर मोबाइल नंबर मैप किया जाता है इन द HLR. ये MSISDN दैट इज नॉट अवेलेबल इन द सिम. ये सिम में अवेलेबल नहीं होता, दैट इज मैप्ड ऑन HLR. ये बेसिकली नेटवर्क साइड में अवेलेबल होता है. इसकी इंफॉर्मेशन हमारे पास नहीं होती, मोबाइल में नहीं होती. दैट इज अवेलेबल इन HLR. और MC जो है ये नंबर आपका सिम में अवेलेबल होता है, सिम में हार्डवेयर में अवेलेबल होता है. दैट इज द डिफरेंस. MSRN ये रूटिंग पॉइंट ऑफ व्यू से यूज होता है जब कॉल टर्मिनेटिंग पॉइंट पर आती है, जब हम MSRN यूज करते हैं। इसका नाम भी ऐसा ही है, मोबाइल सब्सक्राइबर रोमिंग नंबर। आप इसको ऐसा भी बोल सकते हैं, मोबाइल सब्सक्राइबर टर्मिनेशन नंबर। ठीक है, बाकी डिटेल में अभी मैं नहीं समझा पाऊंगा इसको। जो ये कैन बी से BTS एज ए सेल, ये आप मतलब ठीक नहीं है, लेकिन फॉर अंडरस्टैंडिंग पॉइंट ऑफ व्यू आप समझने के लिए ऐसा मान सकते हैं कि एक BTS जो एरिया कवर करता है वो एक सेल होता है, बट उसमें कंडीशन है कि BTS ओमनी डायरेक्शनल होना चाहिए। ओमनी डायरेक्शनल मतलब जैसे आपका FTTH या वाईफाई का एंटीना होता है ना, वो चारों तरफ रेडिएट करता है, बट हमारे जो मोबाइल के BTS हैं, कोई भी BTS ओमनी डायरेक्शनल नहीं होता। इंडोर सॉल्यूशन छोड़कर जो भी आउटडोर सॉल्यूशन है वो सब सेक्टर्ड BTS है। तो बेसिकली एक सेक्टर को एक सेल बोलते हैं। तो वो जो एक सेक्टर है वो सेल होता है। ओके, ठीक है। तो ये आपके क्वेश्चन हो गए। नाउ वी आर कम ओवर 3G मोबाइल नेटवर्क। व्हाट इज द 3G मोबाइल नेटवर्क? बेसिकली 3G ये जनरेशन जो मोबाइल नेटवर्क इस सर्विस को प्रोवाइड कराता है, डेट इज UMTS। उसकी फुल फॉर्म है यूनिवर्सल मोबाइल कम्युनिकेशन, बेसिकली टेली कम्युनिकेशन सिस्टम सर्विस। तो ये बन जाएगा आपका UMTS, यूनिवर्सल मोबाइल टेली कम्युनिकेशन सर्विसेज, UMTS। ओके। टेक्नोलॉजी यूज इन UMTS, कौन सी हम टेक्नोलॉजी यूज करते हैं UMTS में? UMTS में जो हम मल्टीपल एक्सेस मेथड यूज करते हैं इंस्टेड ऑफ TDM में, यहाँ पर हम मल्टीपल एक्सेस मेथड यूज करते हैं, डेट इज WCDM में, वाइड बैंड कोड डिवीजन मल्टीपल एक्सेस मेथड। ठीक है, WCDM में रेडियो नेटवर्क सिस्टम आर्किटेक्चर। एंड UMTS कोर नेटवर्क एलिमेंट। UMTS कोर नेटवर्क एलिमेंट में कौन कौन से नेटवर्क एलिमेंट अवेलेबल हैं, वो सब चीजें। ठीक है। नाउ द 3G रेफर टू थर्ड जनरेशन मोबाइल टेलीफोनी। ये 2G की एहेड जनरेशन है। जैसे 2G में 900 और 1800 यूज होता है, यहाँ पर हम 2.1 गीगाहर्ट्ज फ्रिक्वेंसी यूज करते हैं। दैट इज बेस्ड ऑन IMT 2000, IMT इंटरनेशनल मोबाइल टेलीकम्युनिकेशन 2000, 3GPP और ITU जो एक विजन लॉन्च करते हैं, दैट इज IMT 2000। उस पर बेस्ड जो सर्विसेज प्रोवाइड कराते हैं उसको हम बोलते हैं 3G। और IMT 2000 का क्या विजन था? दैट इट द नेटवर्क कैन बी गिव अस 2 Mbps स्पीड, दैट इज अवेलेबल, that network can be give us वेरिएबल बिट रेट डेटा रेट सर्विसेज ऑन डिमांड। 3G की जो बिट रेट है दैट इज फ्लेक्सिबल, वो वॉइस सर्विसेज भी देता है और हमारी बिट रेट उसकी फ्लेक्सिबल होती है, मैक्सिमम 2 Mbps तक जा सकता है। इसमें पॉसिबिलिटी थी FDD एंड TDD की, लेकिन हमने इंडिया में जो यूज किया है दैट इज ओनली द FDD में। ठीक है, बट पॉसिबिलिटी थी TDD, पर हमने यहाँ पर यूज किया है केवल FDD। इसमें पॉसिबल है इंटर सिस्टम हैंडओवर इज आल्सो पॉसिबल इन 3G। व्हाट इज द मीनिंग ऑफ इंटर सिस्टम हैंडओवर? दैट मीन्स इफ 3G network was not available, so then you can take handover from 3G technology to 2G. That was also possible in 3G। 3G जो सिस्टम था, that the name of 3G is UMTS। एंड जो मल्टीपल एक्सेस मेथोडोलॉजी है दैट इज WCDM। तो इसके ना तीनों नाम है, यू कैन से इट इज 3G, इट इज UMTS और इट इज WCDM। तीनों एक ही चीज को रिप्रेजेंट करते हैं, बट थोड़ा थोड़ा डिफरेंस है। दैट कम्स इन 2001, फर्स्ट टाइम इसको जापान में डोकोमो के थ्रू लॉन्च किया गया था। दैट इज बेस्ड ऑन रिलीज 99। ठीक है, 3G जो बेस्ड है वो है 3GPP के R99 पर। यही R9 बाद में R3 के नाम से जाना गया। इसको राइट नाउ वी नोन एज R3। Okay, no. It's a यूरोपियन टेलीकम्युनिकेशन सिस्टम और इन दोनों ने मिलकर बनाया, दैट इज 3GPP, दैट इज रिस्पॉन्सिबल फॉर GSM डेवलपमेंट। इसी की एक सिस्टर कंसर्न हुई 3GPP2, दैट इज रिस्पॉन्सिबल फॉर CDM में डेवलपमेंट। तो ये GSM का डेवलपमेंट था जो दैट इज कैरीड बाय द 3GPP, और ये CDM में का डेवलपमेंट था दैट वाज कैरीड बाय द 3GPP2। ओके, ओवरव्यू ऑफ UMTS रिलीज आर्किटेक्चर। UMTS के जो रिलीज आर्किटेक्चर थे दैट इज बेस्ड ऑन R9, R99, R4, R5। ठीक है, बेसिकली 3 टाइप के आर्किटेक्चर थे, R99, R4 एंड R5। R99 जो था मोनोलिथिक MSC पे था। R4 में वी हैव डिवाइड आवर MSC इनटू द 2 पार्ट, one is the MSC server, other one is the media gateway, and R5 we have introduced the IMS in this one also. It can give us all IP code, it can give us the IP like services. Okay, WCDM में access network, WCDM में radio access network is also known as UTRAN, UMTS terrestrial radio access network। यहाँ पर ये UTRAN है, W radio access network is also known as UTRAN. UTRAN has two components. One is the RNC and node B, and that all are connected to the core. Here we have 2 types of core. One is the CS core and other one is the PS core. Circuit switch core and packet switch core. So BTS known as node B, BSC known as RNC, and there are 2 core, CS circuit switch core and packet switch core. Node B is connected to RNC via IUB. RNC is connected to the core network via IU interface. अगर ये CS से कनेक्ट है तो IUCS, और PS से कनेक्ट है तो that is IUPS. RNC is also connected to another RNC via interface, that is IUR, that was not available in BSC. तो ये एक नया इंटरफेस है जो RNC to RNC है, जो 3G में नया इंट्रोड्यूस हुआ था फॉर सॉफ्ट हैंड ओवर पॉइंट ऑफ व्यू। तो ये सारे इंटरफेस हो गए सर, IUB इंटरफेस, IUR इंटरफेस, IUCS एंड IUPS इंटरफेस। ओके, नाउ नोड बी, व्हाट इज द पर्पज ऑफ नोड बी? जो BTS का पर्पज था वही आपके नोड बी का पर्पज है। It will radiate the frequency, receive the frequency, it will give us the radio resource, and it is much smarter than BTS. It also manage their own resources. RNC to RNC लिखा हुआ है ये इंटरफेस, IUR इंटरफेस, ठीक है। एंड जो मोबाइल BTS टू मोबाइल इंटरफेस है इन GSM दैट वाज द UM इंटरफेस, बट हियर इट नोन एज UU इंटरफेस। UU इंटरफेस फॉर द मीन्स यूनिवर्सल इंटरफेस फॉर UMTS। तो ठीक है, ये सारे इंटरफेस हो गए, UU, IUB, IUR, IU। इफ IU is for CS then it known as IUCS, और अगर ये PS के साथ है तो it known as IUPS। रेडियो बेस स्टेशन इज नोन एज नोड बी, इट विल गिव अस रेडियो फ्रिक्वेंसीज, और ये RNC से कनेक्ट है IUB में, ठीक है। फंक्शन ऑफ नोड बी, रेडियो ट्रांसमिशन, रिसेप्शन, हैंडलिंग, इन्वॉल्व इन मोबिलिटी मैनेजमेंट, इन्वॉल्व इन द पावर कंट्रोल, मॉड्यूलेशन, डिमॉड्यूलेशन, क्लोज लूप पावर कंट्रोल। मैंने बताया ना कि दैट इज मच स्मार्टर देन BTS, सो दैट वी हैव रिटन इन्वॉल्व। ये इन सब कामों में भी इन्वॉल्व होता है बेसिकली, एंड दैट विल डन बाय द RNC और रेडियो नेटवर्क कंट्रोलर, बट BTS नोड बी इज आल्सो इन्वॉल्व इन द वन। तो रेडियो नेटवर्क कंट्रोलर RNC, दैट इज a BSC, that was the BSC in GSM, but here is known as RNC जुड़ी होती है IUR से फॉर सॉफ्ट हैंडओवर पॉइंट ऑफ व्यू. What are the purpose of RNC? It the main function of RNC is the radio resource management. जो radio resource है that is managed by the RNC. Call congestion algorithm, admission algorithm, call management and connection. Here we have the 4 type of bearer. बियरर मतलब रेडियो बियरर होते हैं. इसमें 4 प्रकार के हमारे पास रेडियो बियरर हैं. तो आप यहाँ देख सकते हैं. इसमें इंटरेक्टिव रेडियो बियरर है, कन्वेंशनल रेडियो बियरर है, ये वाली कन्वेंशनल, स्ट्रीमिंग, इंटरेक्टिव एंड बैकग्राउंड. ये 4 तरह के रेडियो बियरर हैं बिकॉज इट इज ए वेरिएबल स्पीड. तो कन्वर्सेशनल कन्वर्सेशनल रेडियो बियरर यूज फॉर द वॉइस टेलीफोनी. यहाँ पर हमारा डिले लो होगा और ऑर्डरिंग स्ट्रिक्टली फॉलो होगी क्योंकि ये रियल टाइम वॉइस टेलीफोनी में यूज होता है. स्ट्रीमिंग समथिंग लाइक you are watching YouTube or watching video, it can have the moderate delay or strictly ordering or also follow. Interactive, there is no need of ordering. कोई पैकेट किसी भी टाइम आ सकता है बिकॉज यू आर डूइंग द वेब सर्फिंग. ठीक है. एंड बैकग्राउंड, नो डिले इज पॉसिबल इन, मतलब डिले की कोई जरूरत नहीं. कितना भी डिले हो सकता है, कोई भी ऑर्डर हो सकता है बिकॉज यू आर डूइंग द डाउनलोड और अपलोड. तो 3G कोर मैंने जैसा बताया 2 कोर हैं इसमें. एक सर्किट स्विच है, एक सर्किट स्विच कोर एंड पैकेट स्विच कोर. सर्किट स्विच कोर में क्या क्या होगा? MSC एंड GMSC. पैकेट स्विच में SGSN एंड GGSN. SGSN इज सर्विंग GPRS सपोर्ट नोड. जो GPRS में अवेलेबल था उसी को कुछ अपग्रेड करके इन्होंने 3G का SGSN बना दिया. दैट कैन हैंडल मोबिलिटी मैनेजमेंट. SGSN जनरली हमने सर्किल लेवल पर लगाए थे, GGSN हमारे जोनल लेवल पर थे. तो SGSN can support the mobility management, session management, interaction with other network and billing. Okay. 3G and 2G both are having the shared node. Shared node कौन कौन से थे सब जो हम पढ़ चुके हैं. GSM में HLR, VLR, EIR and AUC. They all we have seen in the GSM. They all are the shared node. That is all about the 3G. इसमें 3G में आपको में से ज़्यादा नहीं है. तो 3 तरह के हमारे पास आर्किटेक्चर हो गए. एक R3 आर्किटेक्चर है जो मोनोलिथिक MSC में है. एक R4 आर्किटेक्चर है जिसमें MSC 2 हिस्सों में डिवाइड हो जाती है. वन इज MSC एंड अदर इज MSC सर्वर एंड मीडिया गेटवे. एंड R5 आर्किटेक्चर इज बेस्ड ऑन IMS. ये आप देखेंगे दैट में. ये that one. R5 architecture, that is IMS based architecture. R5 architecture, that is IMS based IP multimedia subsystem. Okay. तो 3G में आपके में इतना ही लिखा हुआ है. That is all about the 3G. Now we are going over the 3.5G, which is also known as HSPA and HSPA plus. What is the meaning of HSPA? High speed packet access, and HSPA plus means high speed packet access plus. Now what we are going to cover in this chapter: HSPA, HSPA plus standard, various release, migration to 4G. That is the migration part, 3G to 4G. अब 3G UMTS था और LT 4G था. इन बिटवीन 3G to 4G देयर इज ए टेक्नोलॉजी विच इज HSPA. यहाँ पर आप देखेंगे R99 में हमारा 3G स्टार्ट हो गया था और R8 में LT स्टार्ट होता. तो इन बिटवीन दीज आर द टेक्नोलॉजी विच इज बेस्ड ऑन 3G एंड एनहेंसमेंट ऑफ 3G. आप इसको एनहेंसमेंट ऑफ 3G भी कह सकते हैं. वन बाई वन वी विल सी ऑल इज इन डिटेल। अब हम इस सारे रिलेशन को डिटेल में देखते हैं। यहाँ पर बहुत छोटे में लिखा है, लेकिन जो भी क्वेश्चन वगैरह बनेंगे वो बनने इधर से ही चाहिए आपको। जैसे R99, that is a pure 3G network, that is can give us 2 Mbps speed maximum. Then R4, it is a bearer independent circuit switch architecture. R4 bearer independent मतलब कि यहाँ पर MSC सर्वर और मीडिया गेटवे है। In media gateway it can carry any type of नेट ट्रैफिक। अब वो टीडीएम बेस्ड ट्रैफिक भी हो सकता है, एटीएम बेस्ड भी हो सकता है, आईपी भी हो सकता है, बिकॉज हियर वी आर यूजिंग द एनजीएम टाइप ऑफ आर्किटेक्चर। इन R5 फर्स्ट टाइम वी इंट्रोड्यूस IMS, and in air interface we have introduced the HSDPA, high speed downlink packet access, that can give us 14 Mbps services. फिर इन R6 वी हैव द HSUPA सर्विसेज। यहाँ पर हमने केवल डाउनलिंक में अनाउंसमेंट किया था। इन R6 वी दे हैव डेवलपमेंट इन द अपलिंक आल्सो। देन अब यहाँ पर दोनों मिलकर क्या बन जाते हैं? इन R6 वी कैन से दैट इज HSPA। इन R7 HSPA प्लस हायर ऑर्डर मॉड्यूलेशन। इन R8 LT कम इन द पिक्चर। फिर R8 में LT आ जाता, R9 LT एनहेंसमेंट एंड R10 इज आल्सो नोन एज LT एडवांस। 3G HSPA provide the major improvement in the performance of 3G UMTS mobile telecommunication। ठीक है, तो बेसिकली R4 आर्किटेक्चर इंडियन, R5 इट कैन गिव अस, R5 HSDP के नाम से जाना जाता है, R6 HSUPA and R7 is HSPA plus because it can give us higher speed with the help of higher order modulation, 64 kb QM or 16 QM modulation, 64 QM downlink में and 16 for uplink, that is available। R8 it can use the MIMO also, so it can give us more speed। In R9 instead of one carrier, here we can use the two carrier, one 5 megahertz plus one 5 megahertz, so here we can use the two carrier and MIMO is 2 MIMO is possible in R9। In R10 the carrier can be the 4 into 5, it can go 20 megahertz and it can give us 2/2 MIMO। Okay, HSPA, high speed packet access। HSPA, high speed packet access, high speed packet access is a upgradation of 3G UMTS। HSPA जो है वो हमने एक ओवरले टाइप ऑफ नेटवर्क है, जस्ट लाइक GPRS जैसे GSM का ओवरले नेटवर्क था, दैट वाज यूज्ड फॉर द higher speed। The same way HSPA is a overlay network of 3G that is also used for the higher speed। अब कितनी स्पीड पॉसिबल है सर? HSDPA में रिलीज फाइल में इट कैन गो मैक्सिमम 14.4 Mbps in uplink। In R6 it can increase the uplink speed, that is 5.7 kbps। In R7 we can go up to 28 with the help of 2/2 and R8 it can go 42 Mbps। R9 में हमारी स्पीड पॉसिबल 84। ये सब आपको रखनी पड़ेंगे और कोई इसका व्हाट इज द हाउ वी कैन इंक्रीज द स्पीड। हम इंक्रीज स्पीड कैसे इंक्रीज कर सकते हैं विदाउट इंक्रीजिंग द बैंडविड्थ बाय UMTS सर्वर डिफाइनिंग 3GPP R9। R5 में और R9 में क्या डिफरेंस था? हियर वी आर गोइंग टू यूज द हायर ऑर्डर मॉड्यूलेशन इंस्टेड ऑफ QPSK। Basically in 3G we were using the QPSK, but in HSDP we are going to use 16 QM instead of QPSK, तो वो ऑटोमेटिकली हमारी स्पीड 3 times हो जाएगी। हायर ऑर्डर मॉड्यूलेशन ठीक है। शॉर्टर टाइम इंटरवल जो WCDMA का फ्रेम होता है वो 10 मिली सेकेंड का होता है, बट इन HSDP हम फ्रेम लेंथ को डिक्रीज कर देते हैं एंड दैट इज 2 millisecond instead of 10 millisecond. We in HSDP we are going to use 2 millisecond frame length, and here we are using the shared channel transmission also. That technology is available in HSDP. HSDP में हम shared channel transmission technology use करते हैं, that was not available in 3G. And in 3.5G we are going to use the link adaptation technology. As the radio condition permit, we are going for higher modulation and lower channel coding. हर 2 मिलीसेकेंड पर वी आर गोइंग टू चेंज द मॉड्यूलेशन स्कीम और चैनल कोडिंग स्कीम। अगर हमारी रेडियो कंडीशन परफेक्ट आ रही है तो हम हायर ऑर्डर मॉड्यूलेशन पर जा सकते हैं, और इट इज नॉट बैड है तो लोअर ऑर्डर मॉड्यूलेशन पर आ जा सकते हैं। तो यूज ऑफ लिंक अडेप्टेशन, बाय अडेप्टिंग द लिंक इट इज पॉसिबल टू मैक्सिमाइज द चैनल यूज। जैसा भी उसकी कंडीशन है उसी के अकॉर्डिंग हम उसकी यूज कर सकते हैं। फास्ट नोड बी शेड्यूलिंग, नोड बी में जो शेड्यूलिंग होगी दैट इज फास्ट हो जाएगी उसकी। 3G UMTS HSPA constituents, there are two main component of 3G UMTS UPA। इसके दो मेन कंपोनेंट हैं HSPA के। एक बार हमने इंक्रीज की थी डाउनलिंक स्पीड और एक बार इंक्रीज की अपलिंक स्पीड। तो HSPA के दो मेन हो गए, HSDPA हाई स्पीड डाउनलिंक पैकेट एक्सेस। यहाँ पर हमारी स्पीड 2 Mbps से इंक्रीज हो जाती है 14 Mbps, and HSUPA that is for uplink, and here we can increase 2 Mbps की जगह हमारी जो uplink स्पीड है that can be increased up to 5.74। HSDPA में क्या क्या टेक्नोलॉजी अवेलेबल थी, दैट इज एडिशनल चैनल। यहाँ पर हमने एक शेयर्ड एडिशनल चैनल अचीव किया, दैट इज HSDPA डाउनलिंक शेयर्ड चैनल। ये ट्रांसमिशन में हमारा एक नया चैनल यूज हो जाता है, दैट इज न्यू चैनल इंक्लूडिंग हाई स्पीड डाउनलिंक शेयर्ड channel. The same we have in physical link also, high speed dedicated physical control channel. तो basically shared channel हमने use कर लिया। modulation instead of QPS के we can go up to 16 QM, and improve scheduling जो डेटा की पैकेट आपके पास आ रहे हैं उनकी शेड्यूलिंग improve हो जाती है, फास्ट हो जाती है। एरर चेकिंग जो है दैट इज बेस्ड ऑन फास्ट हाइब्रिड ARQ। यहाँ पर हम हाइब्रिड ऑटोमेटिक रिपीट रिक्वेस्ट यूज करते हैं इंस्टेड ऑफ ARQ। द सेम वी हैव इन HSUPA। HSUPA में क्या क्या हमारा होता है, इंक्रीज डेटा रेट, we can increase data rate from 2 Mbps to 5.74। shorter TTI जैसे मैंने बताया इन WCDM में we have the 10 millisecond frame, but instead of 10 millisecond in HSDP or HSUP we have the 2 millisecond frame length। we can improve system efficiency, modulation order, hybrid ARQ and fast। Now HSPA is also evolved into the HSPA plus। HSPA जो हमारा R5 तक हुआ वो भी अब इवॉल्व होगा into the HSPA plus। HSPA plus is in 3 releases। HSPA R7 में आता है as well as LT in R8 we have the evolved HSPA plus standard। So HSPA is available in release 7 as well as release 8। And what we are going to do in HSPA plus, instead of 16 QM, we are going more higher modulation, that is 64 kbps or 64 QM। Then now first time we introduce MIMO in HSPA plus, instead of one antenna, now we have the numbers of antenna। First we have introduced a 2x2 माइनस। यहाँ पर हमने एक एंटीना की जगह हमने दो एंटीना यूज किए। नाउ वी आर आल्सो इंक्रीज द मल्टी कैरियर टेक्नोलॉजी इन HSPA प्लस। एक सिंगल कैरियर की जगह अब हमारे पास कितने कैरियर होंगे, दैट इज 2 कैरियर। तो ऑटोमेटिकली बैंडविड्थ हमारी इंक्रीज हो जाएगी, 5 मेगाहर्ट्ज से इंक्रीज होकर के कितनी हो जाएगी, 10 मेगाहर्ट्ज हो जाएगी। तो विद हेल्प ऑफ 5 मेगाहर्ट्ज HSPA maximum speed is possible is 42. If we are using more than one carrier, so then it can go up to 684 Mbps. So that is all about in HSPA plus. तो ठीक है, ये हमारा तीनों चैप्टर मैंने आपके कवर किया। एनीथिंग एल्स, आप कोई क्वेरी पूछना चाहते हैं? अदरवाइज वी आर गोइंग टू स्टॉप। 5 मिनट है आपके पास, कोई आप पूछना चाहते हैं तो पूछ लीजिए, हम डिस्कस कर लेंगे इसमें। You can unmute also, or you can write in chat. जी, कोई क्वेरी सर? अच्छा, सब लोगों ने थैंक्स कर दिया, यानी कोई क्वेरी नहीं है। ठीक, कोई कहना चाह रहे हैं अप टू 17? ठीक है, कोई क्वेरी ऐसी नहीं लग रही जो हम जो है इसमें डिस्कस कर सकते हैं। तो ठीक है, नाउ वी आर गोइंग टू क्लोज दिस सेशन। तो हम इसको क्लोज करते हैं। R3 जो है वो R99 ही थी गोयल जी, R99 को ही हमने फिर R3 बोला। एक्चुअली पहले क्या था, 3GPP ने प्लान बनाया था कि वो ईयर वाइज अपना रिलीजेस देंगे, तो उन्होंने स्टार्ट किया था R97। 1997 में फर्स्ट रिलीज दिया था R97, देन 98 में R98, ईयर 99 में उन्होंने दिया R99, और फिर 2000 से मिस हो गया तो दे हैव स्विच फ्रॉम ईयर टू नुमेरिक। तो R97, 98 फिर R3 स्टार्ट कर दिया। फिर उसके बाद से हमारे जितने भी रिलीजेस हैं वो न्यूमेरिकल वैल्यू में है, जैसा R3, R4, 5, 6, अभी हम R17 तक आ गए। ठीक है सर? तो ठीक है सर, नाउ वी आर गोइंग टू स्टॉप अवर PPT। तो आफ्टर लंच दिस प्रेजेंटेशन, आफ्टर लंच में भी क्लास आपकी रिज्यूम होगी और 4G की क्लास। तो थैंक यू सर, थैंक्स अ लॉट।
वेट करिए, शुरू कर रहे हैं, जस्ट वेट। आराम से लेटो, स्क्रीन में शेयर।
PPT खोलो।
PPT की तरह विंडोज से मत करो। बोलिए।
Hello, good afternoon, all of you. So it is a third session of mobile communication. It's taken by our GM sir, Rajeshwar Dayal sir. So in this session, we will cover the 3GPP standardization. It means up to release 17. So in this session, we will cover the release 99, release 4. Disconnect हो गया था। Yes, sir. So release 99, release 4, it is a basic release of the 3GPP, basically based on UMTS technology. And then release 4, 5, 6, 7, 8, based on HSPA, HSPA plus. And then release 9, 10, LTE, LTE advanced. Then 11, 12, 13, expansion of 4G. And then 15, 16, 17 is based on 5G. So definitely it is a very, very important session, and all are enjoying this session. And if any queries, please write on your chat box. Please mute all. Wait. Yes. So if any queries or any doubts in the session, please write on chat box. So we will discuss after the end of this session. So I think it is a very, very important for exam point of view as well as the mobile technology point of view. So thank you. And session handed over to our GM sir. Sir, please welcome.
Very good afternoon to all. Welcome to this online classes. The topic that I will be covering is basically like introduction to salient features of 3GPP releases up to release 17. Broadly, I will be covering what is 3GPP. So some of the topics are basically covered from the point of view of that being a telecom person, you should know what is 3GPP, what is the standardization, what all are the sources are there. Then I will be covering some of the key feature of the releases. And as I was told by Mr. Abhay that I think we need to cover some thing on 5G also. So I have some slides at the end covering the key architecture or the feature of the 5G also. So with that, I will start the class. So this slide is basically we will deliberate it on a little bit on 3GPP. We discuss we will deliberate on 3GPP. I don't know how many of you are aware about this terminology 3GPP. How many people are knowing that 3GPP? So like to start with, I will just give a brief background about the standardization process. 3GPP is basically a standardization development organization, or normally known as the SDOs. Any standard that is to be developed is a kind of a collaborative effort. 3GPP is also one of the collaborative effort to develop the standard related to the UMTS or 3G network. Prior to that, like you must be knowing two popular standards, GSM and CDMA. So GSM was basically like developed by ETSI, European standard, and CDMA was developed by like TIEIA, that was more popular as a US standard. Apart from that, there were many other standards like Codec was there, that was there, ICW was there. So when they were developing the standard for the 3G UMTS, they decided that we should have a kind of a collaborative, or we should have a common effort so that a common standard is coming up. What was the benefit of that? The benefit of that was that if you have a kind of a common standard that is acceptable or that is being adopted by various operators or the user across the world, so your scale of economies are easily achieved. In case you have a different standards and each one is developing its own standard, then what happens? Some continents, some countries are adopting one standard, another is adopting another standard. Then scale of economies cannot be achieved, as well as, hello. Now am I audible now? Hello. Okay.
Coming.
Yes, sir. Coming. I just got a message. Voice is not coming. Now I'm audible now. Got it.
Yes, sir.
Okay, thank you. So coming back to the same point. So when there were different standards were there, about 7, 8 standards were there for 3G, which was quite popular. Then apart from what I discussed, the scale of economies, another issue was roaming feature. As you may be knowing at the background, like CDMA was very efficient technology spectrally, as well as in terms of data rates and all that. Despite that, it couldn't survive because the roaming was one of the issues. The GSM, which already had a large footprint, offered a good roaming facility across the world. So with all that background, then the organization came up that all the main popular SDOs, they decided that, okay, we should have a kind of a common collaborative effort to develop one common standard. And with that, the concept of forming a partnership project, third generation partnership project came in. And so,
Hello.
yeah,
सर आवाज नहीं आ रही है
but I got a chat message that
अरे
yeah,
सर बिल्कुल ठीक आवाज है आपने अपने एंड पे चेक कर लीजिए प्लीज
yeah, I think then it will be issue at your end. You can restart your end, I think then it may work. So with that, the concept of 3GP, third generation partnership project came in picture. And initially they started with the key objective of developing the standard for UMTS, cellular telecommunication technologies, including all the aspect RAN, core, as well as services. Any doubt, then you can write on the chat, or maybe at the end we can have a discussion. So as I briefly told you, the third generation partnership project is basically like it unites 7 SDOs, or they were all normally referred to as the organizational partners, and they were representing different countries or the continent. And I have just in the next slide we can see that the 7 organizations are basically like, first one is ARIB, Association of Radio Industries and Businesses from Japan, the Alliance of Telecommunication Industries Solution USA, China Communication Standards Association CCSA China, then ETSI, European Telecommunication Standard Institute Europe. So this was the body which has developed basically GSM, GPRS, Edge, like prior to all UMTS or 3G standards. All 2G standards were developed, including your Edge, were developed by ETSI. Then TSDSI, Telecommunication Standard Development Society India, that was a and that entered this OP list a bit late, where earlier 6 has already started with the all UMTS activities. The next is the Telecommunication Technology Association of Korea and Telecommunication Technology Committee of TTC. So those are the composition or the organizational partner in 3GPP. Apart from that, there are many other technical associations or technical organizations also involved, but they become a like a kind of a technical member and not having all the veto or the powers that are required for recommending the standards. And the composition of the 3GP is basically like it consists of basically three technical specification group, core network and terminal CT, radio access network, LAN. Third is service and system aspect. Basically, like first one is your reflecting to requirement pertaining to your user device or terminal. Second one is basically towards radio network. Third one, services and system aspect is basically the core network related, whatever services we are offering and overall system behavior. Those are being covered by SCA. Apart from that, there is a like a project coordination group, which is like a overall supervisory or overall body, which is finally ratifying or approving the specification or technical reports. Brief about each technical specification group is the like TSG RAN radio access network basically have a 5 working group. Working group 1 basically referring is working on the radio layer 1 specification. Working group 2 on layer 2 and layer 3. Working group 3 on IUB, WF specification, application method requirements. Working group 4 is related to radio performance protocol aspects. 5 on mobile terminal and conformancy testing related. TSGSA is basically dealing with services, architecture, security, codecs, orchestration, charging, mission critical applications. And TSGCT is basically then dealing with user equipment protocols, interworking with external network, core network protocols, smart card application. So over the time, basically these groups have been rearranged or the work allocation has been changing. And what I'm presenting here is basically the latest allocation of the work. Right? With the change in the technology, like earlier there used to be a group related to the GPRS edge compatibility and all that. Those have been now more or less been done away. So now coming to our topic, which says 3GPP releases. So releases is basically like you can say a gives an idea what exactly is being covered under one particular set of release. Release is like what we say is a version or specification number in terms of what all it is covering. So once I say a particular release, then I have a set of defined requirement features which are being covered under that release. And other idea is to have a release is that once I say, okay, I will be covering following items or the features in this particular release. So when we place the order or when we go to the market, then we know if I say I want the equipment to be compliant with this particular release, then I know what all features has been covered by the vendor or the supplier and which all are not available to us, right? So 3GPP is using a system of releases and all this here. So this is just a kind of a screenshot from 3GPP website. So you see like started like the effective specification started from release 99, which is also referred to as a release 3. Release 1 and 2 are basically have been reserved or been designated as a draft specification. And currently the work is going on release 19. So we will be discussing some key features up to release 70. So first release was basically the release 99, which was referred to as a UMTS. And basically this was the release in which the 3G network was defined. So in this one, I think you might have already covered in an earlier lecture. The core was your like MSC and all that, and radio access network was there. node, right? And the technology air interface that was used was basically WCDMA. Prior to that, you were using this time slotting and this. Then release 99, as I told you, it was synonymous with the release 9.3, while the numbers were reserved for graph specification. This slide basically gives like some of the key features that has been covered in 3G releases. Now again, like when I say 3G releases, is that like I come out with like in R99 we started or we specified the UMTS requirement or 3G, right? Then over the time, then we feel that okay, this particular thing should have this more additional feature and all that. We continue with the additional feature adding on enhancement in different specifications. And after some time, then we come out to a entirely new version or there's a significant change in terms of technology, in terms of RF interfaces, in terms of core technology. Like these benchmarks are like we have defined 3G, we have defined 4G, then 5G. So till from 3G to achieving up to 4G, we have different releases like R99, release 4, 5, 6, 7, and 8. So release 8 is basically the release where the 4G work started. In between all the releases, the work has been more on the enhancement of the whatever we have initially specified for UMTS network. So if you see that release 99, circuit switch and packet switching, both switching was there, all right? Circuit switching was basically for your voice call and packet switching using like for packet data. In the core architecture, you had a PDSN, GGS, so in PDSN for case of CDMA, GGSN, SGSN for UMTS, DSN evolved path network. And you have updated radio bearer, multimedia services, location service that were part of initial release 99, which defined the UMTS. Then in the release 9, there were several enhancements as well as on the radio side, PDS CDMA feature was also introduced. In the release 5, we added like enhancement were there, HSDPA, IMS, AMR, WBSP. HSDPA basically was enhancement to achieve the high data rate, high speed data packet access. Then IMS, IP multimedia system. With that basically started your introduction of IP in the core network started, right? Prior to that, you had a kind of a protocol which were not IP based in the core side. Then adaptive multi-rate wideband speech, the codec improvements are also there to achieve the spectral efficiency. Those features were covered in release 5. Then the release 6, due for release in the March 2005, uplink capacity has been enhanced. MBMS, multimedia broadcast multi-task services were introduced. And the interface interworking between wireless LAN and UMTS network was also from the core side was also taken up in release 6. In release 7, HSPA was basically high-speed packet access evolution happened, covering in the downlink. The support was for 64 QAM, in uplink it was 16 QAM. Continuous packet connectivity, those additional features were introduced in release 7. So in between, like HSDPA basically came in 2 stages. Initially started with the downlink enhancement, then they take up the work with the uplink enhancement. Then the release basically, release 8 is like a starting point for your 4G or LTE technology. So LTE and then system architecture evolution, SAE, then DC, HSDPA, dual connectivity, HSDPA. Those were like DC, HSDPA was basically like the work that has been continuing for your 3G networks. Wherever LTE and SAE was basically kind of a new chapter, new marking for your LTE network. So here I would like to just introduce bring a clarity rather that LT is technically speaking, LT is not a 4G technology person. Like for LT advanced is a 4G technology, and it is the ITU which defines basically like IMT 2000, IMT advanced, IMT 2020, IMT 2030, which are basically the generic name adopted by the ITU. And 2G, 3G, 4G, 5G, these are the basically marketing or commercial name which has been adopted by your 3GP. So LT basically like including LT advanced was 4G, but LT per se is technically speaking is a air interface, and that too not fully as per the requirement of IMT 2020 calling to be or qualifying to be as a 4G. LT advanced is the standard which is basically 4G compliance standard. And so with release 8, your work for LT has started. I think this is a just text with more or less I think I've covered. Release 99 was the first deployable version of the UMTS, or basically the first document that has been first deliverable by the 3GPP forum in the domain of 3G. So in release 4, we have a MMS support and using IP some started. Release 5 HDPA, IMS was introduced, and instead of ATM, which was earlier used, the release 99. Then release 6, the features like MBMS, performance specification for advanced receiver, WLAN integration options, initial UIP capability, IMS announcements were introduced in release 6. In the release 7, basically provided the capability of HSPA evaluations, higher order modulation, MIMO enhancements, radio enhancement for into 64 QAM in downlink and 16 QAM in uplink. Release 10, release 8, basically I have just highlighted that this release basically has a component both for your LTE work as well as your evolution path for your UMTS enhancements. Release 9 is basically still continuing some work related to HSPA. That's why it has been here. Just a very in bullets point, if we say like what all standard we have covered up to release 7 and 8, they were the release which were dealing with the enhancement of your UMTS. AMR wideband is basically is adaptive multi-rate in wideband. So adaptive multi-rate is basically dealing with the codecs, voice codecs and all that. Right? So to achieve the error correction as well as to achieve the better spectral efficiency. So those releases were basically covering to the enhancement in UMTS first release 99 and enhancement. Now with release 8, the work or LT was basically introduced. This is basically like just this slide basically provides the key releases pertaining to your LT or LT advanced. So with release 8, LT was introduced. Release 9, enhancement in LT was made. Release 10 was basically LT advanced. So as I told you that LT advanced is basically the true 4G standard or M20. And release 11, 12, 13 until 14, there were different enhancement in LT and LT advanced. And release 14 I stopped because there the thought process for developing the new standard or 5G standard, what we say now, has started. So covering each one of them, let's go ahead. So this is like a slide taken from the Qualcomm side, which basically summarize the key features that has come up or that were relevant to the 4G releases like LT to LT advanced prior to your 5G standard. So she says like you see that release 8 is basic initial LTE standard, and the OFDMA was the air interface modulation, that orthogonal frequency division multiple access was the OFDMA was the waveform, and both FDD TD operation was supported in that, and it had a IP based evolved packet code EPC. You see, like OFDMA was a technology that was used for the first time. And though the technology per se is not a was not a new technology, but the capability of the digital signal processing, we were able to use this OFDM technology. And the key concept in OFDM, I don't know whether it is covered or not. It was basically like you are not providing any uh, what you say gap between the two carrier, or the when the carrier one carrier goes to zero, your other carrier starts. That way it is quite spectrally efficient. Then coming to release 9. Release 9 basically covered the MBMS aspect of the LTE broadcast part, location services LTE position part, then circuit switch fallback, enhanced voice fallback facility was introduced, and voltage voice over LTE feature was introduced in release 9. So this CSFB and VoLTE feature were introduced like to provide the backward compatibility, or when you go from 4G to 3G or 2G network where the radio interface is not 4G network, then to ensure the continuity of the call, or to originate or terminate the call, those features were introduced in release 9. And coming to the release 10. So release 10 is basically another landmark where which were against the requirement specified by ITU for with 4G or IMD content. So it introduced the concept of carrier aggregation. I have some one slide on that. Carrier aggregation, HETNet, heterogeneous network, advanced binding. And in release 18, your COM feature was introduced, coordinated multi-point. HETNet enhancements were there. ICICI, basically interchannel interference cancellation concept was introduced. In release 12, the work was done for dual connect, FDD, TD, carrier aggregation, and the modulation 256 band was achieved, and device to device connectivity was also specified or covered in release 12. In release 13, 32 cross CA, FD MIMO, LT analyzed LLA, LT IoT, EMT, NB IoTs, they were included. So like some of the topic, I have some slide like carrier aggregation HETNet that I will be covering in with detail, you can say. And so like LT unlicensed LA, basically like they introduced the feature that to able to use the free Wi-Fi band, spectral band, to top up or to cover or to enhance the data rates. So whenever there is a possibility to use the free unlicensed spectrum, use like which is used by your Wi-Fi, if that is available without any much of the interference, so that was also being used for delivering the high throughput or high data rate. So that feature was introduced in release 13. And IT IoT basically like two feature narrowband IoT. Those were basically specific customization in your 4G to take care of your IoT devices, because these devices were basically not requiring a much of the data rate, but they required a kind of a short duration data to be transmitted or received, as well as the bandwidth requirement was not high. So that way some customization was required, and those were basically taken care of in your NB-IoT specification. Then in release 14, we have enhanced LLA, license access, then vehicle to everything, digital TV broadcasting. Vehicle to everything, basically this terminology is coming from the point of view of your IoT devices, where like vehicle can be connected to another vehicle, or vehicle can be connected to every other thing. Like initially, there used to be one-to-one connectivity kind of thing. Then over the time, it was felt that vehicle may have to connect it to many devices. From that point of view, V2X term was basically coined. Release 15 basically covered drone or ultra low latency communication and further enhancement towards IMT 2020 in existing spectrum. So that 4G enhancement from the existing spectrum were taken care in release 50. Right. So these were the up to release 14, you can say all were primarily addressed to your 4G standards, 3G, LTE and LTE advanced standard. Then release 15, some work was carrying on for 4G as well as we will see that release 15 basically started the 5G specification. So this I will just say LTE, it's already I have covered. Those things we have discussed. Now coming to Hacknet. So Hacknet was a feature we see that it was introduced in release 8 or 10. Then Hacknet is basically kind of a heterogeneous network. As you may be knowing that heterogeneity means kind of a difference, not having the same or similar type of composition. If you see this picture, you can see that there's a Pico E node B is there, macro E node B is there, as well as Femto was introduced later on. Anyway. So like you see, we have a macro E node B, which is having a broader coverage. Apart from that, there were several areas which have been shown as Pico E node B. Pico E node Bs are the area which are having a heavy number of subscribers or where the traffic requirement is high. Right? You may be knowing that complete area may not be having a similar type of traffic requirement where the population is high or where you say there's a market is there or some kind of a office complexes are there. There you may be requiring to cater for a more of a traffic also apart from the connectivity. Wherever for the rest of the part or rest of the geography, you may be providing basically coverage and number of subscribers at a time may not be too much. So you try to introduce Pico node Bs or those locations. However, you have to provide the connectivity or the coverage when somebody moves out from Pico node B to your normal macro coverage area. But what happens when you are using the same kind of frequency band as well as connectivity, then possibility of the channel carrier, inter-channel carrier interferences quite high. So to take care of that, those requirement has been introduced in the later releases of the LT Advanced LT, and that was the concept to take care of this. And how they are able to achieve it is in general, like you say, from 4G is basically you are having a scheduler in which radio resources are basically allocated in terms of time slot as well as frequency band. The granularity of allocation of time slot and frequency slot that you can vary. You can give more number of time slots, more number of frequency slots, as well as the area each E node B, the type of like if particular frequency F is given in one particular E node B, then during the same time you can allocate different frequency band to the other people E node B to avoid the interference, or the time slot may be varied. Another concept was that comp was there, coordinated multi-point, right? So here if you see there are E nodes V's are there, 3 E node V's are there. And in the left side, if you see, The two persons are basically like POMP is used to achieve spectrum efficiency at the edges as well as to improve the cell throughput. If the two persons which are at the edges are being served by the two E node Bs being at the edge, there's very likelihood that they will be interfering with each other. So what I told you like earlier that I can control the radio resource allocation node wise also. The scheduler can control the. So whenever a person at edge is there which is using a particular frequency while communicating, I will ensure that other E node B doesn't allocate the same frequency resource at the same time. So that way I am able to avoid the cancellation. Or if there is suppose one person at the edge, then I can allocate the same resource from the both side or using the time slot in such a way that the frequency from both the side as well as the time slot reinforce each or supports each other. So that was the concept introduced by way of coordinated multipoint. So if you see that we are able to achieve the interference as well as we are or weak by coordinating or by doing the resource allocation. I think those have been covered. Resource allocation might have been covered in the LT lecture. By introducing the reinforcement, I am able to improve the quality of our experience, or by properly scheduling the resource allocation radio in terms of radio or frequency or in terms of time, I am able to avoid the interference. Another concept that we have discussed during the release discussion was carrier aggregation. Right? Carrier aggregation in simple term is basically like till now, till 3G, 2G, we know that once I say this particular for like CDMA, it was 1.25, UMTS 5 megahertz. This is the band. So the device will be operating in that band only, right? So if I say it's a 5 megahertz, so it will be working 5 megahertz. I'm not, despite having more bandwidth with me, I cannot connect two bandwidths so that I can have a 10 megahertz and I can serve the same subscriber by increasing the bandwidth to 10 megahertz. This feature were not available in 3G. But from the 4G onwards, what happens? The standards or the technology provides me to combine or aggregate the multiple or different carrier bandwidth. Suppose I have a 2 or 3 different frequency allocation with different bandwidths, which may or may not be contiguous, right? What happens? I can club from my BTS E node B here, from E node B to user device. I can basically combine different carriers, so they will look to the user device as a common point. So the release 10 basically provides up to like 5 component carriers can be combined, and maximum channel bandwidth can be 10 megahertz, 100 megahertz. So this was the concept of carrier aggregation. Another concept was that of the relay node. In the relay node, the concept is that relay node, in simple term, I can say it is a kind of a repeater. But in what way it is different is that repeater is basically what happens. It takes the signal, simply amplifies it and retransmit. But in case of 4G, the concept of relay node that was introduced was that it will be basically hooked or connected to your donor E node B, DE node B. That was the regular E node B. And you install the relay node B. It will be connected to the E node B on the same frequency band which we are using. It will behave as if it is from the user point of view, it will connect it to it and then process the information, do the error correction, and it will be at the other end will be connected to your user devices. So this basically relay node is like functioning as a repeater to enhance or to increase the coverage, cell coverage, or to provide to extend the connectivity rather. But it is not true sense repeater because it is able to process for error correction and other features. So that concept was introduced. It was not having basically like it doesn't have the full-fledged functionalities. What is there in eNodeB from the point of view of scheduling, resource management, connecting it to your MME and all that. But it will be rented or it will be served through the donor eNodeB. With that, like we have broadly covered like what were the key enhancement in case of 4G and coming up to 5G. So this is like from Qualcomm. So from release 15, your standards or the activities for the 5G start. So release 15 is basically the starting point for your 5G standard. And here we will be discussing up to some of the key feature up to release 17. And presently the work is going on release 9. Right? So I was told by Mr. Abhay, our AGM, that 5G was also to be included. So I have few slides for the 5G, then I will cover one slide, what are the features for 15, 16 and 17. So 5G, I hope 5G has not been yet covered. Has it been covered, 5G?
No, sir. Even 4G is not covered, sir.
LTE has not been covered.
No, sir.
Anyway, I have some slides from the 4G point of view. LTE, I will check with the team how they are doing. I thought that this might have been, or they might have planned it. I don't know. Let me check it. But I planned it for 5G because I was told that 5G is to be just covered. So there are 2-3 slides in which I will be just discussing the basic philosophy of the 5G and 1 or 2 key features of the 5G. With that, we will close our class. So 5G basically, like to start with, like for example, if I come up with any new technology, I have some requirements. Okay, मुझे कुछ भी नया चाहिए होता है, then I should know मुझे क्या नया चाहिए. So when people were deliberating for like 3G, the key requirement was that okay, it should be able to support more data rate, more number of users, or spectral efficiency. Then people or the operators were discussing 4G. Still that time also, the key requirement was more of a data. YouTube link. Just wait. I will just pass on the message to share the link. So when 4G standards were being thought of, the key thing was data rate. Why? Because like if you see during that period, 14, 15, year 14, 15, all that, the importance or the activity, most of the traffic were diverting towards your data consumption. At that stage, the operator, when tried to come out with their own traffic in terms of voice as well as data, they observed that the data traffic is overcoming, or data traffic is basically increasing vis-a-vis your voice traffic. So the importance of data traffic was realized, and the focus was more or less on data traffic as well as to some extent capacity, as it was there in earlier standard. But when the standards for 5G were being thought of, so they had basically 3 type of requirement in the mind, right? Any guess? If few people are asked for what are the typical requirement that you want to have in mobile network, then they come up with the three type of requirements. First one was they categorized as EMBB, enhanced mobile broadband. So this was the requirement that was basically originated, or that was basically trying to address the heavy data rate, right? You want a very good data rate to be able to download the movies, video streamings, and all of the things. Second concept that came was URLCC, ultra reliable low latency communication. So they envisage that there are some application which needs a high reliability as well as low latency. I have some slide like in which we are covering the scenarios, also the applications for each scenario. And third type of scenario they envisaged was basically MMTC, massive machine type of communication. So this basically originated from like IoT was there, but then it was a limited. Like there were some devices which were connected, but then they thought now the IoT type of application will be increasing to a massive level, and they made it a generic that it is a machine type of communication and massive machine of type of communication. And just covering each type of scenario. First one is enhanced mobile broadband, EMBB. So as I discussed, EMBB was the case for to improve the data rate, latency, user density, coverage. So it was a basically kind of a superset for your mobile broadband access, which allowed live streaming of applications in crowded environment. The initial application that they thought of was that like if you people are sitting in the stadium watching a football match, so there are thousands of people, and they wanted to share some live clip or to their friends or colleagues. They will be like a large number of users will be there, as well as huge data rate will also be required to do all those things. But over the time, some of the applications that are being used, they been adopted or falling in the category of EMBB are like ultra high density streaming and cloud enterprise enterprise and public cloud network. Then augmented reality, virtual reality, high definition.
एक्चुअल में ये तो रिलीज कर दिया बोल रहा था यार, पता नहीं उसका जो पहले नंबर 48 है ना, वो भी अपने यहाँ से एक्टिव बता रहे हैं, और वहां से वो जो बोलता है उसके सिस्टम में तो
I think somebody has unmute. Need to.
तो वही सिंह मॉनिटरिंग वाला वही तो ना, नहीं इसको बोला हूँ ये योगेश को देखेगा उसको, और बाकी वो 10 को, हाँ 10 को जो चालू करना है उसको भी तो कर दिया बोल रहा है, अनबोर्डिंग कर दिया बोल रहा है। नहीं
Please
नहीं, हाँ
unmute your mic.
योगेश, चलिए योगेश को और बोलता हूँ। अरे आज तो चालू कैसे होगा?
Sorry for the interruption. So like augmented reality, VR reality, some of my time you have seen, it requires say like a heavy data rate from each type of senses, different uh, feeling, different type of transducer parameters, information has to be transmitted at very high data rate, as well as like definition video conferencing requires a high data rate. Holographic conferencing, like you have to basically virtually making somebody be there by using a holographic image. So all those applications requires a connectivity using a very high data rate. So those were the applications that were like envisaged for EMBB type of usage scenario. Another scenario was URLCC, ultra reliable, low latency communication. So in this, some examples are robotics, smart manufacturing, AR, VR, connected enterprise devices. Another example that is being quoted for this URLCC is like robotic surgery. So for example, or automated vehicles. So if you say in robotic surgery, uh, people are like the patient is some thousands of kilometers away from the surgeon or the doctor and is performing some kind of surgery. Then the connectivity has to be highly reliable. You can't afford to be a kind of a like afford to have a kind of a break or disconnectivity or communication gap at the two end, right? As well as the latency also. Whatever command with respect to the cut or stitch or such is given by the surgeon sitting at the remote end has to be executed at the same time without any delay on the patient. So that those are the application which require reliability as well as the low latency. Another application is automated vehicles, self-driven vehicle, where what happens that the vehicle is basically sensing information from the nearby street poles, street furniture, lamp poles, is trying to sense from their transducer different information whether any obstruction is there or not. So, and this all has to be passed on at the application server as well as to receive, you should be able to receive the command from the application server, which is controlling all those things. So it has to be reliable as well as a low latency. Because suppose if all of a sudden the vehicle communicates, okay, there is some object ahead, and then that information is not being able to be passed on to the application server or to the local network there, and is not able to receive the communication of stopping the vehicle, accidents may happen. So, okay, and robotics industry 4.0 is basically like it was envisaged that you need some kind of a like cutting or greasing are there, operations are there where high precision is required. You have to be immediately effect those operations in picture. So there it is a requirement of a ultra low latency. AR, VR is also there, like whatever uh, my movements are there, that has to be reflected at the other end in the same, immediately without much delay. That's why like this information is a bulk data as well as it has to be low latency in terms of transmission. So connected enterprise devices, smart grids, industrial automation, these are some of the applications which are requiring URLCC scenario. Third is MMTC, massive machine type of communication. So one of the best, one of the example, good example is a smart city. You see the smart city, like there are so many things which are connected to your through your network. Smart energy meters are there, water quality, smart parking, vehicle charging. So those are the devices which will be like in a small township or a society, you will be having thousands of such sensors which need to be taken care of. So that's why it's a massive machine type of communication. Or for logistic and track fleet management, there will be a lot of devices will be there. In parking lot, there will be a lot of devices will be there. So these things will be requiring basically a lot of devices to be connected to the network. They may not be requiring the high throughput, but they will be required like number of the devices to be supported by the networks are huge. This is a different requirement. So this is a picture from ITU document when they came out with the vision document for the 5G. If you see that we have at the three corners, they are the extreme case for each type of usage scenario. First one is like enhanced mobile broadband, and the other corner is the URLCC, MMTC. So you see that gigabytes transmission in 2 seconds, 3D HDLD those are the application that are taking care of that they are falling under the EMBP type of scenario. Then in URLCC, you see that mission critical application, health, self-driving car are there, and MMTC smart cities are there. But there are some applications which will be falling in between these three extremities, and accordingly, like standard has to be designed. So that has been taken care of while coming out with the standard. We'll be seeing that in next slide. Like if you see augmented reality will be basically requiring both type of feature and mobile broadband and not mobile EMBB as well as URLCC, right? So I think the slide is not there, but I would just like to make one point that uh, we have discussed the three type of scenario, and we have discussed like different capabilities for each type of. So one thing you have to keep in mind, there are some parameter that has been specified by for the 5G in terms of data rate, in terms of latency, like latency should be less than 1 millisecond, which was there in case of 4G 10 millisecond, data throughputs and spectral efficiency. But all these requirements will not be required at the same time in one particular type of application. So whenever any application is being offered or the standards are being specified, they take care of the application aspects also that you have to keep in mind. Just for the okay presentation, I will share with the team and it can be shared. I think whatever whether WhatsApp group is there or it can be shared. No issue. It will be shared. I will provide them the. So another terminology that are being quite popular when migrating from 4G to 5G is SA and NSA. Right? Being a telecom man, we should know this one or two terminologies also. SA is a standalone and NSA is non-standalone. So 4G is basically what your 4G is your LTE network, LTE advanced network. You migrated to 5G. So there are basically two approaches are there. First one is a standalone and second is non-standalone. Keeping it very simple, SA is the technology when only one radio interface technology is there. Like when only 4G is there, it is a standalone of 4G. When only 5G radio is there, it is basically referred as 5G SA. In case of NSA, you have basically two multiple access radio technology. Like you are having a radio access network for 4G as well as 5G. So this is a basically like a example for SA. On the left side, if you see the 4G evolved packet core is there, 4G LTE. LTE is basically like a radio interface. Technically, it is a radio interface. That's why it's 4G LTE is a radio network for the 4G core. EP is evolved packet core is the 4G core. On the left side, when only one radio interface is there, it is basically 4G standalone network. On the right side, like 4G core is there, uh, 5G core is there, sorry, and 5G NR. Basically, the radio network of 5G is referred as a 5G NR, and G node B is the uh, equivalent of your BTS or node B. So when only one type of core and compatible with that type of radio network is there, that is referred to as a standalone configuration or standard migration. So in case if I decide to go that my whole network will be having only 5G core as well as 5G RAM, then that will be basically a standalone approach, right? I'm not considering existing 4G deployment, I am basically going ahead with the full-fledged 5G core as well as 5G band. Right? So from the day one, I will be able to support all three type of scenario: EMBB, MMTC, and URLs. Right? And this option is basically exercised by the operator, which are the greenfield operator or who are just entering the market. Because otherwise, the existing operator will be having a network, their 4G network, and in one day they cannot say, okay, say buy and put or replace with the 5G network. Another approach is non-standalone, right? NSA. So in this, if you see, the blue color is basically like evolved packet core network is basically for your 4G core. LTE node B again 4G radio network, and you have installed 5G radio, that is a G node B, right? If there are some pockets which are requiring high data rate, you have installed 5G G node B. So in this architecture, if you see, you are having two type of radio interface, 4G as well as 5G, and both are basically parented to your 4G core net. So there will be some enhancements will be required to support G node B by EPC. So slowly you are basically trying to introduce your in the radio network, you are putting your 5G nodes, G node B, and your existing LTE node B or your 4G network is there in the network, and that both are being taken care of or being covered by the world packet core of 4G. So this type of migrating from 4G to 5G is referred as a NSA. And another combination possible is that you have a both 5G and 4G core, and your existing 4G E node Bs are being parented to your G node B and this NG4 5G core. So when this type of migration is there, that is referred as the NSA. When there's a full-fledged BTS, sorry, full-fledged core as well as full-flow radio is there for 5G, that is referred to as standalone compute. In this one also, like there are about 8 combinations are possible. We have discussed broadly too, because even the G node B can handle your E node B, or E node B can be directly parented to the 5G core. It can be parented through G node B. So the various combinations are available in terms of which is handling the control part and which is handling the signaling, sorry, data part for your other two networks. Another thing that is quite popular or which is like quite visible with the 5G is a beamforming concept. So in the beamforming is basically like in the left side, if you see in case of standard antenna, you have a coverage, right? Right. Simple coverage, which is covering the three items that has been shown: house and a mobile subscriber as well as speaker. But with the help of the beamforming in 5G, what I can do, I have the flexibility of making a beam towards each cluster or towards each entity. In the simple term, this is basically you are able to achieve it because of view of you are migrating towards your very high frequency band. You might have known, basically you may be knowing that the size of the antenna depends on the frequency being used. Lower the frequency, higher will be the size of the antenna. So when we are using 2G and 3G frequency bands, you have a suppose some size of antenna. But when I move to 5G technology, 5G network, I'm using the frequency in the bands of gigahertz, right? 20 gigahertz, 20 gigahertz, and they are working up to 70 gigahertz and all that. So if you see when my frequency is increasing, the size of my antenna will basically reduce. So whatever, suppose one antenna, within one antenna that was being taken care of in the standard antenna on the left side, if I use or if I adopt some gigahertz frequency range, so in the same size of the antenna, which I was using in for 3G or even for 4G, I'm able to place 64 to 56 antenna. And I can individually control each antenna. I can be controlled individually. So I can control a bunch of the antenna and make a beam. That was the basically concept adopted in case of beam forming. This beam forming can be horizontal as well as vertical. Suppose if you are in a multi-storied building area, so like you get a complaint sometimes, okay, my lower floors are getting covered, but not on upper floor. So with the help of 5G, basically like with the help of 5G and basically using a high frequency link in gigahertz, I'm able to point, I have a vertical beam forming also. I can make a beam for the upper floors, middle floors separately, right? To just sum up, so release 15 was basically like the first new radio release, and it supported vehicle to X services, IPMS core subsystem, IMS. The thing is, one thing I would like to just mention it, not in a, like up to 3G, we had circuit switch as well as packet switch. From 4G onward, there is nothing like circuit switching. Everything is packet switching. So for voice and all that, we are basically using a packet switching, and with the help of IMS, we are making voltage and voice calls. So this is the like a key architecture difference from 4G onwards. Everything is basically packet switching. There is no concept of circuit switching. So IMS will be there till that time. Then release 16 is basically phase 2. And like first NR was basically towards more towards NSA type of application or focused on radio. Then release 16 phase 2 was basically uh, NR based except for unlicensed spectrum and satellite access. Then release 17 has the several features like they were more like towards MIMO, power saving, and enhancement required for physical layers in RF band to support frequency band 52.6 gigahertz and till 71 gigahertz. With that, I will close my presentation. If you have some quick question, we can have it through chat or any questions? Okay, then thanks all for the patient hearing. Sure, sure. I will convey to my team that the link and the PPT material be shared positively with all the thing and relevant reference material. Those who are uh, to- quite interested in the 3GPP or having a in-depth information on the standards or these things, you can visit the 3GPP website. It's rich in original and authentic information because they're the body which is developing all these standards. So you people can refer to those things. And not having like a face-to-face meeting, I think it's a bit constrained here. But then anyway, thank you all. Bye.
Good afternoon. Am I audible? Yeah, okay. And slides are visible. Slides are visible. Oh, okay, okay, okay. Thank you, thank you, thank you, thank you. So today we are going to discuss about LT and LT advanced. So these are the today's discussion topics. First, we will see LT principle and technology, LT network architecture, how LT network is composed, what is the entity in LT network, and how they are connected to each other. After that, we will touch about the LT advanced and some main functionality of LT advanced, like a carrier aggregation, possible carrier aggregation scenario, benefit of LT compared with LTE. If you have any query, please feel free to write in the chat box. Before going to start, these are some terminology which I am going to use in this discussion. First one is a LTE. As you are well aware that in any telecom architecture, we have divided into two parts. One is a access part, other one is a core part. In access part, in LTE, access part also known as the radio part. And the radio part is also known as the LTE, long-term evolution. SAE, name of core part. And EPC and SAE, both are same thing. EUTRON, Evolved Universal Terrestrial Radio Access Network. eNode B, this is the one entity available in radio part. MME, this is the node which is available in core part. This is a pure signaling node which is available in core part. You will have to remember these full form. Sometimes these are asked in the exam. What is the full form of MME? If you compare legacy network with the LT network, then equivalent to GDSN, this PDN gateway, packet data network gateway. This is just equivalent to gateway. PCRF, policy and charging rule function. The basic functionality of this node is to control the quality of service of the subscriber. Suppose one subscriber take 1 Gbps per day plan, subscribe for 1 Gbps plan, and he exhausted his limit, then DSP has to control his quality of service. So they are doing with the help of this node, PCRF. This type of policy, they are controlling with the help of this node. HSS, Home Subscriber Subsystem, just like a HLR. HLR working on MAP protocol or C7 signaling, and this HSS working on IP or diameter protocol. So this is the only node which 3GPP has taken from release 5. Otherwise, all the node in LT network is evolved node, new nodes. EPS, entire system of LTE known as evolved packet system. Next is serving gateway. Serving gateway comes under user plane. MME is controlling plane and serving gateway comes from user plane. These are the some abbreviation which I am going to use in this discussion. Now, the question is what is the LTE? LTE basically the project of 3GPP, and 3GPP started this project in November 2004 for higher performance, wide application, and higher throughput. So they have started, 3GPP has started LTE network in November 2004, and first release comes in 2008. First release came from 3GPP frees the specification for LTE in 2008. And this network commercially available in 2010. You should remember year 2008, the first specification they have freeze in year 2008. And in 2008, they have all, ITU is published IMT Advanced. IMT Advanced document. What is the IMT Advanced? Anybody? What is the meaning of IMT Advanced? IMT 2020, IMT 2030. What is the meaning of it? Anybody? IMT Advanced, basically this technology, LT technology, is academically 3.9G generation. 3.9G generation. 3.9G generation. Okay. This is a full form of international mobile telecommunication, but what is the IMT Advanced? My question is, what is the IMT Advanced? IMT Advanced, basically the vision for 4G network. ITU has released. This is the basically vision document for 4G network, IMT Advanced. And LT is 3.9G generation, and they freed specification in 2008. Then 3GPP, based on IMT Advanced requirement, 3GPP enhanced LT network and given new 3GPP specification for LTE Advanced. IMT Advanced is the basic vision document for 4G network, and LTE Advanced is the true 4G. And for okay. So IMT Advanced is basically vision document, and LTE Advanced is the technology which is the enhancement of LTE. But LTE is not a 4G technology. LTE is a 3.9G technology, but it's marketed as a 4G technology. So you should differentiate what is the IMT Advanced, what is the LTE, and what is the LTE Advanced. LTE Advanced is basically, we will discuss in detail what we have done in LTE Advanced. These are the band. These are the band for LTE technology. This is the FDD band. FDD band, band 1 to band 25, FDD band. After that, band 33 to 43, TDD band. See, in GSM, there are only two bands specified, 900 band and 1800 band. And the carrier bandwidth is just a 200 kilohertz. In CDMA band, they have specified carrier bandwidth is 1.25 megahertz. In UMTS, 5 megahertz, and they have specified only one band. But in LTE, you will see there are lot of band
have been defined by 3GPP, still they are adding more bands in LTE technology. And carrier bandwidth also, see, there is a scalable carrier bandwidth. They have specified variable carrier bandwidth in LTE. The minimum carrier bandwidth is 1.4 megahertz and maximum carrier bandwidth is 20 megahertz. So with the help of this scalable carrier bandwidth, we can enhance spectrum efficiency. We can enhance spectral efficiency. So if some TSP having only 1.4 megahertz spectrum, he can launch on only LTE network on 1.4 megahertz. So as you well aware that for IoT or in forest area, only minimum bandwidth is required. So TSP can launch his network on 1.4 megahertz, where throughput is high throughput is required, then he can launch on 20 megahertz. The point is that in legacy network, we are having only single carrier bandwidth. The carrier bandwidth, this is the carrier bandwidth between mobile station to BTS, between mobile station to BTS. One thing also, if carrier bandwidth is increased, then channel capacity will also enhanced. This is we have studied in communication technology, one channel capacity theorem. The channel capacity theorem, you should remember, channel capacity theorem equal to B log base 2 1 plus SINR. The carrier bandwidth enhanced, then it means that throughput will be increased. These are the system requirement. I have taken some important specification from this document, TR 25913. This is freely available in 3GPP website. So I have taken some system requirement, and so many system requirement they have defined. I have taken some specification. Those are adopted by industry, telecom industry. The first point is that peak data rate. The peak data rate, the first specification is 100 Mbps in downlink and 50 Mbps in uplink. But in case of CISO, single input and single output, there is a one stream we are transmitting, one stream we are receiving, single antennas. So 100 Mbps in downlink and 50 Mbps in uplink. This is the specification for LTE, but for CISO, in case of CISO. It supports MIMO also. We will see what happened. Improved spectrum efficiency 2 to 4 times better compared to legacy network. Improved latency. The latency is in order of 10 milliseconds. For a small packet, this is a 10 millisecond. For large packet, we are achieving up to 100 milliseconds. Support of scalable bandwidth 1.4 to 20 megahertz. 6 carrier bandwidth they have specified. 6 carrier bandwidth they have specified. And next, LT system supports FDD and TDD both mode. Frequency division duplex mode and time division duplex mode. Both the mode LT is supporting. Support for interworking with legacy network. This is the backward compatibility. This is the prerequisite for any technology, any new technology that should be backward compatible. Better mobility. It supports up to 350 km per hour real-time services. 350 km hour, this is the speed of bullet train. Cost efficiency, reduce capital and operational expenditure, including backhaul. How? We have removed so many nodes, number of entity we have reduced in LTE. There is only flat architecture, number of nodes they have reduced in LTE technology. Now some key parameter. Here suppose if we are using a 20 megahertz carrier bandwidth, then we will get 100 resource block. What is a resource block? I will tell you in coming slide, but you should remember at present, if carrier bandwidth is high, then number of resource block is high. If we reduce carrier bandwidth 10 megahertz, only 50 resource block is available. As you remember that in BSNL, we have shut down our 3G nodes or radiate LT node, LT BTS, then we are using 5 mega spectrum in which only 25 resource block is available. Only 25 resource blocks are available. So if you reduce spectrum, yes, somebody is saying something? Okay. So on 25 resource block, if we are using carrier bandwidth of 5 megahertz instead of 20 megahertz, it means that through will be decreased by 4 times. Please mute. Please mute. Please mute. Please mute yourself. Some disturbance is coming. Okay. Next parameter is a modulation scheme. Modulation scheme also it supports QPSK 16 QAM and 64 QAM. This is also adaptive in nature. In downlink, it supports QPSK 16 QAM and 64 QAM in downlink. So if we are using a QPSK, then it means that we are packing 2 bits per OFDMA symbol. Per 2 bit per OFDMA symbol. If we are using 16 QAM, it means that we are packing 4 bit per symbol. In 64 QAM, we are packing 6 bit per symbol. So just like a carrier bandwidth, this is also one parameter. If we are going through higher degree modulation. So for example, in these days, suppose Wi-Fi 7 is supposed to come. In Wi-Fi 7, we are using a 4096 QAM in which we can send 12 bit per symbol. Similarly, as you well aware that beta version of LTE BSNL has launched in Punjab. So those eNode Bs supplied by Tejas, they support 256 QAM modulation scheme. So my point is that if you are going for higher degree modulation, it means that we are sending more bits in one symbol. So in this way, Rajinder sir, I will tell you what is the resource block in coming slide. I will tell you in detail. No issue. Please wait. So this is also one parameter by which we can enhance our throughput. One, I have told carrier bandwidth. Second one is higher degree modulation. We are going towards higher degree modulation. So, and this modulation scheme is adaptive in nature. What is the meaning of it? Your user equipment and eNode B negotiate based on radio quality. If radio quality is good, then system will go for higher degree modulation. So there is a one parameter for with the help of their this parameter we measure radio quality, that is a CQI, channel quality index. Channel quality index. This is the 4-bit. 4-bit. It 1 to 15. The value of CQI is 1 to 15. If CQI is 1 to 6, it means that it will go for QPSK. If sequence is 7 to 9, then it will go for 16 QAM. And 10 to 15, the system will go for 64 QAM. So based on radio quality, your UE and network negotiate which modulation scheme they are going to use. Okay. Next parameter. Next is a multiple access. Multiple access, we are using OFDMA in downlink. OFDMA, what is the OFDMA? This is a basically multi-subcarrier system, multi-carrier system, orthogonal frequency division multiple access, OFDMA. The one inherent disadvantage of OFDMA is its PAPR is very high. Peak to average power ratio is very high. So if you use OFDMA in uplink, then what happens? The battery of your user equipment will drain so quickly. So that's why we are not using OFDMA in uplink due to disadvantage of OFDMA. The peak to average power ratio is very high for in OFDMA. So we are using SCFDMA in uplink. So this is the, we are using access method OFDMA for downlink and SCFDMA for uplink. Due to peak to average power ratio, PAPR is very high in OFDMA. So this is the access method. MIMO technology, it supports 4x4 in downlink, 4x4 in downlink and 2x2 in uplink. 4x4 in downlink and 2x2 in uplink. It means that your E-node can transmit 4 streams. You're able to transmit 4 streams simultaneously, and your mobile handset also can receive 4 streams simultaneously. Suppose if we are using 4x4 MIMO, then throughput will be 100 into 4, 400 Mbps. If system is using 4x4 MIMO, it means that 4 Mbps throughput will come. If system is using 2x2 MIMO, it means that 200 Mbps throughput is. Approximate 25% is overhead in LTE. Approximate 25% overhead. Overhead means signaling, for control, for transmit, VCCH, also for BCCH. So 25% is overhead. So if you are using a 4x4 MIMO and minus overhead, then throughput will be 300 Mbps. This is the basically 300 Mbps in case of carrier is 20 megahertz and minus overhead. And this throughput is the total throughput of one transmitter. We are using a 3-sector site, so it means that 3 transmitters are there. So this is the throughput for single transmitter. And this throughput we will distribute among the subscriber in one sector. Similarly, 2x2 MIMO, suppose 20 megahertz carrier, then throughput will be 200 Mbps and 25% minus 25% is overhead. Then actual throughput will be 150 Mbps. If we are not using MIMO, in case of CISO, so there is only 100 Mbps. If minus through overhead, then 75 Mbps. In uplink, 50 Mbps I have told in case of CISO. 2x2 MIMO, the system is support for uplink, then 100 Mbps minus overhead, then 75 Mbps will come. Any query in this slide? This slide and previous slide is important for your exam point of view. They will ask what is the modulation scheme, what is the multiple access, the key parameter and design requirement. These are the important slides. The flat overall architecture, this is the architecture of LT is known as a flat architecture, and this is the pure packet network. Access method OFDMA, SCFDMA. This is the scalable carrier bandwidth, latency in order of 10 milliseconds. We have discussed these things. See one video.
LTE stands for long-term evident. LTE stands for long-term to delivered accordingly. And an IP multimedia subsystem to handle voice over LTE and other. Today in LTE, LTE.
Audio of video is coming.
LTE.
Yes.
Yes.
Okay.
LTE, key technology, OFDM. Today's data rate becomes higher as teletechnology is evolving. In GSM, data rate is only 9.6 kilobytes per second. In UMTS, the rate is increased to 21 megabytes per second. Today, in LTE network, it can be more than 100 megabytes per second. What kind of key technology makes LTE so fast? It's OFDM, which involves frequency division multiplexing, FDM, and multi-carrier communication. FDM divides the available bandwidth into many subcarriers and allows multiple users to access a system simultaneously. Different users' data transmits on different subcarriers. Between subcarriers, there is a guard band to avoid interference. In multi-carrier FDM, the data of the users can be split into multiple substreams and transmit them in parallel to make the data rate higher. While OFDM, the subcarriers are designed to be orthogonal. This allows subcarriers to overlap and saves bandwidth, thus achieving higher data rate. Therefore, OFDM technology is adapted in LTE to make the data rate higher. LTE, key technology.
So So in FDMA, what we are doing, in OFDMA, what we are doing, we are not transmitting. This is, for example, in LTE, maximum carrier bandwidth is how much? Maximum carrier bandwidth, how much? How much carrier bandwidth maximum? Minimum is 1.4 megahertz and maximum is 20 megahertz. 20 megahertz. 20 megahertz carrier, maximum carrier band size of maximum carrier band we are using in LTE is 20 megahertz. So we are not modulating data on this carrier. What we are doing, we are making a small subcarrier, just like a F1, F2, F3, like that. In 20 megahertz, there are 1200 subcarrier. 1200 subcarrier. And the size of one subcarrier is 15 kilohertz. 15 kilohertz. The size of one subcarrier is 15 kilohertz. And each subcarrier, the size of one subcarrier is a 15 kilohertz, and all the subcarrier are orthogonal to each other. What is the meaning of it? The meaning of it is that the characteristic of F1 and F2 and F1200, all the subcarrier is entirely different. So what happened? So we can transmit all the subcarrier in same time. We can transmit all the subcarrier in one time. So 1200 subcarrier, it means that we are using only 18 megahertz. We are using 18 megahertz. 18 megahertz. How 18 megahertz? 1200 into 15 kilohertz and equal to, it will come 18 megahertz. 18 megahertz. 18 megahertz. It means that we are wasting up 2 megahertz by making subcarrier orthogonal to each other. So we are transmitting our data on this subcarrier, F1 subcarrier, F2 subcarrier, F3 subcarrier, like that. So that's why the OFDMA is multi-subcarrier system. In traditional method, this is the conventional multi-carrier technique. This is the one carrier. After that, to avoid the interference, we will have to leave some carrier. This gap we will have to leave. After that, next carrier, between two carrier, we will have to leave some guard band to avoid the interference. But in OFDMA, we are transmitting all the subcarrier in same time. All the subcarrier is orthogonal to each other. It means that there is no interference. So by this way, if we will compare with the conventional FDMA, so we are saving approximate 50% bandwidth. My point is this. Now come to OFDMA. This is the basically one radio frame. The size of radio frame is 10 millisecond. Size of the one radio frame is 10 millisecond. And it consists 10 subframe. The size of one subframe is 1 millisecond. In one subframe, there are 2 slots. There are 2 slots, and the size of one slot is 0.5 millisecond. And in one slots, we are packing 7 OFDMA. We are packing 7 OFDMA symbol. We are packing 7 OFDMA symbol. So this is the basically a frame structure of LTE. There are 2 types of frame structure. One is for FTD, other one for TTD. So for one, I am taking example of FTD. So here, the size of one frame is 10 millisecond, and it consists 10 subframe. So then the size of one subframe in time domain will be 1 millisecond. In 1 millisecond, there are 2 slots. For what? Google Drive link. What Google Drive link? Mina? Okay. Okay. So this is the frame structure. Don't confuse. Don't confuse. This is simply, I am saying this is the frame structure of LTE type 1 for FTD. So I'm repeating once more. The size of one FTD is 10 millisecond. In 10 millisecond, there are 10 subframe. In one subframe, there are 2 slots. In the size of one subframe is 1 millisecond, and size of one slot is 0.5 millisecond. In this duration, we are packing OFDMA symbol. 7 OFDMA symbol in one subcarrier we are packing. 0 to 6, 7 OFDMA symbol. So between OFDMA symbol, this yellow color is shows cyclic prefix. This yellow color, this is a basically gap between 2 OFDMA symbol, and this gap is known as a cyclic prefix. And in LTE, 2 types of cyclic prefix is defined. One is a normal cyclic prefix, and other one is a extended cyclic prefix. What is the significance of this? This is used to avoid ISI, inter-symbol interference. Inter-symbol interference, we are using this cyclic prefix. If you are using a normal cyclic prefix, it means that 7 OFDMA symbol in one subcarrier. 7 OFDMA symbol. If you are using an extended cyclic prefix, then extended cyclic prefix, it means that you are extended this gap. If you are extended this gap and the total this is a 0.5 millisecond, then you will have to compromise 1 OFDMA symbol. So it means that there are only 6 OFDMA symbol in case of extended cyclic prefix. If you are using a normal cyclic prefix, it means that 7 OFDMA symbol. 7 OFDMA symbol. And this is the time duration, 4.6875 microsecond for normal cyclic prefix, this yellow color time. And for extended cyclic prefix, 4 times. Now come to the what is the meaning of resource block? What is the meaning of resource block? The resource block, in previous slide, I have told that in 20 megahertz, there are 100 RB. If you reduce carrier bandwidth, then number of resource block will be also reduced. So resource block means if in frequency domain, there are resource block in frequency domain, 12 subcarrier, pool of 12 subcarrier. Pool of 12 subcarrier is known as resource block. In time domain, 0.5 millisecond. The size of FDD frame, in FDD frame, the slot size is 0.5 millisecond. So we are packing this RB in that slot. So in question is that what is the meaning of resource block? The in frequency domain pool of 12 subcarrier. Pool of 12 subcarrier. So we are transmitting 12 subcarriers simultaneously. In LT, what we are doing, we are transmitting bunch of 12 subcarrier. Then RB, the size of RB, 12 into 15 kilohertz, it means that 180 kilohertz. So this is the one subcarrier. This is the F1 subcarrier. This is the F2, F3, F4, F5, like that, up to F12. So in one subcarrier, 7 OFDMA symbol. One subcarrier, 7 OFDMA symbol. Then this small block where I'm packing a data bit. This is known as resource element. This is known as resource element, and this is the smallest entity in LT network. This is the smallest resource unit. Yeah, smallest entity in the LT network. Here we are packing data bits based on modulation scheme. If system is using 64 QAM modulation, it means that we are packing 6 bit per symbol. 6 bit in this block. 6 bit in this block. How many resource elements is available in one resource block? Write in chat box. How many resource element is available in one resource block? Very good. Very good, Yogender. Very good. Suppose if I'm using an extended CP, then how many resource element in one resource block? Yes, yes. My next question is, if I'm using an extended cyclic prefix, then how many resource element will come? 72. Yes, exactly. Exactly. Okay, it means that you are following me. So minimum requirement of one subscriber is 2 RB. Minimum requirement of one subscriber is 2 RB. Minimum you will have to assign. To do the service to any subscriber, the minimum requirement of one subscriber is 2 RB. 2 RB. Okay. See again. This is this color. Okay, this grid shows resource block. This shows resource block, and this is using a normal cyclic prefix. It means that in one subcarrier there are 7 OFDMA symbol, and in time domain the size of one resource block is 0.5 millisecond, and frequency domain 12 subcarrier and 180 kilohertz. So in resource element, 84 resource element is available if I am using normal cyclic prefix. So how many bit will come in one resource element? It depends on modulation scheme. Which modulation scheme I am using? If I am using 64 QAM, it means that 6 bit I am packing in one resource element. I hope this slide is clear to all. Now, see. See, this is my normal carrier bandwidth. 6 carrier bandwidth they have defined, 1.4 megahertz to 20 megahertz, and number of resource block is available 100, 75, 50, 25, 6 like that. But real bandwidth will be 18 megahertz, 13.5 megahertz, like that. Why we lost this 2 megahertz? To make the subcarrier orthogonal to each other. So we are transmitting of resource block. So there are 12 subcarrier. It means that 12 subcarrier I am modulating and transmitting. So in parallelly. So OFDMA, this is a carrier number 1, carrier number 2, carrier number 3, like that. So we are transmitting data parallelly in OFDMA, 12 subcarrier. But in SCFDMA, we are transmitting data serially. So for SCFDMA, we are not assigning single carrier to subscriber. Basically, this is also type of OFDMA. Here we are transmitting data serially. In OFDMA, we are transmitting a 12 subcarrier parallelly, but here we are transmitting data serially. So it looks like a single carrier, but it is not a single carrier. So the PAPR is very high in OFDMA, so that's why we are using SCFDMA. This question examiner asking so many times. Its PAPR is very high. Why SCFDMA is using? To increasing the battery life of UE. So this is a small calculation. How we will get 100 Mbps? Let's assume we are using a 20 megahertz carrier. It means that 100 resource block is available in 20 megahertz. Modulation, we are using a 64 QAM. It means that we are packing 6 bit per symbol. Number of resource element in 1 RB is 84. So minimum is the 2 requirement. 2 RB is required. In 2 RB, how many resource element? Multiplied by 2. Suppose we are using a modulation scheme 64 QAM. So 6 bit we are packing in 1 resource element, and total number of RB in 20 megahertz, there are 100 resource block. So in this way, we can calculate how many number of bits we are transmitting. How many number of bits we are transmitting? So 2. Why we are taking minimum requirement of one subscriber is 2. Number of resource elements, number of bit, and total number of RB. So we will calculate, then it will come 100,800 bits per millisecond. Why millisecond? Because the size of 1 RB is a 0.5 millisecond. So in 1 millisecond, we are transmitting 100,800 bits. So convert into per second, then throughput will become 100 Mbps. If you are using a 200 Mbps, if I am using 4x4 MIMO, then 400 Mbps per E node B. Per E node B means per sector, for one transmitter. So approximate 25% is overhead we are using. This is a small calculation for how we get 84. 84 we are getting. For this, you will have to remember what is a resource block. Resource block basically pool of 12 subcarrier. In one subcarrier, we are packing 7 OFDMA symbol. So 12 into 7. How 100 RB in 20 megahertz? Okay, 100 RB. The size of one RB is 180 kilohertz. Divided. So you should divide 18 megahertz divided by 180. Usable carrier bandwidth in 20 megahertz is available is 18 megahertz, Yogindra, and divided by 180. So you will get 100 RB. Okay, Yogindra? Okay, thank you. Any query till now? Any query till now? What we have completed? We have completed till now basic design requirement. What is the key parameter? Important some key parameter. What is the RB? One frame structure also we have seen, FDD. These things we have covered till now. If anybody is having any query, please write in chat box or speak. Unmute yourself and ask. Okay. Now second And second part, we are talking about architecture. Architecture. As I have told you in my introductory slide, in telecom, any telecom architecture, there are two parts. One is the access part, other one is the core part. So access part in LTE known as the LTE, and core part known as the SAE, System Architecture Evolution, or Evolved Packet Core. So these are two things, and there is also one term that is known as the EPS, which is the combination of LT plus EPC, which is a combination of LTC or LTC, LTE, and EPC. So this part is radio part is known as the LTE, and SAE and EPC both are same, SAE and EPC, and entire system known as evolved packet system. So this is basically comparison of UMTS network and EPS network. If you remember, in 3G in radio part there are two nodes, RNC and node B. So we have combined functionality of node B and the RNC in LTE, and that one new node come that is known as E node B, and each E node B connected to another E node B with the help of X2 interface. This is regarding radio interface. Now, but single nodes are available in LTE in radio part, and X2 interface is available between E node B. Now my question is that if from in core part, from which node will you compare? From which node will you compare from legacy network? My question is that, okay, one answer is coming. MSC, no, not MSC. Why? MSC is dedicated for switching, or you can say for voice call. This LT is a pure packet network, pure IP network. So we can't compare core network with MSC. MSC is not available. The functionality of MSC is not available in LTE. For voice call, we are using an external network like a IMS. So you will have to compare with the SGSN. You will have to compare with the SGSN. In SGSN, we have split into two parts. SGSN, we have split SGSN into two parts. One for signaling or controlling, other for user plane, other for traffic, data traffic, simple traffic, other for signaling traffic. So SGSN, the functionality of SGSN, we have divided into two parts. One for user plane, that is known as a serving gateway, and for controlling part, this is a MME, mobility management entity and serving gateway. And GGSN, like PGW, packet data network gateway. This is like a GGSN. So SGSN, we have split the connectivity through S1U interface. This is my user plan, or this is my controlling plan. That line shows the signaling or controlling. Any query? Okay. So these are some feature. No circuit switch components are available. This is a pure IP network. So all the if LT network is a pure IP network, it means that all nodes are having a functionality of router. Router functionality is available in all nodes. EPC and Utron, there are two parts. One is the Utron, other one is the EPC. Core part provide access to external IP network. Through PDN, we are accessing external packet IP network. the RAN perform all radio interface related function. It means that in RAN part, there is a one single node that is known as the E node B. All the radio resources managed by this node. So this is my core part, evolved packet core, EPC. EPC. So this is my LT and UMTS network, or this is my edge or GPRS network is connected to GPRS core, and GPS core connected to this evolved packet core. And evolved packet core also support non-3GPP IP access. Non-3GPP IP access means e-video, WiMAX, Wi-Fi, like those are not coming. Those technologies, those are not specified by 3GPP. Just like a WiMAX, Wi-Fi, CDMA, video, like that. So there are two parts. One is the control part, other one is the user plane. So this is the architecture. This is the architecture. This is the architecture. You should remember interface for exam point of view. So this is the UU interface between UE and E node B, and there are only single nodes available in radio part, and E node B is connected to through S1 MME interface to MME, S1U interface to SGW, and between SGW and PGW, there is a two interface defined, S5/S8. For S5 interface, if both the entity SGW and PGW is situated or installed in one licensing area or one circle, you can say, then S5 interface, otherwise S8 interface. This PGW belongs to Chandigarh and this belongs to J&K, then S8 interface. And SGW is connected to MME through S11. If MME to MME, S10 interface, and MME connected to HSS through S6A interface. HSS is basically permanent data type of subscriber, in which we are having data of subscriber like MSISDN, IMSI, subscription profile, or also some dynamic fields are also there. Just like a location of MME, location of MSC, location of SCSM, these are the dynamic fields. They keep changing. If subscriber is moving one place to another place, these fields are keep on changing. And one portion is also available here that is known as the authentication center. That is a software integrated part of in which we are having authentication key as well as some algorithm also. Milange we are also having here for authentication purpose. PCRF is connected to GX for policy and charging rule function, and PGW is connected to outer network, outer IP, external IP network. See, sir, are interface name randomly or they have some significance? All are having a significance, not a randomly. 3GPP has defined. 3GPP defined all the interfaces, the S1, S2, S3, like that. I am talking about only inside the LTE network. They all are having a significance. Okay. So the same slide, representation is different. Otherwise, same slide, if you see. Okay. Now come to functionality. And these are some terminology. These are some terminology. PDP context known as the EPS bearer, GPRS attached, EM registered. So like the location area. No relevant, because this location area belongs to circuit switching. Location area identity belongs to circuit switching, routing area, tracking area. RNC hides mobility from core network. Core network see the every handover, because there is a no controller type of things are available in radio part. So these are some question. Effective data rate in LTE in case of CISO. In downlink
100
mode.
Mbps.
Very good, very good. Your good name? Okay, next. BSC functionality are available in LTE. In which node?
T node B.
Very good, very good. BTS in LTE is called?
E node B.
Maximum carrier size in LTE is?
20 megahertz.
Very good, very good, very good. Okay. Now, till now, these things we have discussed. This is academically, this is a 3.9 GHz system. And R8 and R9 releases belongs to LTE. R8 and R9. Long-term evolution, the multi-sub-carrier system. This the size of one carrier is a 15 kilohertz. Flat architecture. The LTE is having a flat architecture. Evolved node B, evolved packet 4, system architecture evolution. These things we have discussed. Completely new nodes except HSS. OFDMA we are using in downlink and SCFDMA we are using in SCFDMA. SCFDMA we are using in uplink. Somebody is please mute.
दादा चावल रखा है चावल रखा है
Inna?
SD, please mute yourself. The person named SD.
Thank you, Vaibhav. Okay. So OFDMA and SCFDMA in air interface. Why SCFDMA? As I have already told, in OFDMA we are transmitting data parallelly. So 12 subcarrier we have to modulate. So high power is required. So we don't want to drain battery of user equipment so quickly. So that's why we are using SCFDMA. SCFDMA, nothing new. That this is also type of DMA. But here we are transmitting data serially, but in OFDMA we are transmitting data parallelly. More of MIMO, 4x4 MIMO LT supporting in downlink and 2x2 supporting in uplink. No CS domain. There is no CS domain for voice, for SMS. You will go in external network or external node, just like a IMS. High enhancement in PS domain. So these things we have discussed till now. Paper law. What is the meaning of it? Paper law. PAPR. Oh, okay, okay. PAPR is high. PAPR is high. This is the inherent disadvantage of OFDMA. Now IMT advanced. Okay. A single carrier. We are sending a serial. So this is the basically IMT advanced is the basically vision for 4G network, and ITU releases this vision in 2008. But till now, 3GPP freezes the specification for the LTE. So the requirement of 4G requirement requirement of 4G in vision document is 1 Gbps throughput. 1 Gbps throughput, but LT support only 400 Mbps. Only supports 4 Mbps. So this is according to 3GPP, this is the 4G technology, but TSP telecom service provider marketed as a 4.5G. So don't confuse. Don't confuse. They have marketed LT as a 4G technology and LT Advanced is 4.5G technology. So this is just a vision document. This is a vision document. What was the requirement? Some important requirement I have written. First requirement is that all IP, pure packet network. So LT supports this requirement. LT network support. Interoperability, this also support. And this data rate is not supporting LT network. So what they have asked in IMT Advanced 100 Mbps while the client physically move at high speed, and 1 Gbps while the subscriber is stationary mode. So these are the requirement for 4G network. Next, scalable carrier bandwidth. This also support one more 1.4 megahertz also they have specified, but the in IMT Advanced document 5 to 20 megahertz. This is regarding spectral efficiency, 15 bits per second per hertz in the downlink and 6.75 bits per second per hertz in the uplink. Seamless roaming. So these are the some requirement which is available in IMT Advanced document. So what 3GPP has done, he has taken LT specification and modified. And the enhanced version of LTE they have released in release 10. So for LTE Advanced, first release was release 10. 8.9 for LTE and release 10 for LTE Advanced. And for LTE 8.9, 10 to 11 LTE Advanced. This LTE Advanced fulfilled all the requirement of IMT Advanced. So according to 3GPP, this is the 4G technology, true 4G technology. Okay, same thing. I have to skip little bit. Okay. Release 10. Now these are the specification for LTE Advanced. In release 10, they have told that the LTE Advanced support 3 Gbps in downlink and 1.5 Gbps in uplink. And carrier bandwidth they have enhanced up to 100 megahertz. The carrier bandwidth enhanced up to 100 megahertz with the help of carrier aggregation. They are aggregating 20 carrier component, 20 CC, 5 carrier component, then they are achieving 100 megahertz. But this bandwidth is not available for any TSP in India. Number one. Number two, MIMO just double. MIMO just double. They have just double for 8x8 in downlink and 4x4 in uplink. So this is not a commercially available technology in India. Why? Because 100 megahertz spectrum in one licensing area is not available with any TSP in India. Number one. Number two, 8x8 MIMO supported handset is not available with subscriber. If you are going to purchase a new smartphone, to remember this specification also next time. Your handset is going to support how much MIMO configuration. So this is for 8x8 and 4x4 LTE Advanced. So you should remember carrier aggregation they have introduced, and they have introduced MIMO just double they have introduced if you compare with the LTE. And throughput is downlink in 3 Gbps and uplink 1.5 Gbps. So three things are there. One is the LT, other one is the IMT, third one is the LTE Advanced. So LTE Advanced, the enhanced version of LTE, and LTE Advanced fulfill all the requirement of whatever vision given by IT. All the requirement it is fulfilling. LTE is not fulfilling all the requirements. Some of the requirement LTE is fulfilling, but all the requirement is not fulfilling. Just like a throughput is not fulfilling. So what they have introduced in LTE Advanced. First one is a carrier aggregation. Next is a MIMO 8x8 and 4x4 in uplink, relay for LTE. Relay they have introduced it in coverage in low coverage area. Suppose as is so many blind spots are there in network, so they have introduced a small type of BTS that is known as the relay. So we will see. We will see. Just at present, you should remember what is a relay. Relay to avoid patches and blind spot in the network. So this LTE advanced technology, before it, the network type is homogeneous, but after relay introduced, small BTS is also introduced. So the type of network is changed. Heterogeneous network is now self-optimizing network enhancement. Self-optimizing network is enhancement is also available in LTE Advanced. Some of the feature of SON is available in release 8 and release 9, just like the ANR is available. After that, they have enhanced SON. Now, this is the comparison slides. This is the comparison slides. This is the LTE. This is the LTE Advanced, and this is the IMT Advanced. So 300 Mbps maximum. They are reducing 25% of overhead. So that's why 300 Mbps, 3 Gbps, and 1 Gbps. But stationary mode, this is 100 Mbps only. In uplink also, same thing. I hope this slide is clear to you. So this is just a comparison. This is a comparison of LTE so that you can visualize IMT Advanced, LTE Advanced, and LTE. Now, these are some feature. Carrier aggregation, the use of multiple components carriers CC to extend bandwidth up to 100 megahertz. So these are 5 components. If size of one component is 20 megahertz, so 100 megahertz is there. You can achieve 100 megahertz of carrier bandwidth. Next, MIMO technique, they just double 8 by 8. Relay concept they have introduced. Coordinate multi-point transmission and reception. Meaning of it, this is my mobile handset. Before it, this mobile equipment is connected to one eNode B. This is transmitting data and receiving data from one eNode B. But in coordinated multiple point transmission, this handset is transmitting and receiving data from more than one eNode B. From more than one eNode B. Suppose at present receiving from this eNode B, next schedule from this, next schedule is this. So it means that your handset is receiving and transmitting more than one BTS. This is a coordinate multi-point transmission and reception. Okay. 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 So for carrier aggregation, we are achieving 100 megahertz of carrier bandwidth. So in carrier aggregation, there are lots of flexibility. What is the meaning of it? Meaning of it, if I'm having, suppose I want to aggregate 5 carrier in downlink and 2 carrier in uplink, I can do. And these carrier can be continuous or non-continuous. Also, I can aggregate. If these carriers belongs to same band or interband, there is no issue. So many flexibility is available. So many flexibility is available in case of carrier aggregation. It depends upon TSP. So many flexibility is available. There is no issue in carrier aggregation. So same thing. I have told 3 carrier I am aggregating here. 5 component like that. Same thing. Number of aggregated carrier can be different in downlink and uplink. I have already told. Maximum 5 component carrier can be aggregated. Hence, the maximum bandwidth is 100 megahertz. In this way, I am achieving a 100 megahertz carrier. Component carrier, you should remember. So I can make a 40 megahertz carrier bandwidth, 60 megahertz carrier. So many flexibility is there. Band 1, intra-band contiguous, intra-band non-contiguous, inter-band non-contiguous, same thing, same thing, same thing, same thing, carrier aggregation. Carrier aggregation. So three, somebody is asking something. Release for LT advanced and IMT. IMT advanced is the only vision document. IMT 2020, this is a vision document. And for LT releases are R8 and R9. For LT advanced from release 10, 11, 12, 13, like that. Okay. So three carrier bandwidth I have aggregated. So the wavelength of this carrier is different. If this subscriber belongs to in this circle, it means that he can get advantage of all the aggregated three carrier. Here, this subscriber out of this circle, it means that he can get advantage of only two carrier. I hope this is a clear to you carrier aggregation. Okay. Okay, these things I'm skipping. MIMO, I have already told. Remember 8 by 8 into 4 by 4, more than enough. Relay. Relay, this is a small BTS, just like a femtocell, small FTTH, small FTTH CP, just like this. So this is my relay. I can put in blind spot, or any basement or any building. Their blind spots are there. Coverage is poor, so I can put. So this relay will take signal from this E node B, and radiate again. It can radiate on same frequency, or it can change the frequency. So this is the relay. So to avoid the blind spot. So repeater, we are amplifying the signal. Here we are receiving or retransmitting the signal in relay, just like a small BTS. You can remember this is the small BTS. And you can put through OFC also. You can put on air interface. This is the air interface receiving on air, or here you can give backhaul link also. Through OFC. You can receiving signal from here and you can transfer. Simply, this is just a small BTS. You can simply say. This is a donor E node B, or this is a relay node. So the coverage of this is like that. This is a receiving, and the coverage of edge we are enhanced with the help of relay. This is a coordinated multiple. Self-optimizing network shown. Anybody can guess how many parameters it takes to have one base station configured? Any guess? Only 10 minutes. Only 10 minutes. After 10 minutes, I will leave. How many parameters it takes to have one base station configured? How many parameters is required to transmit, to define, to integrate BTS in the BSC, or node B in the RNC, or E node B? How many approximate parameter? Any guess? Be quick, guys. Be quick. Guess any? Any guess? No. More than 500 parameter is required. Not 10. More than 500 parameter required. More than 500 parameter required to configure the one node B. Now, how many parameters it takes to run a UMTS network? Just guess. Just give any figure. Oh, Sushil Kumar, 50. 500 for BTS and 50 for entire network. Sushil, 500 require for run the one node B, and you require only 50 BTS, 50 parameter to run the entire network. Oh, so guess the more than 500 now. Okay, okay. See, see, see this figure. This figure, see. So 640 lakh. So you will have to handle these parameter. So that's why the SON concept is coming. It is very difficult to handle these all the parameter. But so that's why SON introduced. So so this self-optimizing network introduced in planning, in deployment, and optimization and maintenance. So optimization, so first, for example, automating neighbor relation and optimization. It meaning of it that earlier we will have to take, suppose I want to define a handover between two cells. So what we are doing, we are defining in the BSC, we are putting and measuring frequency relation between two sector. But here, what will happen? It will sense handover is required and not required. If required, it will sense or automatically define. Automatically define. It will in maintenance self-healing. Suppose if some cell, for example, sleeping DRU is coming in the network. So it will sense. For sleeping DRU, what will you do? You will have to block and deblock the TRX. So it will sense and automatically you will block and deblock. If some problem is there, automatically it will sense. Self configuration, plug and play, just like a USB. We are putting a USB and working on. Simply, you suppose if one node B you want to integrate, just give power and connectivity. It will start. It will start. In planning, radio parameter planning, and with the help of if you are doing a automatic planning, reduce self configuration error. So that's why we have introduced, they have introduced self-optimizing network. So in every department, self-planning, self-configuration, self-optimizing, self-healing. So since the release 8, they have introduced SON and keep on enhancement in every release regarding a SON 3GPP. So one video. See one video.
LTE stands for long-term evolution. It provides the fastest mobile broadband services commercially available today. The high-speed LTE stands for long-term evolution. It provides the
Voice of video is coming.
Coming.
Okay, thank you.
LTE stands for long-term evolution. It provides the fastest mobile broadband services commercially available today. The high speeds are made possible by using more radio spectrum per connection, multiple antenna pads, and more efficient encoding of the data being sent and received. In order to build an LTE network, some elements are required, such as antennas and radio base stations called eNode B. Transport network including microwave links, optical fibers, and IP routers. A connection to the internet and IP networks known as the gateway. A controller to manage mobility called a mobility management entity. A home subscriber server database, which contains information about all the individual subscriptions. A policy management system to ensure that the services you subscribe to are delivered accordingly. And an IP multimedia subsystem to handle voice over LTE and other multimedia services. Everything starts from your personal device. Here we go. Let's say you're making a voice over LTE phone call while you're sharing video and sending heavy emails at the same time. Boy, are you busy. The mobility management entity establishes the connections and controls the signaling with the terminal. Using LTE, all your data is sent and received in IP packets. IP packets are like boxes in which your movies, music, emails, and phone calls are going to travel. Beginning of a technological journey that will take your data from your phone, carefully sorted out in their packets, to an eNode B radio base station. Then a huge transport network made of microwave links, fiber, and IP routers sends your data from the antennas and eNode B radio base stations to the gateway, a system made out of several levels. The serving gateway routes and pushes your data packet forward on its journey. It's the frontier of the packet port, maintaining the connection between your phone and the IP network while you're moving freely around. Now, receiving the packets, the packet data network gateway looks at the destination of those packets, then sorts and sends your data onto the right tracks. It is the crossroad of every kind of traffic, no matter what the source of the technology. While all this data is processed, the policy management counts your data packets and applies policy rules for your personal subscription plan. Quite a bit of travel, huh? And it has yet to go to its final destination through the internet and other IP networks. And here we are, safely arrived to its destination. How easy was that? Considering the numerous benefits that you will feel using LTE networks. Improved browsing and online experience thanks to lower latency and no unwanted delays. Better app coverage, that is, better performance of multimedia applications through higher upload and download speeds. Enhanced voice communication with higher voice quality and shorter call establishment time. Naturally, LTE is also compatible with the existing telecom infrastructure and ecosystem. So, are you ready to join the journey?
Okay. This is regarding architecture, the hardware point of view. So there is no difference between LTE and LTE advanced. So same nodes are available. So there is no difference. So that's why I have given a one video for this is a quiz. Due to lack of time, I'm not going to play. So these are the benefit. These are the benefit. So yeah, now please let me. If you have any query, please let me know.
Sir, I am Ajay Kaswan. Before finishing, please explain COMP.
COMP basically, Kaswan sir, your user equipment, your mobile phone is communicating with the eNode B.
G.
One BTS it is a communicating, but in COMP in packet network, your handset is able to communicate simultaneously with the more than one BTS, one eNode.
Agreed.
So this is a known as a comp in both direction, transmission as well as reception. So how we can do this thing? So we can do this thing because in packet there are a scheduling. So
Yes.
from one e-node B, one packet is coming, other e-node B, second packet is coming, from other third e-node B, third packet is coming, like that. But the your handset should support and network also should support.
सर मेरा जो क्वेश्चन है इसमें means one handset is getting 3 frequency that 2 of adjacent channels, adjacent cells. Then there will be problem of adjacent channel interference. How that is avoided?
For interference, there is not much interference in LTE because we are using different concept. Same is different frequency.
Agreed. Because of orthogonality will avoid.
Come again?
Because of orthogonality of CDM of those boards.
Yes.
Thank you.
So, for exam point of view, you should remember only this. The comp it's supporting a LT advanced, but in practically it will take time. Okay.
Basically, from exam point of view, every topic is okay, but syllabus becomes so vast, na? From where he will ask question whether easy or difficult, it's very difficult to guess. So one has to go deep, very deep in every topic.
Yes. I have seen. That's why I'm not filling this paper. I'm not going to write this paper.
Arey, sir. But your presentation is wonderful. The best of this 5 to 9 session.
Thank you, sir. Thank you. But I'm not comfortable with online.
Okay, whether you are comfortable or not, we learned a lot. I think most of people are agreeing with me.
Okay, sir. Any query?
I have shared my number with you. I have shared my number with you on personal chat. If you are comfortable, please share your number. In case of any query, I will ask you.
Oh, yes, definitely. My number, WhatsApp number is 94127.
Yes.
39333. This is my WhatsApp number, and my mail you can also write. If you have any query, please feel free to ask.
Yes, sir.
Feel free to ask. My mail ID is rajeshbsnl@gmail.com.
Thank you very much.
Any query, sir? Any query? Time
Sir,
is.
can you share Google Sheet, sir, for presentation PPT, sir?
Okay, I will give this presentation to coordinator. They will say.
Yes, Rajesh, I will send all 4 presentation of today session of mobile communication.
Okay,
so
sir.
definitely it is useful for all participants as well as the others participants also. So there is no problem.
Sir, kindly give me your link, sir.
Sir, Abhay sir.
In chat.
Yes.
In chat.
Yes.
Please also share the link of video.
Okay, no problem.
1, 2, 3 video I have shown. So please share these also.
Yes, definitely, Rajesh.
Otherwise,
Sir,
yes.
चैट बॉक्स में सर ये आप गूगल शीट का सर लिंक दे सकते हैं क्या, या लिंक जो ये मतलब.
Don't worry, sir. The presentation with you, sir. There is no issue to share with you.
Yes, we will share the all presentation as well as the videos as well as link of the this Google Drive also, right? And it is really wonderful session taken by Rajesh. Ultimate presentation and very vastly explain each and everything of LT and LT Advanced. Definitely, it is very useful for all the participants. And previous session is taken by our GM Rajesh Dayal sir. So it is also covered the release up to release 17 for 3GPP, and it is also very useful for exam point of view, especially for exam point of view. So please see all the videos and presentation of mobile faculty of LTTC, and definitely it is useful for all participants. If in future, if any doubts and any queries, please send your WhatsApp, send your message on WhatsApp, and chat box. So definitely we will take care of next week also. Right? Thank you. Thank you, Rajesh.
It
Okay,
was a
sir.
wonderful session.
Okay, okay, sir. Okay. Okay. Thank you, everybody. Thank you. Thank you. Thank you. Thank you, sir. Thank you. And I'm writing my WhatsApp number in chat box 941273933. And my mail ID is rajeshbsnl@gmail.com. Regarding mobile, if you require any material, please let me know. Otherwise, my suggestion is that whatever material is uploaded by BSNL headquarters, follow those material only. There is no need to go here and there. Only follow those material. That is a
No,
Bible
sir.
for you.
No, Rajesh sir.
Yeah.
Because I have seen that examination of that exam paper of electrical and civil for common paper.
Okay.
The questions were outside from the content shared at training portal.
Oh, okay, sir. Okay. Okay. Okay, sir. Okay. Okay. Thank you, sir. Thank you, everybody. I'm going to close this meeting. Thank you. Thank you very much, sir.
I am sharing paper with you, that that civil paper on your WhatsApp number right now.
Okay,
Go through it once.
Okay, sir. Okay. Okay. Thank you. Thank you. Thank you, everybody.
Okay, bye.
अभी और किसी की क्लास है सर? सर के यादव बोल रहा हूँ सर।
लगवा दो यादव जी, लगवा दो या कल लगवा दो।
अब सर आज तक का ही शेड्यूल था ना।
अच्छा, ये जो अभी बताया है सर ने, वो हमें लिंक कहाँ, गूगल ड्राइव का लिंक कहाँ शेयर कर रहे हैं आप?
ड्राइव लिंक का मैंने शेयर किया, जो डेली कर रहा हूँ। एक ही ड्राइव लिंक है, रोज बदल नहीं रही, जो आपका मटेरियल वाला
ठीक
है।
है,
ठीक है ना,
ठीक है,
वही
ठीक है।
ड्राइव लिंक आएंगे, उसी में जो जो मटेरियल हम उसको अपलोड करते जाएंगे। कल भी जो मिलेगा उसको भी हम करेंगे। ठीक है ना।
राइट।
और भी कुछ सजेशन आया उसको भी मैं अपडेट कर दूंगा, तो आप उसको रखे रहिए सेफ। ठीक
सर
है।
मटेरियल वाला एक बार मटेरियल लिंक सर बताएंगे क्या? चैट में डाल देंगे?
मैं दोबारा से डाल देता हूँ अभी बिफोर एंडिंग करने से मैच। ठीक है, जरा होल्ड
ओके
करिए।
सर, ओके सर, डाल दो सर।
इसके बाद वो फिर तो हट जाएगा ना। एक मिनट होल्ड रखिए, मैं डालता हूँ। एक मिनट आपका ये
सर जी रिलीव करोगे क्या?
सर क्लास इंचार्ज साहब आपको बताएंगे। रिलीव तो इससे उनको किया जाएगा ना जो रिलीव हुए हैं।
अरे तो हम लोग रिलीव हुए हैं तभी तो बोल रहे हैं।
तो ठीक है, फिर रिलीव है तो जो भी है वो बताएंगे आपको। कुमार साहब हैं जो भी हैं इंचार्ज। ये पहले मैं ड्राइव शेयर कर देता हूँ एक।
राइट राइट।
जल्दी क्या है सिंह साहब, जल्दी क्या, जब रिलीव होगे तब ज्वाइन करना। काहे कह रहे हो रिलीव होने के लिए?
अरे नहीं, ऑफिस वाले पीछे
हमने
पड़े हुए हैं।
लिंक शेयर कर दिया है। ठीक है, इसको क्लिक कर लीजिए, फिर मैं मीटिंग को एंड करूंगा। मिल गया सभी को?
ओके
यही
सर, ओके।
ड्राइव है, इसके अंदर जो भी कुछ अपडेट होगा टाइम टू टाइम अपडेट कर दिया जाएगा। ठीक है, थैंक यू, थैंक यू। थैंक यू, थैंक यू।